Hi there, welcome to Simplilearn's YouTube channel. Today we bring you the SQL Full Course. SQL, or Structured Query Language, is the backbone of data storage, retrieval, and analysis. Whether you're a developer, analyst, or aspiring data professional, mastering SQL is essential for working with databases effectively. In this free course, you will learn everything from basics to querying data to writing advanced queries, joining multiple tables, and building real-world database solutions. We will also cover techniques used in projects and prepare you for interview scenarios to help you land in your next data role. By the end of this course, you will be able to confidently extract insights, manipulate data, and create efficient SQL queries for any database systems. Now let's go through the agenda. This course covers introduction and basics of SQL, where we will understand databases, tables, and some simple queries. Followed by that, we will have data filtering and aggregation, where we will explore where clause, group by clause, order by clause, and some aggregate functions. Followed by that, we have joins and relationships, where we will explore joins like inner join, left, right, fill join, and we will also combine some tables. Next ahead, we have subqueries and nested queries, where we will be using queries within queries for advanced data retrieval. Then we have common table expressions, or CTEs for short, and window functions, where we will be simplifying complex queries for data. Then we have manipulation and transactions, where we will explore insert, update, delete, and transaction control. Next ahead, we have a hands-on project where we will be building a mini database and solve real-world problems. Then we have SQL interview questions and tips. So here we will practice common queries and patterns asked in interviews. That said, if these are the type of videos you'd like to watch, then hit that like and subscribe buttons along with the bell to get notified whenever we host. Now, let's get started with a small quiz question. So here's the question. Which SQL clause is used to combine rows from two or more tables based on a common related column? Your options are A, where, B, join, C, group by, and D, the last one, order by. Please do let us know your answers in the comment section below. Now, let's get started. Now we enter the module 1. So the module 1 will be about the introduction to SQL and database basics. So what is SQL is our first question, and why is it important? So today, SQL in simple terms, or let's expand as structured query language, is the standard language used to store, manage, and retrieve data from relational databases. In very simple terms, SQL acts as a communication layer between humans and databases. Instead of manually browsing data through files or spreadsheets, SQL allows us to ask precise questions to the large data systems and receive accurate answers almost instantly. You can think of SQL as the grammar of data, because just like grammar helps us form meaningful sentences, SQL helps us form meaningful data queries. So through SQL, we instruct databases to perform critical operations such as searching for specific information, updating existing records, inserting new data into the entries, deleting or removing outdated data, and organizing information using tables, views, and schemas. Without SQL, interacting with structured data at a scale would be slow, manual, and completely error-prone sometimes. Now, why is it important? SQL turns raw data storage into an intelligent, queryable system that businesses completely rely on. Now, you might be wondering why SQL still dominates in 2026 despite hundreds of new technologies and tools and frameworks emerging every single year. So the answer is, SQL continues to dominate the data ecosystem in 2026 and in future, because this is not by accident. Because SQL solves a fundamental problem. Reliable access to structured business data, universal adoption. Every major organization, whether it's Google, Amazon, Meta, banks, hospitals, or e-commerce platforms, they rely on SQL-powered databases at their core. Even modern cloud-native systems ultimately store their most critical data in relational databases using SQL, and they also query that data using SQL. Next is standardized language. SQL allows ANSI standards, which means once you learn SQL, the same knowledge applies to MySQL, PostgreSQL, SQL Server, Oracle, Snowflake, BigQuery, Redshift, and many others. This portability makes SQL a career-safe skill that remains relevant across tools and companies. Next is essential for analytics and AI pipelines. In analytics and AI workflows, SQL is often the very first step. Before any dashboard, machine learning model, or AI system is built, SQL is used to extract clean, structured, and reliable data. In many ways, SQL is the foundation layer for data-driven intelligence. After that, we have high performance with massive data. Modern SQL engines are highly optimized and can process millions or even billions of rows of data in just mere seconds. Features like indexing, query optimization, and parallel execution make SQL extremely efficient for large-scale data operations. Now, the next question is, where do you see SQL in real life? Although users rarely see SQL directly, it silently powers many everyday systems we interact with. Whether you book a flight, withdraw some cash from ATM, place an online order, or check your bank statement, SQL queries are running behind the scenes. SQL also supports food delivery applications, telecom recharge history, hospital records, and customer support systems. Each of these systems rely on fast, accurate retrieval of structured data, which SQL excels at. A useful real-life analogy is to think of SQL as a remote control for business data. Successful learners who master SQL gain the ability to instantly switch to exact channel of information they need, whether it's sales data, customer retention, or customer records or transactional history, without delay or dependency on others. So the next one is types of databases. So we have two types, relational databases or RDBMS and non-relational ones. Let's get started with RDBMS. A relational database stores data in tables made up of rows and columns, similar to Excel spreadsheets, but with far more structure, rules, and reliability. Each table represents a specific entity and relationships between tables are clearly defined. Relational databases enforce consistency through constraints and relationships, ensuring that data remains accurate and reliable even as systems scale. They follow ACID, or popularly known as asset properties, which guarantee transaction safety, making them ideal for business critical operations. Since relational databases are SQL based, they allow precise querying and strong validation and predictable behavior. Most popular examples include MySQL, PostgreSQL, SQL Server, Oracle, and MariaDB, all of which are widely used in enterprise systems. Now let's discuss the second type, which is non-relational databases, or simply known as NoSQL. Non-relational databases, commonly known as NoSQL databases, store data in formats designed for flexibility, scalability, and speed rather than strict structure. Instead of fixed tables, they often use JSON documents, key value pairs, columns, or graphs. These databases are designed to handle large volumes of semi-structured or unstructured data and are commonly used in microservices, IoT platforms, real-time applications, and distributed systems. Some of the popular examples include MongoDB for document storage, Redis for key value access, Cassandra for column-based storage, and Neo4j for graph-based relationships. NoSQL systems trade strict consistency for flexibility and scalability in many use cases. Now, in the next stage, let's discuss the basic fundamental differences between relational and non-relational database systems. So, relational versus non-relational analytical comparison. Relational databases focus on structured data, predefined schemas, and strong consistency. They are ideal for transactional systems, reporting, and business logic where accuracy is critical. SQL serves as a powerful and standardized query language in this ecosystem. Non-relational databases, on the other hand, prioritize flexibility, horizontal scaling, and high-speed access. They allow schema changes without downtime and are better suited for rapidly evolving data models. A strong analogy is to think of RDBMS as a well-organized library where every book has a catalog number and fixed location. NoSQL is more like a creative studio where items can be placed freely, based on immediate needs without any rigid structure. So what is RDBMS? A relational database management system is specialized software designed to store structured data and manage relationships between different data entities. It acts as an engine that processes SQL commands and ensures data remains consistent and secure. An RDBMS is responsible for enforcing rules, managing user access, and handling backups, recovering from failures, and even ensuring that multiple users can work with the same data simultaneously without any conflicts. In short, the RDBMS is the backbone that makes SQL reliable, scalable, and safe for enterprise use. Tables represent real-world entities such as customers, products, or orders. Each table focuses on a single concept, keeping data organized and easy to manage. Next is columns. Columns define the attributes of an entity such as name, email, or city. Each column has a specific data type and rule set that governs what value it can store. Rows. Rows represent individual records within the table. Each row captures a complete instance of an entity, such as a single customer or transaction. Next is the primary key. Primary key uniquely identifies each row in a table, ensuring no duplicates exist and enabling efficient data retrieval. Foreign keys create relationships between tables by linking related records, helping maintain consistency across the database. Next is indexes. Indexes function like a book index, allowing the database to locate data quickly without scanning every row. Followed by that, we have constraints. Constraints enforce data quality rules such as not null, unique, and check. These rules help preventing invalid data entry entering into the system. Now, the next stage is why RDBMS is the industry standard. RDBMS systems are highly reliable and trusted for business operations that cannot afford data errors. They enforce data integrity, support normalization, and handle complex transaction workflows efficiently. Because of these strengths, companies use RDBMS platforms for mission critical applications like billing systems, HRMS, ERP solutions, inventory management, and logistic platforms. When accuracy, consistency, and reliability matter, RDBMS remains the preferred choice. Now comes the next stage where we will learn the installation and setting up SQL environment. So now we have come to a stage where we will install MySQL into the system. Now it's really simple. All you need to do is just type down MySQL Workbench on your browser, and then you'll be redirected to this particular page. Use the first link, MySQL Workbench, or you can also go with the download option. And here you have the download now option, right? So you can click on this and your installation file or the setup file will be downloaded for you. And you just have to run that particular file. It's a simple installation procedure. But if you have any queries, don't worry. I'll also drop a link to this particular tutorial on how to install and run MySQL Workbench. For now, we have already installed MySQL. So let me run that. So this is my database, which is SLP database. So you can see on the right hand corner of my screen, we have an option that says the position of all the prompts and all the sections of this particular workbench. So I'll go with the first option where I can see all the databases I have and the tables I have, right? So right now we are in the table that we earlier created for interview questions and answers. So this will be down the line. So let's go to any of the databases. I would like to go with this particular one, sample dataset. So I'll be using the SLP database. So we can test our SQL database in this way. You can start by selecting any of the databases. Don't worry, in the upcoming section or the upcoming module, I'll explain you how to load the data, how to create table, how to insert the values into your table, and all those fundamental things. So first, for the beginning section, to test our SQL installation, we'll do this. So before you get into anything, you just need to select the database where you have the data. So you can do that by simple command which says use the database name. This is the font. So let's say use and database name. And you need to have a semicolon, right? So you can also see why I'm using specific format. I'm using, let me expand my screen. I'm using all caps for the keywords. In SQL, we have keywords and also the user-defined words, right? So the keywords are something which carry a functionality. So here, if you see, we have a select, from, where, not in, right? These are keywords. They have specific functionality. And whatever the things you see in a black color, which have, case sensitivity in lowercase or sentence case, those are the ones which I define. So tomorrow, if my query gets a little more complex, so down the line, we will be learning subqueries and advanced querying functions, where we should be at a stage where we should identify our own code. If you follow or some mixed kind of way to write your queries, then you might fall into a confusion understanding what is what. Is it a keyword, or is it a word that I define, or is it the name of the column, or anything, the name of a table which I define? So to avoid such confusions, we will follow this standard. If ever there is a keyword, just keep it in all caps. And if ever there is a column name or a table name, then you can keep it in mixed case or low case as per your requirements. So product ID, this particular name is a column name, so that I identify it as a column name, I'm using mixed case there. So it has a caps thing, and then the all small letters in that way. So basically, you need to select a database name and explain MySQL workbench that I'm going to dive into this particular database, which is SLP. And you can see I have complete access here. So if I expand this particular section, you can see SQL gave me a green to go, and then I can also check what are the tables present in my database. So for that, you will be using show tables, control enter, and these are the tables which I have: bonus, book collection, book order, clone, consolidated student information, employee details, etc. So now, if I want to understand employee details, what I'll do is copy this row, copy field, and then I'll simply write down a select statement, right? We will also understand what exactly does select from, and every aspect, every syntax of the statements in the upcoming module. For now, we are just testing the condition of the installation that we have done. So for that, so I'll be writing down select. So you can see when I type, you can see some auto suggestions, but don't take any auto suggestions. Follow a strict format for yourself. So select star, which means all the columns. So maybe I'll be having 5 columns, 6 columns in this particular data set or data table. When I indicate star, automatically MySQL Workbench will understand that user wants to query or extract all the columns from the table. If I dedicatedly provide, let's try that as well. So from, and remember the field that we copied, just paste it and remove the single quotes. And at the end, yeah, without semicolon, your query will run. But to follow a strict syntax, we need to enter semicolon. Now, let's hit enter to find out the entries in our data set. So we have 5 columns. You can see we have employee ID, employee name, age, department, and salary. So now, let's say I just want the employee name and their department. In that case, what I can do is quickly copy this and paste it somewhere here. And instead of star, I will write the dedicated column name, EMP name, comma. If your intention is to extract specific columns, then you need to specify them and separate them using a comma. Now I want employee name and department, so I'll write EMP name column, comma, separated, both are separated by comma, and department, right? So let me run this and I'll have, okay, there was some error. Copy field name and I'll paste it here. Yeah, I think that was a small spelling mistake, not to worry. Enter. There you go. So we have John Doe and all the other employees, Jane Smith and Michael Johnson, and their specific departments. Now let us understand something a little more detailed. Let's say the user wants to extract specific employees from IT department. How do we do that? We do that by adding a where clause. So these are clauses, don't worry. We're just testing it out. In the upcoming module, we will be going deep diving into each and every part of this. So where our department is IT. So since this is a character data type, it will be inside quotes. So IT semicolon. Remove the semicolon and everything is good to go. Enter. and we will have the details of all the employees who are in IT department. So this is how a basic query on a MySQL Workbench works. Now we have a briefing on the understandability and working functionalities of the MySQL Workbench. Proceeding ahead, we have the choice of SQL engine for learning purposes. So MySQL and PostgreSQL both are excellent choices. MySQL is known for simplicity and ease of use, making it ideal for beginners and web applications. On the other hand, PostgreSQL offers more advanced features and widely used in analytics and data engineering roles. Both databases are open sources, stable and production ready, making them perfect environments for learning SQL fundamentals. Now we have common installation issues and fixes. Beginners often face issues like port conflicts, authentication mismatches, or missing environment values. So these will be the common issues that you might be facing during the installation process. Don't worry, we will be linking the complete installation and setup video in the description box below. You can go through that, and it will have all the mistakes and all the possibilities of creating mistakes and all the permutations and combinations of the problems that you might be facing in real-time installation. It's a completely detailed tutorial, so it might take a lot of time of this particular session. So for that purposes, we have created a dedicated tutorial for installation. So we will be linking that. Now, why these issues come? Because you might be having Jupyter Notebook or any other platform that deals with databases like MySQL as well. So you might have to dedicatedly create a port for their access. So if there is a port conflict or any kind of authentication mismatch, you might face these. So you have that all covered in that session. Understanding these errors early prevents frustration and builds troubleshooting confidence. Addressing problems such as 3306, which is a port number conflict, or PG admin setup, which is for PostgreSQL failures, helps learners become self-sufficient and comfortable with database tools. Now let's go through best practices for beginners. So some of the best practices are: you should learn always to create a dedicated practice database to avoid accidental data loss. Using meaningful table name and column names improve readability and long-term understanding. Backing up data before experiments and maintaining a personal SQL notes file helps reinforce learning and builds good habits from the start. And that brings us to the end of module 1, and next will be the module 2. So now we have entered module number 2. So this module number 2 gives us a brief introduction to the basic commands in SQL. So this is all about how to create a table, how to insert data into a table, and then when you start querying, how do you query, right? For a basic example, you have select. So select in SQL means you're trying to explain the SQL workbench that you want to select something from a table that you just created. So there might be many number of tables. For this sample execution, we're going to create 5 tables, and you must specify which table are you focusing on, right? So for that, you might have to give SQL table name along with the select statement. And then what do you want to select? You want to select a specific column or all the columns available. So there are again specific ways to select the columns again. If you want any particular column from the table, you need to specify the column name. Or if you want to extract all the tables, and you don't have to write all the column names, you just write an asterisk and then all the values will be extracted for you. And if you want to filter out, let's say there is a condition where you want to filter out all the employee details where department is equals to HR, then you will go ahead with one filter query, which is where, right? That particular where is a clause in SQL. So this can help you understand how simple SQL is. It's just a verbal language. You talk to your database and you'll get the queries. It's as simple as that, right? This is what makes SQL so exciting, so resilient, so reliable, and so relevant to the current IT standards and industry standards wherever data is related to it. So now without further delay, let's start by creating a simple table, right? So now you can see on my screen, we might have to use the database first. I have already created a database on the name interview, and this particular database will be used by us in upcoming modules, maybe 2 or 3 times for interview questions and answers and joins. And for now, we are just working on the basic terms of creating and filtering data and extracting data insights. So I'll be using this particular dataset. And if you want to create a new dataset, it's really simple. You go to File, and here you create a new model, and then you add the names to your model and all those things. Or you can also go ahead with this particular option, create a new schema, and then you name your schema as sample schema test now, and then you can choose a default location and all those default things for yourself, and then apply. And then you create a schema if you want, apply and finish. For now, I don't want to create this one, so I'll just close it. And once you create the schema, everything is straightforward, like we are going ahead with now. So once you create a database, you need to remember the database schema name. So now I've created this particular interview schema. So to begin with adding any of the tables or adding any of the data entries, I need to specify the database I'm using. So you can see on the left hand side, we have a lot of data schemas. We have car dealership, credit card data, interview, sample store, right? This is the one sample schema test that we recently created, right? You can drop this schema, drop now. So we have removed it. That's the way you delete a schema if you want. Okay, let's take it as a learning step in case if in future if you wanted to delete any schema. So now I want to get the access to interview schema, or the one which I created already. So how do I get access to it? Again, SQL is really simple. You just need to write down use schema name, which is interview. Done. Semicolon. Now SQL understands, yeah, user wants me to use this particular schema on the name interview. So let me expand this so that you can see it better. I hope the code is visible clearer. So now you can select the entire query and use this particular flash logo to execute, or the best way I use is hold control and press enter. That is the best way or a shortcut to select the database. Now comes the next step where you want to create a database. So again, let me tell you this. So we have linked this particular code document in the description box below. You can open up the code document and follow along with us so that you have a better learning experience. And I've also saved this particular code documentation on a notepad for quick access. But before going with the quick access, let us manually type the table names and enter the data or the insert commands so that we have a decent understanding. Let's go back. So the first table that we will be creating is departments. Now you can see this particular double code, right? If you have programming background, then you might have something called naming conventions or tagging or quoting, right? It will not be executed in real time, but it will act as a note or a sticky note that you leave on your code so any of your fellow developer understands what's happening here. So I'm using these double hyphens here as a quote so that my fellow developer will understand that I'm creating a data table which is named as depart. So the simple command for this is create. So you want to create something, so you just write create. What do you want to create? I want to create a table, right? So you can see that whenever we write something, we are using, or I'm using, a separate naming convention, right? So here you can see I used uppercase for the keyword use. So anything which is getting highlighted as in a blue color is a keyword. A keyword has a dedicated meaning and it cannot be used for normal purposes. It can be used only for SQL purposes only, to make SQL understand what is your step or what is your intention. So use uppercase for all the keywords and use mixed case or sentence case or lowercase preferably for your names, right? For the table names, for the column names, for the row entries, or anything which is from your end. Basically anything which you are giving, the users which you are giving to SQL should be in lowercase so that you can differentiate. For now, we are just trying to write 2 or 3 lines of code, 2 or 3 lines of query. That is easily understandable. But in future, you will be writing subqueries, you will be writing joins and a lot of more complicated queries where at least you'll be writing 10 to 12 lines of code. In that particular scenario, you must be capable to understand which is a keyword and which is a user defined word or a name or a column name, right? So a metadata basically. So that's the naming convention you should be following. So understand what's the difference between a keyword and what's actually the name that you have given to your column name or a table name, which is basically user defined. So you can take it in programming terms, which is user defined, which is internal implicit design, right? Implicit function. So I want to create a table. So write create table. And what's the table name? So my table name is departments. So this is my table name. So what do I have inside my table is my next question. So inside my table, I want to have a couple of columns. Let's say 2 columns, department name and department ID. So for that, I need to write down DPT ID and data type is integer. I want to provide integer data type for it. So basically, before we continue, let me tell you something. So whenever you want to add columns, you need to add column name. Okay, let me comment this. Column name along with its data type. So this is a set. So whenever you try to enter a column name, you should follow this particular approach where SQL understands this is a, it's a combination. It's an entity which is made of 2 things, name of the column and what's its data type, right? So this is the naming convention that you should be following. So I want department ID as the first column and the next column is department name, right? So for this particular department name, I want to go ahead with varchar, and varchar is also another data type. And for that data type, you can allocate number of locations to save that particular department name. So for a basic request, I think I'd like to go with 50 character spaces, and that should be good enough for writing my department names. And then you can close the command and write a semicolon to end the query. So your query will run without a semicolon, but for safer programming practices, consider it as a protocol so that you or any other developer who is reading your commands will understand that it is the position where this particular query ends. So use a semicolon for that. This is pretty good, but remember, we might have to work on joins in the future modules. So joins is nothing different from the VLOOKUPs or the relationships or the data modules that you have seen on Power BI, Excel, etc. Basically, you're combining 2 or 3 different tables together. Let's say you are ordering something from your online websites, and for getting that particular product to your location, you're providing your address, phone number, and all the details, right? So in a similar way, when you want to access data from a different table, you might have to establish a connection between them. So to establish a connection between the 2 tables, you might want something called as a primary key and a foreign key. So primary key and a foreign key act as phone numbers or an address location, or basically something which establishes a relationship between them. So now this particular thing you need to understand. A primary table in one table is the one which connects with the same primary key in another table. But in the other table, it is termed as a foreign key. In my table, department ID would be the primary key. It will be unique and it will not be null. And this particular department ID can also be another table. It can also be unique. It can also be not null, and it will not be empty. But in that particular table, it will be termed as foreign key. The same primary key in a different table is termed as foreign key, but the same primary key in the dedicated table is termed as a primary key. So now I want to term my department ID as the primary key in my table. For that, you just need to write one more sentence here, not even a sentence, one more word. You just need to specify primary key, and that's done. So primary key and done. Now what happens is SQL will understand you want to create a table and the table name is departments, and you have 1 department ID column, 2 department name column, and the data type for department ID is integer and the data type for department name is varchar, and you have provided 50 spaces or 50 data spaces or addresses for you naming your department name, right? And out of which department ID is the primary key. So these are the details that you have given to your SQL workbench, and you should be ready to create a new table. So now let's head back to the notepad where we had created the code. This is the one. So create table departments ID is equals to int primary key, department name is work 50 locations and semicolon. So only difference is there are some indentations done. So what is an indentation? Just like any other programming, you also provide dedicated spaces, new lines, so that the fellow developer understands where is what. So this is the indentation we have followed here. We are creating a new table, departments, and the first column is department ID. It is an integer data type and it's considered as the primary key. The next column is department name. Its data type is varchar, which is a character data type. We have provided 50 spaces and then end of the command. Right? Now comes the insert command. Now, again, similar to table creation, inserting data into a table is also simple and easy. So all you need to do is specify the operation that you want to do. It is insert. I want to insert data, but into which table? So I want to insert into table which is departments that we recently created. You can simply copy and paste the departments table name here. And what are the department columns you have? So I have two columns there. I'll take department ID and department name. And now these are the values I want to insert. What are the values? So again, comma separated values. The first is ID, so you don't have to write any quotes. But the second one is varchar, so character data types must be specified in single quotes. So this is the first entry, comma separated values. The second one is number 2, comma, single quotes, and what's the next one? Maybe engineering, and again a comma separate. And third team could be finance, separate by comma. Fourth team can be marketing. So I don't have any further rows here. So what I can do is I can close this particular indentation. And write a semicolon to explain the end of this particular query. So now, similarly, you can just execute this and add the values. So let's head back to the notepad. So here you go. So this is a similar approach what we have mentioned here on my MySQL workbench. You can follow this indentation so that you are clearer. And you can just simply run the query. I'll use Control Enter, and these values are entered into your table. Now I want to extract what are the values that I have entered into my table, or I want to just cross verify if I have entered all the values or if the values that I have given are properly inserted or not. So for that, you want to select. So as we discussed, there are multiple ways to extract data. You can just specify the column names from which table. The table is departments, or you can specify dedicated column names. Let's say I want to only extract the department name or department ID. You can also do that. Or another approach for the same code is this one. You don't have to specifically mention the column names. You can just write down an asterisk and it will still execute the same. So let's try all these 4 commands. You have your data here, and the same works for this one as well. Now let's say I want to select only a dedicated column. So these are your department IDs and dedicated department names. This is your department name. And now if we drill down further, let's say I want to extract the details for only HR team. So this is where the where clause comes into the picture. So extract or select department name where. So this is basic fundamental queries that I'm really writing right now so that you understand how it actually works in the background. So you understand the workflow of it. So where department ID is equals to Let's run this. Department ID 4. So 4 is marketing. So department ID is equals to 4. So what happens is SQL selects the department name column altogether. The entire department column is selected. First, it will go to the departments table itself. It has two columns. One is department ID and a department name. You can see it right here, right? So this particular entire table is selected by SQL, and then it reads what are the columns I need to select. So we are dedicatedly specifying just one column, which is department name. This particular column will be selected in the second phase. The third phase is where it applies the filter for department ID. Now, again, it goes to department ID and it checks individual department numbers. So it will go for the department ID where it matches with number 4, and then adjacent to it is marketing, right? This is what we are trying to extract. SQL has understood this and it will give us the marketing team name. So this is how the query works in the background. Now that we have a basic understanding of how the fundamental keywords in SQL, which are select, from, where, filtering things, right? Basically how to create a table, how to insert values inside a table, and how to query them. Now we will proceed and add a few more tables onto our MySQL workbench so that we can get continued with further queries like some aggregate functions like average, sum, etc. So let's not waste much time. Let's go back to the query window where we have all the table details and copy them and simply write them. So let me copy the entire 3, 4, 5 tables and paste it on the SQL workbench here. I'll minimize this a little so that we have a better view. There you go. So this is our second table, which is employees table. Now, before we create the table, let me explain you a few things. So we have about 5 tables. One is departments, second is employees, third one is users, fourth one is orders, and fifth one is sales. In the terms of data analytics, in the terms of business analytics, we deem these tables as two parts. The first one is fact tables and the second one is dimension tables. So what are fact tables and dimension tables? We will deep dive into these in the next upcoming modules. So basically, it's nothing but relationships between the tables. So there will be one table which is related to all other tables in the database, right? So in this particular scenario, the employees table is a fact table, and employee is the one which works in your company. Let's say you have an online store and you have a list of employees, and these employees are the ones which receive orders from the users, and they fetch your inventory, pack that order and send it to the users, right? So employee table is the fact table which is related to the orders table, which is related to the users table, which is related to the inventory table, which is related to the department table, right? It connects to all the tables. And on the other hand, the dimension tables, these are related to your fact table based on one foreign key, right? You will be having employee ID, right? This particular employee ID will be the primary key of your data table, and somewhere or the other, the employee table will dedicatedly have a department value, department ID, right? It will have the order values, the order ID, it will have the sales ID, right? All these entries will be in the fact table, and all these entries will be the primary keys of all the dimension values, right? The dimension tables. These values will connect to the fact tables. So it will be a little confusing now, but when we enter into the data modeling module, there you will have a clearer understanding. For now, let's understand one thing. You just have different types of tables. One is fact table, one is dimension table. Fact table is really important because fact table acts as the mother of all the other tables, and all the other tables are connected to fact table. If you delete the fact table, then there is no way you're going to perform the analytics in future, right? It is like the root. Just understand that basic thing. Now let's continue with table creation. So now let's head back to table number 2, which is our fact table here, or let me tag it as the fact table for reference. Now the same pattern again. We want to create a table. So create command, table command, provide a name to your table, which is employee. And here we have 1, 2, 3, 4, 5, 6 columns. We have employee ID, we have employee name, we have salary, we have department ID, on which date was he or she hired, and the department ID, right? So here we are dedicatedly specifying that department ID is a foreign key which relates this particular fact table to the departments table, and we are referencing this, right? So references is the keyword which helps SQL identify that you are trying to connect this particular employee data with the department data, right? So we have about 5 columns here: employee ID, name, salary, department ID, and hire date. And if you are trying to get this connected with another dimension table, then this particular command where it says we are trying to use department ID as a foreign key, which happens to be the primary key of a dimension table, which is the table name, departments, and in that particular table name, the column name is department ID. It is named as department ID. So please go to the departments table, refer to the department ID column, and then match the entries of department ID from employees table to the department table. So this is how it works. Now let's click the flash logo, or I'll go with my shortcut Control Enter, and we have successfully created the employees table. And similar to the previous approach, you need to specify the keyword insert. I want to perform an insert operation, and I want to insert these elements into is another keyword, and you need to provide the table name, which is employee. And now what are the columns I have in my table? I have employee ID, I have employee name, I have salary, I have department ID, and hire date. So based on the column names, I need to specify the data entries as well. So you cannot mix and match. You are specifically providing the order in which the entry should be happening. So the order is: first comes the employee ID, second comes the employee name, third comes the salary, fourth comes department ID, and fifth is the hire data. In the same fashion, your entries should also be matched. So first, the employee ID is 1, the name is Alice, the salary is 90,000, department ID is 2, so she belongs to department whose ID is 2, right? If we go back to department here and execute this, so we will be having engineering in the department ID 2. So Alice belongs to engineering department, and then comes the hire date, which is this one, right? So you need to specify the data type. So here I have specifically provided the data type as date for hire date. In the same fashion, rest of the employees, employee ID 2, 3, 4, 5, 6, 7, and 8, 9, and 10 are added, right? And deliberately we're also adding some null values here. So you'll understand why we are adding null values, because in future we will be performing some join operations in the upcoming modules where we will try to filter out the employees whose department is not yet allocated. We are considering these employees are new or fresh hires, so they are on bench period and they are not aligned or assigned to any projects as of now. So they are having their department ID as null. So we'll be performing such operations. For now, just try to, here I think I've marked it, no department, right? So for now, just try to create a table and add data. So now your fundamental job to do is you need to understand how to create a new schema, which I've explained before. Go to the schema table here, create new schema, and write a name to your schema, and then apply it to create a new schema, which happens to be a dimension table, and this will be related to the fact table, which is our employees table, right? And here I'll be having user ID, email of the user, and at what time was the account created at timestamp, right? Now Control Enter, and we have created this particular users table. And similarly, we will insert the data into users table. So we will be following the same pattern. So we will be inserting into users table, and these are my values. Let me indent it. So proper indentation will help you understand how your tables are organized. So you can follow this. It might take a little time, but in future it will definitely save a lot of your time entering or making mistakes, right? So this is a good practice or best practice. Now I have about 10 users in my database. And then this is the end of the query. So here you can see I've also tagged as duplicate email entry. So this will be another learning experience for us, where we will try to find out duplicate email entries in our database. Now hit Control Enter. I think we selected employees data table. We were supposed to select users data table. Yeah. Okay, we were supposed to create the data table first. Okay, we have successfully entered the elements into the users table. Now comes our fourth table, which is orders table. Similarly, we have order ID, customer ID, and order date. Control Enter, and we have created the orders table. Let's quickly add all the data into the orders table. You can also follow the same indentation, or if in case if you want to have a particular specific format of indentation, you can also follow that. We have the last table, which is sales table, and similarly let's enter all the data into sales table. Now let's check all the entries or all the tables. The process is simple, like we discussed. Select star from employees. There you go. So these are the employees and their details. And similarly, you can just quickly copy and paste this command and rename this to departments and run a query, and you have all the employees or department details. Similarly, you can copy paste, and then you can use the name of sales, orders, and users. And I'll also have orders, and also I'll have sales. So these are the user details that we have entered, and these are the timestamps when a user account was created, and these are the order details. So these are the orders placed on what detail, on what date, and who was the customer and who was the order ID, and all the details of that. And sales data table, what was the sales ID, on what date was the sale made, and what's the amount they paid, right? So these are the details that we needed. Now let's take a step further and try to extract some details from this particular data set that we have just created. So I'd like to close it here. So far, this is the creation and insert process. Let's comment it. Now let's proceed further, and this would be the querying stage. Now let's try the filtering process. So let's consider we want to filter the details of employees who are earning let's say 90,000 or more. So how do you extract it? Let's take a moment. So far we have a basic understanding of how to insert data, how to select queries, right? And we also went through a sample where statement where we extracted the marketing ID, right? So the department name where marketing or department ID was equals to 2, right? So following the same approach, can you devise a quick query? Yes, I think you already have a rough template on your mind, but it's okay if you don't have it. So let's get started with it. So as we discussed before, SQL is really simple. All you need to do is just explain SQL in very simple terms. I want to select. Select what I want to select. I want to select employee name, or I want to select everything from employee, where from employee. Let me copy the employee name to save time. This is the table name. From employees, where salary is greater than a rough number 90,000. So before that, let's run this query and see. We have Alice, we have Bob, we have David, we have Eve, we have Heidi, and we have So there are a few employees who are drawing salary greater than 90,000. Let's say it as greater than or equal to 90,000. So we must be getting a couple of entries here. So let's quickly run the command, control enter, and there you go. So we have about 1, 2, 3, 4, 5 employees, Bob, Alice, David, even Heidi, who are withdrawing salary which is greater than or equal to 90,000. So this is one of the good filtering examples. Now let's go with a few other queries or filtering queries. So we have HR, we have employees, we have users, we have sales, we have orders. So let's say I want to extract employees who were recruited after February of 2025. So for that, we can use the same query. We can quickly copy and paste it here from employees where join date, right? So I'll execute the select query once again. So I'll copy this particular field name and paste it here is greater than or equal to March. We don't have a March, but we can take the September. We can copy this particular field and paste it here. There you go. So any employee who is hired after September 2025 should be highlighted. Enter, and there you go. We have about a couple of employees who were recruited after this particular date. Or we can also find out less than who are the employees who were recruited before this particular date. There you go. So only David was the one who was, maybe this can be considered as David is one of the senior most employees in this particular organization. Now, let's proceed further and try the next type of query, which is the sorting data. Now, I want to sort the employees table. Let's say now I want to identify employees in terms of salary. Who is the employee who is drawing highest salary and who is the employee who is drawing the least salary? I want to order them in decreasing order. So it's really simple. You can use the same query here. Select star from employees and order by salary DESC. So we have two keywords, DESC and ACSC. So ACSC is ascending order, BESC is descending order. So you just need to run this query and we will have salaries of the employees who have highest salary numbers. So we have Bob, David, Heidi, followed by that we have Eve, Alice, etc. And Ivan is the person, maybe he's a fresher, so he's drawing the least intern level salary or the beginner level salary, which is 50,000. And similarly, you can follow another thing here. You might be assuming, can I give two columns here? Yes, you can give two columns. Order by DEPT. So let's go with department ID. So this even works for character data types as well. Department ID ascending and salary descending. So you need to separate this by a simple comma and there you go. Enter. Now what happens is you can organize the department ID in increasing order and organize salary from descending order. So it's just executed for the reason to understand if this particular order by sorting command executes for one or more columns or not. So the reality is it works for one or more columns. So that's the basic understanding. Now we need to understand one more thing, which is filtering out with limits. Let's say I want to find out only one entry which has the highest salary. So in that particular case, what I can do is I can make use of limit command, which limits the number of rows output by one or two, number of, a number, dedicated number. If I just want one entry, I'll have just one entry. In case I want to have top 3 employees, I can provide top 3 as limit 3, and you'll have top 3 rows executed right here for you. So this is where we come across the limit function. And apart from limit, you also have another function which is called as distinct. So the name speaks for itself, unique entries in the row. So for example, let's say I want to find out, let me use the same query, select star from employees, and I'll replace star with distinct department IDs. Okay, field name. So what it does is, for understanding what it does, we need to copy this statement and paste it once again, semicolon. Now what's happening is, when you enter this particular query, you have multiple departments. Let's say department number 2, engineering department, is repeated multiple times. But now I don't want to extract all the employee details. I want to just know how many number of unique departments are present in this particular employees table. So in that particular scenario, I need to provide a semicolon to follow the principles or best practices. So here you see we have about, okay, I think for distinct function we might not need semi double quotes. Okay, I think I made a mistake in keyword. Yeah, there you go. We have 1, 2, 3, 4 distinct department IDs and 1 null. So that is from the employer to which we did not assign any team yet. So that's one thing. And now if we continue ahead, we have aggregate functions, which are basically the average, sum, count, minimum, max, and a few other basic aggregate functions that you use on a daily basis. So for basic aggregate functions, I'll just quickly copy and paste the comments here so that we save time and spend that time for understanding how the query is performing. So here we have the first function, which is counting the number of employees. So basically we'll start with the first aggregate function, which is trying to calculate the total number of count of total employees in this particular data set. So we are using the count function, and here you can provide a dedicated column name, or you can also provide the star logo, which basically calculates the entire rows here. So just enter. Then you have about 10 employees here. Now the next aggregate function is, we will be trying to find out the average salary of an employee from a specific department, which is engineering. So for that, let me expand this again. So for that, first we will be calling the columns from this particular table, which is employees table. And since we are also dealing with a specific department, which is engineering, we need to perform a join operation where we will combine both employees and department tables together based on one keyword or one column, which is department ID. So department ID will be a primary key for department table, and department ID will be a foreign key for employees table. So based on this foreign key, meaning the employees table will be able to get joined or connected with the department table based on this particular department column, department ID column. Now, so our statement is simple. We are selecting average of salary, and we are aliasing it as average engineering salary from the table employees, and we are joining the employees table with the departments table on one common column, which is department ID. Departments dot department ID is equals to employees dot department ID. So departments is the name of the table and employees is the name of the table. So in this particular table, I'm referring this particular column, and I'm trying to connect to this particular column in the next table where department name is equals to engineering. Now let's execute this particular query. There you go. So on an average basis, the salary of any employee working in engineering department is 1,08,750. So this is the average salary of any employee who is working in engineering department. Could be more or could be less based on the designation. If he is an intern or a beginner, then the salary might be less. If he's a supervisor or in a senior position, the salary might be more. It's basically an average of both. Now, the next aggregate function that we will be dealing with is the maximum and minimum. So, for finding out minimum number, you can use a function in SQL which is called min. And for maximum, we can use a function called max in SQL. So, it's as simple as that. Minimum of salary as minimum salary, maximum of salary as max salary from employees table. So, let's quickly execute this query. There you go. So we found out the minimum salary of any employee in the entire company is 50,000 and the maximum salary in the entire company is 1,20,000. Next comes the last aggregate function in this particular domain, which is count function. So we will be selecting a department ID and we will be counting the total number of employees per department, and we will also name it as employee count from the table employees, and we will be grouping it by department ID. Let's enter. There you go. So we have one employee who has no department assigned, maybe he's an intern, and department ID 1 has 2 employees, department ID 2 has 4 employees, department ID 3 has 1 employee, and department ID 4 has 2 employees in it. And with that, we have come to an end of this module, and we have understood the basic functionalities on how to create a table, how to insert a table, how to select or extract data entries from a table, how to filter data using where clause and having clause, and we also learned grouping, aggregate functions, basically all the fundamentals to proceed with the upcoming modules. And with that, we transition to the next module. So now we enter module number 3, which is about understanding SQL data types and operators. This particular module will help you set the stage for all the basics. In this module, we will be diving into something absolutely fundamental, something every single SQL developer, data analyst, and database engineer uses every single day: data types and operators. Now, I know what you're thinking. Data types? Operators? Isn't that basic stuff? Yes, it is basic. But it is also the reason behind almost 70% of SQL mistakes that beginners make. Wrong data type breaks queries, slows down performance, and causes corrupted results, and even sometimes crash the entire production system. I've seen senior developers accidentally storing dates as text and then wonder why the database can't sort December properly. So in today's chapter, it's not just theory, it's how not to break your job interview or your database. Let's dive into this section. The first step is understanding SQL data types. Before we even start to write a single query, SQL forces us to follow this one golden rule. Every piece of data must have a type. Why? Think of a database as a massive warehouse. Data types are the labels on the boxes. Without labels, the warehouse becomes chaos. With accurate labels, everything is fast, searchable, optimized. SQL databases rely heavily on the data types for storage, indexing, comparison, sorting, and performance tuning. Imagine a library where books have no categories. SQL without data types feels exactly like that. Now let's break them down. First one, numeric data types. We have integer, or it is also specified as int, which is used for whole numbers. Great for IDs, counts, quantities. For example, age can be stored as integer. Product ID can also be stored as integer. Quantity, the number of items ordered. Now it's a small story type. In one of my early projects, someone stored product prices as int field. So the price was $99.5 or 99.5 rupees. So the total became 99, ignoring the 50, right? Or the decimal value. Now, what happened because of it? We lost precision and the entire billing report was off by lakhs. Lessons learned: use the right data type. Now, the right data type was numeric type or a decimal one. So, this is the superstar for financial data. P is equals to precision, total of digits, and S is equals to scale, which is digits after decimal. Now, for a simple example, consider this one. Decimal 10, 2, up to 10 digits and 2 digits after decimal. The maximum value is 99 millions dot 99 decimal values, or one decimal value less than 100 million. Now, real world use case: salaries, prices, taxes, rates, weight, percentages, etc. Next comes the float or double data type. It is used when you need very large or very small numbers, but some precision may be lost. Think scientific data sensors, machine learning scores. But don't use float for money unless you want rounding problems or angry accountants calling you. Now the next data type is character data types. We have char function n for fixed length string. Always use the full allocated space. Let's consider country codes where you have some country codes for that. For India, you have IN for US, you have US, and you can also have gender, which we have M and F. For example, country code, character data type, two values. And the second one is varchar, and it is one of the most commonly used ones. It stores variable length data, and some of the use cases to consider as names, emails, city names, product descriptions, etc. A small story again. Once I saw a table with varchar and the limit was 5,000 for storing the first names. First names alone. Imagine allocating 5,000 characters for storing just a three-letter word like Max or Raj. Now, what are the lessons learned here? Proper sizing matters for performance. If you store 5,000 characters for just three letters, your space is wasted. And this might affect your performance. Now, the next data type is text. Text is used for large bodies of text. Blogs, descriptions, comments are a few examples. But avoid text whenever a reasonable varchar works in place of text. It cannot be indexed efficiently. That's the problem. Now, the next one is date and time data types. SQL is amazing at working with time-based data, but only when the data is stored correctly. For example, dates are stored only in year, month, and date types. You can see on my screen we have YY, YY, MM, and DD as the format. This type of formatting is perfect for birth dates, join dates, attendance logs, and a lot more. Next is time, and time stores only time. And after that, we have date along with time function. This can be represented as date time together or also known as time stamp. This stores date along with the time. Now some of the use cases: timestamps, log entries, attendance tracking, transactions. A mistake I've seen too often is people store date time as varchar, right? A data type change completely. And then sorting goes like 2024 1 or 2023 12 1, 2024 110. Completely messed up, right? Now, this can be solved. You just have to change the data type, and also we'll go through some examples in the real-time use case where these type of issues are addressed. Moving ahead, we have the Boolean data types. So the name stands for itself. It is either true or false. Some of the examples is active, is verified, is published. Never store Booleans as varchar. You might be wondering, why cannot we use varchar? It is just simple yes or no. Reason: if you use varchar, it wastes space and breaks the filtering logic. That's the main problem. Proceeding ahead, we have the next data type, which is binary, and miscellaneous data types, which is blob. This particular data type is used for storing images, PDFs, videos, JSON files, and they store semi-structured data. Modern SQL feature: JSON is a lifesaver when you need flexibility without completely switching to NoSQL. Now let's go to the next section where it will help us to learn the arithmetic operators and other functionalities. Operators help us calculate, compare, and manipulate data. Let's start with the easy ones. The first one is arithmetic operators. Just like math operator meaning example, addition salary plus bonus, subtraction price, discount, multiplication, quantify, and division, modulus, etc. Now let's go through a simple example query. So you can see it on my screen. Select product name, sales, quantity into rate as new sales from Excel data. Now the real-time analogy. Operators like these are calculator inside SQL. Instead of exporting data into SQL, SQL helps you compute right inside the database. Now let's also go through a real-world scenario. Imagine a store wants to compute total revenue, discounts, tax calculations, profits instead of running separate scripts. A single SQL query can handle all of these arithmetic operations. Now, let's dive into section 3, logical operators. Logical operators help SQL make decisions like, should this row be included? Does it match with condition? Is it true or false? Followed by that, we have AND operator. All conditions must be true. For example, where salary is greater than 50,000 and department is engineering. You can see that query right on my screen. Followed by AND, we have OR operator. Any of one condition should be true, where city is equals to Mumbai or city is equals to Delhi. So this selects all the entries from the cities of Mumbai and Delhi. You can see a sample query on my screen. Followed by that, we have not operator. This exactly reverses the condition where not country is equals to India, and this particular query is on my screen. So you can see any other data apart from India. Logical operators like filters on YouTube, language is equals to English, duration less than 10 minutes, category is equals to technology. SQL just filters rows instead of videos. Now we land into section 4. So this particular one is based on between, in, and like operators. Sometimes we have another one as well, which is called I like, which is the opposite of like. These are the operators you will use every single day. Now another one is between operator. So this is used for ranges. For example, columns between value 1 and 2. For example, you can see it on my screen. Select everything from Excel data where row ID is between 10 to 20 or 10 and 20. Now, what this query does is it will eliminate any rows before 10 and it will eliminate any rows after 20. Only the rows between 10 and 20 are executed and shown to you. Now, a friendly tip. Between is inclusive. It includes both the boundaries, which means 10 and 20 are included. They are not excluded. Now, let's dive into the next one, which is in operator. Instead of writing many or conditions, you can just write one in condition and write the set of cities. For example, you might want 3 or 4 cities. So what you can do is where city is in and the function, inside that function, you can write the city names. For example, Mumbai, Delhi, Hyderabad, Bangalore, and many more, right? Whenever a city name matches with the elements present inside the in function, that particular row entity will be selected and displayed for you or filtered and displayed for you. Now, followed by that, we have like operator and pattern matching. So you'll have a modulus sign or wildcard, which represents any number of characters. And the example is right on my screen, where name is equals to or name like modulus A and ends with a where name like modulus sign an modulus sign. So contains an as a wildcard. So any name which has an included in it, and it might have anything in front of it, it might have anything in the right hand side of it or the end of it. So whichever text has an inside it, all those text values will be extracted and displayed for you. Now in the section 5, we will have a small practical story or a real world analogy. To make this chapter sticky to your memory, let's run through a few stories. The first one, date disaster. An HR system stored join date as varchar. So sorting by join date gave Jan 10, Jan 2, Jan 25, Jan 5. Why? String sorting treats 10 as smaller than 2. Solution? Convert varchar to date to fix everything instantly. Moral? Always pick the right data type. Let's also go through story number 2. The like operator that saved a scale, an e-commerce company needed to find all products with Pro in their name. iPhone Pro, MacBook Pro, GoPro. One more simple query where product name like modulus sign Pro modulus sign. It can have anything before Pro, it can have anything right hand side of or the end of the Pro. So basically any text which has Pro included in it will be displayed. So what's the result? Marketing team recovered thousands of lost sales because these products were mistagged. Now comes the section 6 where we will have some demos. Here are some fully explained queries for learning purposes. So we will be diving into MySQL Workbench and start executing commands. So now we are on MySQL Workbench for running all the examples that we discussed previously. So my data is in sample database. So we will be using the use database keyword. Let me expand the screen. And the name of the database is sample. So we are in a sample database right now. And we have to show the tables that we have. Again, the keyword. You can see that MySQL Workbench is showing us some recommendations, but we don't want any recommendations. We should go with what we have. Now, apart from that, we want to see what's inside this particular table. So, yeah, Superstore. So we were supposed to go into Superstore, not a problem. So this is our database name and show tables. We have checkpoint data, we have complex post view, and this is the Excel data we need to work with. So now let's type a command, select star or everything from Excel data so that we have an information on all the rows and columns that we have to deal with in this particular execution. So we have row ID, order ID, date, shipment date, customer ID, and everything that we need to know. So now we will execute some sample queries to understand the functionality. So let me write down the demos that we want to execute. So the first demo is about finding employees earning between 50,000 to 100,000. Right, this is the first query. Let's leave a little space and also write down demo 2. And what's about the demo 2? We need to search city names. So these are the examples that we discussed before on the go, right? So containing PUR. So it can be Nagpur or any city which has the letter PUR in it. So it took an auto recommendation, or instead of PUR, you can also have anything like DEL, right? So now let's go with the third demo, which is show products with price calculation. And demo 4 will be about list users from specific cities. Demo 5 will be about employees not in HR department. Or we can also make some changes to this based on the dataset that we are working with. So we can go ahead with the segment here. We have segment in we have which are not in segments of consumer or anything apart from consumer and home office. In specific segment, let's go with the consumer. And lastly, demo 6, which is about items with exactly matching some words, like let's say OUR, or let's say instead of exactly matching, we can consider this as text matching. So we have a template or a skeleton of what demos are we trying to execute here. Now let's start with queries. Now I want to find out any employee or any of the products. So we have number of pricing, right? So we should go with the sales here. So let's identify sales which are more than 3,500. So between 3,500 to 4,000, or sales. Find sales between. So this is a requirement. So what we will write is a simple select statement. We will select everything or select a specific product name. So we will go with the product name. So what I'll do is I'll simply copy this field name. I'll paste it over here, comma. I want sales column as well from Excel data. Where sales is between 35 and 4,000. Now we have the list of products that are having this range of sales. So we have about 5 or 6 entries which have the sales in between 3,500 INR or dollars to 4,000 INR or dollars. And now let's go into the demonstration 2 where we wanted to find out city names containing PUR. So if we go back to our Excel data set, we had a column which had the address, right? So we had cities like Leeds and a few other things, Paris, Parla, and all those things. So I want to find out any city name which has some given text. For example, if you go with Munich, so we have MUNICH, right? And we have Naples here. So APL or yeah, APL. So any state or any city which has Hamburg, etc., right? So any state which has AMB, I want to extract it, right? So let's write down a query for that. Select city from Excel data where city like, since we're using a keyword, let's have like, and since this is a text related data, we need to encode in between single quotes and we want Hamburg, right? So AMB and anything after AMB, semicolon, enter. So now we have any city which has AMB included in it displayed here. We had Cambridge, we had Hamburg, and all those city names which has AMB included in the text. Now let's go with the demo 2. We wanted to show the price calculations. So we have, let's execute this one more time. So we already have sales data, right? So if we go back here, let me scroll it. So if we go back here, we have the rate of every single product and the number of quantity. So the rate for single unit was $24.4 or rupees, and multiplied by 3 times, you have 79.2 as the final price, right? And now I want to calculate that once again. Let's say we didn't have that sales tag or sales column. If we wanted to calculate it, how would you do that? That's the problem, right? So we can do this by the following application of the formula. So what you can do is write down, select, what we want is product name. So I'll just copy paste this particular field name here instead to avoid any kind of errors. Comma. We also have sales, right? So let's keep sales, comma. We have quantity star. Let me copy that. Quantity into price. We have rate here, so we'll copy this rate name, paste it here, and we'll alias this as new sales from Excel data, semicolon, enter. So now we have all the product names and the sales and new sales. Remember the one which we discussed, decimal points. So we did not, kind of constraint to, minimize the number of decimal points. So it gave the full potential of decimal points here. So we could, include a new column with mathematical or arithmetic calculations to go ahead with. Now the next demonstration was about including all the details about a specific segment. So list users or list products. So what we can do is again a simple select statement star from Excel data where segment in. So we want the following. So we have segment as corporate, we have consumer, right? So I want let's say corporate and consumer, comma, consumer. So since these are text-based data, so we need to include single quotes as well. And a semicolon to close the data. And there you go. So we have also, you can choose to include only a specific segment, but overall we have filtered the data to include only corporate and consumer related data set. Now, if we go into fifth, so data of the not in segment, so all you need to do is a simple change. So you can copy this and paste it over here as it is, and simply replace in with not in, and there you go. Now you'll get all the data which is not from the section of corporate and consumer. Run that. Yeah, there you go. Okay, there was a small error mistake. Corporate, and we could also include corporate, separate by comma. There you go. Now let's execute this command. And now we only have a home and office depot related data segment. So that's how you can filter. And the last one is nothing but text matching. So where we wanted to find out the products which have this particular, naming convention. So it's similar to this one which we executed before. Select city names which have this following text matching. So instead of AMG, you can go ahead with any of the other city names like MIL or ILA. So you'll have any of the cities which have ILA in that. This is the list of the cities. And now with that, let's close this particular section with pro tips and best practices. So let's wrap it up with some practical wisdom. First, never store dates as vocab. This is the number one beginner's mistake. Use decimal for money, not float. Float introduces rounding errors. Third one, keep vocab length realistic. Avoid vocab 5000 unless necessary. Next one is use in for clearer queries instead of many ors. Fifth one is like with leading wildcard, and it is slow. Avoid it in large tables. Sixth one is Boolean fields, make filtering faster and cleaner. Seventh one is use int for IDs fields, not vocab. Eighth one is understand indexes before using like frequently. And the final summary. In this chapter, you learned why data types matter more than most people think, how numeric, character, date time, Boolean, and advanced types work, how arithmetic and logical operators really behave, how between in like help simplify filtering, real stories that highlight how crucial good data modeling is. Now let's also go through some professional best practices you can use immediately. With this foundation, you are now ready to write cleaner queries, avoid common mistakes, and handle real-world SQL tasks confidently. In the next chapter, we will start leveling up with constraints and advanced filtering logic, which is where SQL begins to feel powerful. Stay tuned and keep practicing. Module 4, Safe Deletion Practices and Best Practices for Data Entry in SQL. Before we talk about writing advanced queries, joins, or analytics dashboards, there's one uncomfortable truth every SQL professional must understand. The most dangerous SQL queries are not the complex ones. They're the simple queries executed without thinking. And among all SQL commands, there's one command that has probably caused more panic, data loss, and late night emergency calls than any other. And that command is delete. In this chapter, we are going to slow down and talk about something that separates beginner from a professional. It basically depends on how you delete data safely, responsibly, and confidently, and how you insert and maintain clean, reliable data from day one. Because in real world, SQL is not about writing queries that work. It's about writing queries that don't break business. So the part one, why delete statements are the most dangerous ones. So let's start with a very honest question. Why is delete such a scary command? The answer, delete is permanent. Delete does not ask for confirmation. Delete executes immediately. Delete can affect millions of rows within mere seconds. There is no undo button in SQL for delete option. Once data is deleted, reports break, dashboards go blank, finance numbers change, trust is lost. And most importantly, you are accountable. That's why companies don't fear complex joins. They fear one command, that is careless delete statements. Now, with that, we enter into part 2, the most common delete mistakes that a beginner makes. So, let me share you the most common and most dangerous mistakes beginners often make. Let's look at a sample on my screen. For your information, we are not manipulating this database as of now, because we will be using these tables for our next module, and if we run these commands and delete or truncate the data, then we might lose it and we might have to recreate again. So let's not do that. Let's have a sample query on my screen, and that should be good enough for you to understand what's the flow. So here's the query: delete from employees. We are deleting from the employees table. That's it. No where clause, no filter, no condition. This query means delete every single record from the employees table. In a production system, this could mean all employees' records are gone, payroll reports destroyed, compliance violations, audit failures, and here's the scary part. SQL will happily execute this query. It won't warn you, it won't ask you, it will just do it. This is why experienced SQL professionals treat delete like handling a loaded weapon. And with that, we transition to the part 3, safe deletion principles. So the first one, always preview before delete. The golden rule of safe deletion is simple. If you cannot select it safely, you should never delete it. Before deleting anything, always run a select query using the exact same where condition. Step number 1, preview the data. Let's take a look at the simple query on my screen. Select star from table, that is employees table, where department is null. This should show you employees without a department. Now ask yourself, does this data look correct? Are these the records I truly want to remove? Is this count reasonable? Only when you're 100% confident, move to the delete option and delete those records. Now comes the step number 2, convert select into delete. Let's look at the sample query right on my screen. Delete from employees where department ID is equals to null or is null. Same condition, same logic, no surprises. This single habit can prevent 90% of data deletion disasters. Now with that, we transition to part number 4, safe deletion principle number 2. Use transactions. This is professional level practice. In professional environments, delete is rarely executed alone. It is wrapped inside a transaction process. A transaction allows you to preview changes, validate row count, roll back if something looks wrong. For an example, safe deletion using transaction. Let's take a look at this sample code on my screen. Start transaction, semicolon, delete from orders where order date is less than 2025, 1st of January. Now, select row count method and then roll back. What's happening here? SQL prepares the deletion. You check how many number of rows would be affected. If the number looks wrong, you can directly cancel it. When you're confident, then you can commit. This is how real companies delete data. If you mention transactions during your interviews, it instantly signals production level experience. With that, we make a transition to part number 5 of this module. Safe deletion principle number 3. Delete with primary keys when possible. So what do you mean by primary key based deletion? Never delete data using weak conditions if a primary key is already available. So what could be the dangerous part? Let's look at a sample code on my screen. The code will be delete from users where email is equals to alice@example.com, right? Now, how would this be dangerous? Let's say you have orders data and Alice is your company's employee. Alice might have made thousands of sales and she might have entered the same email ID, which is alice@example.com. When you run this query, those thousands of orders records will be vanished in a mere second. Let's say you wanted to just delete the order for a specific number, let's say order 123, and instead of order 123, thousands of all other records based on alice@example.com will be deleted. So now let's understand why this is risky. So in technical terms or SQL terms, email may not be unique. Remember the unique keys that we discussed? You might delete multiple records unintentionally. Now what's the safe process to escape this? Let's look at the sample code on my screen. Delete from users where user ID is equals to 4, right? Or order ID is equals to 4. Now this will be the safest step. It will only eliminate the records of that particular primary key. Now let's go with primary key. Primary keys are unique, they are predictable, they reduce accidental data loss. Professionals think in keys, not names. Now with that, let's make a transition to part number 6 of this module. Safe deletion principle 4. Soft delete. This is again an industry standard. In many real systems, data is never permanently deleted. Instead, companies use something called soft delete. So what is soft delete? Instead of removing the record, you mark it as inactive, you preserve history, you avoid compliance issues. Example, add a status column. Let's look at the sample on my screen. Alter table users, add column, is underscore deleted, Boolean default false. So what's happening here? You're trying to make some changes to the table users and you're trying to add a new column which is termed as is deleted. And you're adding a new Boolean value which is by default false. So in case if you're trying to delete something, then you will refer to this particular default false value, and anything if you want to hide or delete or filter, you can just use that command and filter out those rows. That's what is happening here, and that's called the soft delete option. Now the soft delete query. Let's look at the sample on my screen. Update users, set is deleted is equals to true where user ID is equals to 4. Now the next one, fetch only active records. So for that, let's look at a sample on my screen. Select star from users where is deleted is equals to false. Now why companies love soft delete? It is audit friendly, reversible, safer, analytics friendly. If you say soft delete strategy in interviews, it shows maturity. Now let's make a transition to part number 7, delete versus truncate. It's an important distinction. Many beginners confuse delete and truncate. So let's discuss this once. Let's start with delete. Delete can use where. It can be rolled back when used with transactions. It triggers logs. It's slower but safer. While truncate, on the other hand, deletes everything. It cannot use where clause. It cannot be rolled back. It's extremely fast and extremely dangerous. So let's have this rule of thumb. If you don't fully understand truncate, don't use it. With that, let's make a transition to part number 8 of this module, which is about best practices for data entry. It's the foundation of trusted analytics. Now, let's shift gears. Safe deletion protects your data. Good data entry prevents problems before they even exist. Bad data is more dangerous than missing data. So, the best practices. Number 1, always define data types correctly. Every column should reflect real-world meaning. Let's go for an example for bad design. Salary, worker 50. So you know this is a character data type and it doesn't make any sense. The correct way, salary is integer or salary float. Why this matters? Sorting works correctly, aggregations are accurate, performance improves, data validation becomes automatic. SQL data types are your first line of defense. Now, the second best practice, use constraints, not trust. Never trust users, applications, or APIs to send clean data. Use constraints. So the first one, primary key. Primary key is employee ID in our case. A foreign key, department ID, which can reference department ID from the other table. And for safe side, you can also keep another constraint which says not null. So whenever a null value is being trying to insert, it will not take it. It will definitely throw an error. Next one is name, worker 50, and it can also be not null. Unique value, which is email, worker 100, and it should be unique. And another few benefits of using constraints, it prevents duplicates, maintains relationships, stops bad data early. Good SQL developers design defensively. And with that, the next best practice, that is number 3, handle null values intentionally. Null is not bad. Unplanned null is bad. Ask these questions. Is null allowed? What does null mean in business terms? Should there be a default value? For example, department ID data type is int and null, meaning Employee may not belong to any department. This is acceptable only if business allows it. Clarity beats assumptions. Now with that, the next best practice, number 4. Insert only verified data. Before inserting data, validate the formats, check references, confirm business logic. Let's look at a sample on my screen. Insert into employees, employee ID, name, salary, department ID, hire date. Select 11, Kevin, 80,000, 2, 25, 12, 10. Where exists, select 1 from departments where department ID is equals to 2. This is a sample query on my screen. This ensures two things: department exists and referential integrity remains intact. Now the best practice number 5, standardized data formats. Inconsistent data kills analytics. Bad HR, human resources are a good example for that. Now, good version of it. Single standardized value. Solution: use lookup tables, enforce values via foreign keys, avoid free text whenever possible. Now, clean data is equals to reliable insights. Now, with that, we have best practice number 6, log changes for critical tables. In real systems, every insert, every update, every delete is logged. Why? Because audits, debugging, compliance, accountability. This is why data engineering and SQL governance matters. Now, you might be wondering why this chapter matters. Let's look at the summary. Let's close this with something important. Anyone can write SQL query. Anyone can join tables, but only responsible SQL professionals delete data safely, protect data integrity, design clean schemas, think long term. Companies don't trust databases to beginners. They trust them to people who respect data. If you master safe deletion and data entry best practices, you are no longer just learning SQL. You are learning how real systems survive. In the next module, we will move into joins and relationships using the same database to answer real business questions. Real-world data never lives in a single table. In real companies, employee names are in one table, department names are in another, orders are stored separately, revenue lives somewhere else. If you know how to query one table at a time, you don't know SQL. You know toy SQL. The moment SQL becomes powerful is when you learn joins. Because joins are how HR teams combine employees with different teams, finance teams combine orders with revenue, product teams combine users and behavior, analysts answer business questions, not just technical ones. This chapter is where SQL stops being syntax and starts becoming decision making. Why joins exist is your next question. Let's take a step back and understand why joins even exist. When databases are designed properly, data is normalized, redundancy is avoided, each table has a single responsibility. For example, employees table. Employees table only stores employee details. Department table stores only department names and other details related to department alone. We don't repeat department names inside employees. So, why is this done is your next question again. It is done for few reasons. One is data consistency, easier updates, better performance. But this creates a challenge. If data is split across tables, how do we see the full picture? Right? That's your question now. That's where joins come into the picture. A join tells SQL, combine rows from two or more tables based on a relationship. And that relationship is usually a primary key in one table, a foreign key from another. In our database, department.department ID is the primary key from department, and department ID from employees is the foreign key for employees data table. This is not accidental. This is an intentional design. What's the business analogy behind it? It's very important for learners. Think of joins like VLOOKUPs on steroids. But unlike Excel, joins scale to millions of rows. Joins preserve data integrity. Joins power dashboards, reports, and even AI systems. If select is asking a question, join is asking a smarter question. Now, let's go to MySQL Workbench to execute some of the queries on joins to understand them even more. So now we have discussed the theory part of module 5. Now we will be proceeding into the demo part. Here we are going to slow down things a little bit because joins are not about memorizing syntax. They're about understanding how rows from different tables come together and work together. Most SQL learners struggle with joins because they imagine tables merging physically, data being copied. That's not what happens. A join is a logical operation, not a physical one. So in this session, we will visualize tables row by row. We will see which row survives, which rows disappear, and why that is happening. By the end of this module, inner join will feel more obvious. Left and right join will stop being so confusing, and full outer join will finally make some sense. And you will understand joins well enough to explain them to someone else. That's a real goal. Now, let's start with first query, employees with department names. Let's have a look on the query on my screen. So you can see, let me minimize this output window. So you can see we are starting with the demos of module 5 from here. To get access to the data table inside this particular database, we will be executing use interview, which is the schema name. And now we are on the first type of demonstration here, first query. So what is the first type of join are we executing? So the first join we are executing will be an inner join. But before we understand what exactly or technicality of this particular join, let's understand the problem that we are solving. So we have an employees table. We have another table, which is departments table. And we already know what are the columns. We have an employee table and department table. So now what is our end output for this particular query, or what's the business question? Employees store only department ID, not the department name. So the business question here is, show me employees along with their department names. This is a classic relational problem. So let's deal with this in a step-by-step way. Step 1, understanding the join condition. So the join condition here is specifically mentioned. Department ID from employee table with department ID from the department table. This line defines how rows are matched. It tells the database, take department ID from the employees, match it with the department ID of the departments table. Only rows where this condition is true will be joined. Remember, this condition is not filtering after the join. It is defining the join itself. That distinction is critical. Now, let's go into the step number 2. What inner join really means. Inner join means only keep the rows where the match exists on both sides. So, employee with a valid department is kept and employee with null department will be removed. So, remember the employee with no department in the employees table? So, that particular employee will not be considered here. Department with no employees will also be ignored. So we might be having certain departments in the department table with no employees. So that will also be ignored. Think of it as give me only the confirmed relationships, not any vague relationships. Row by row visualization. Imagine looping through employees. Alice is equals to department ID is equals to number 2. And engineering exists is equals to keep. Bob from department ID 2, which is engineering exists, so keep it. Charlie from department ID number 1 is from HR and it exists, so keep it. And lastly, Frank, the department ID is equals to null and no matches found, so that will be deleted. Frank completely disappears from the end result. That's how inner join behaves. Now, let's select the entire query and execute. So as we discussed, there are two different ways to execute. So let's go with the shortcut Control Enter to execute the command, or you can also go with this flash logo here. So you can have the output table right here. So the department or employee ID, employee name, his salary, and department name. Second one is Ivan from employee ID 9, salary and department name, which is HR, and so on. We have about a couple of entries here. So overall, where the department is not null and employee is not null, those particular specific columns have a relationship established successfully, and those will be combined or joined together, and we have an end output here. We can also name this as, instead of specific name, ID, salary, department, you can also keep star, where all the columns of both tables will be displayed all together. Let's try that for a homework. Now, from an interviewer's perspective, interview insight, if someone asks you, why is Frank's missing? Your answer should be, because we applied inner join. Inner join only returns rows where the join condition succeeds on both the tables. That shows clarity. Now let's move to the next query. So let me scroll down my query. And here we will be implementing left join. All employees without departments. So let's have a look at the query on my screen. So this is the one which we will be executing for left join. Key mindset that you should be having in your mind is, what exactly is left join? The left join means the left table is mandatory. The right table is optional. whatever happens, every row from the employees must appear even if there is no matching from the department table, which happens to be the second table. What changes did you find here compared to in a join? It is only one thing. Rows without a match are not removed here. Instead, missing columns become null. Let's have a visual walkthrough. Let's focus back on Frank again, where Frank did not have any department ID. It was basically null. So no department match, but left join always says keep him anyway. That's the main core difference between the left join and inner join. So now let's see the result. So before executing the query, let's find out how it may look like. So employee ID is equals to Frank's ID, name is equals to Frank, and salary is Frank's salary, and department will be null. It is intentional, null. It's not a bad data. Now, let's execute the query and see the output. So let me select the entire query and hit enter, and there you go. So we have Alice, Bob, Charlie, David, Eve, and here you can see we already have employee ID 6, Frank, Frank's salary, and Frank's department name is null, right? So even if the matches are not accurate, right, in terms of accuracy, even if there is no actual match between both the tables, but whatever the data we have in the left table, which is employees table, everything will be present. That's the major difference between inner join and left join. Now, even if this kind of data is existing, why companies or why professionals prefer left join is your question. Left join is used often when you want to complete coverage, when you want to detect missing relationships, you want to preserve the main data set. When you have these kind of intentions in your mind while executing query, then left join is the most preferable one. So what are the kind of examples you must be thinking when you are dealing with left joins? So all users, if they are never ordered, all products, even if they are not sold, all employees, if they are not even assigned to a dedicated group like Frank here, right? So these are the scenarios where you are forced to use left join. Now a quick interview tip, a powerful phrase. Left join preserves the left table cardinality. That's senior level language. Now let's go into the next query. So the next query will be based on right join. So let me highlight my query first. And now let's understand the technicality. So this particular query is based on all departments, even if no employees. Let's take a look at the query on my screen. So conceptual identity to the left join. Right join is just the left join from an opposite direction. Previously, we focused solely on the left table. Now we will solely focus on the right table. Now departments are very mandatory. Employees are optional. In the previous one, employees were mandatory and departments were optional. Now this is the opposite side. What row survives will be your question. Departments with employees and matched rows will appear, and also departments with no employees will also appear. But anyways, employees without departments is a little bit irrelevant here, but for the concern of understanding, let's keep it that way. Now, let's execute the query to understand the output. Now, there you go. We have all the departments and their employees together. We have HR and the name of employee is Charlie. We have Ivan from HR, and we have Alice, Bob, and David from engineering, Heidi, Eve from finance, Grace from marketing, and Judy from marketing. Now, let's understand one more thing. Why right join is rarely used. Most developers prefer left join, reorder table instead of using right join. So, this query could be written as from departments D, left join, employees E, right? This is also a perfect logic. Same logic actually, more readable. Now, for that, let's have a small teaching insight. Right join is important to understand, but not commonly used in production code. Now, let's dive into the fourth query, which is about a simulated full outer join. So why simulated, you ask? Because there is nothing called full outer join, but we can still have a simulation of it by including the union in our code. So you can see I have highlighted the code and we have a union command here where we will combine both the tables together. So now why are we doing this? Some databases do not support full outer join, or learners want to understand how it works internally. So for that, we have a query highlighted right on my screen. We'll simulate it. But before that, what full outer join means conceptually? Give me everything, right? This particular data extractions include matched rows, left only rows, and right only rows. Basically, what we are trying to do is we are combining inner join, left join, and right join, basically extracting whatever is present inside both the tables. Nothing is lost. And now you might be having a question. Why did we use union here? Left join keeps all the employees from left. Right join keeps all the employees from right. Basically employees and departments. And what is the purpose of union is union combines both and removes any duplicates present in both the tables. So what's the result? Full coverage from both sides. Now let's execute this query and see the output. So there you go. We have all the names of the employees and their specific departments, similar to the previous query. So we have Frank without department name and all the other employees with their dedicated department names right here. Now, what's the important learning moment? This query teaches join logic, set operations, result set thinking. This is advanced understanding, not beginner syntax. Now let's move with a few example queries. So first one, I want to identify orders with user email, and we could go with an inner join here. So let me select the entire query. Now let's understand the flow of this particular query. So take a look on my query at my screen. Business story orders store, and we have customer ID, not customer email. User store, and we have email, not every other details on that, right? Now we want to join to enrich the order data. Why inner join? Because inner join makes sense here. An order must belong to a user. So orders without users is invalid. Inner join enforces data integrity logically. So before we move further, let's execute this command and see the output. So we have order ID, email ID, and order date as per our requirement. Now, what's the real world relevance? This is how dashboards, invoices, analytics queries are built. Almost every real system uses this pattern. Now, let's go with the next query where we will try to find out revenue per order date. And we will be using an aggregate function here. So let's take a look at the query on my screen. So shift in thinking. We are no longer looking at rows. We are looking at groups of data. Group by in my query changes everything. How group by works conceptually and everything else. Now, let's look at the database steps. First, we will scan all the rows. Then group by order table plus we will also be applying an aggregate function for the group. And then we will return one row per group. So let's quickly execute this query and see the output. There you go. We have order date, total number of transactions, and total revenue all in one shot here. So why count and sum work here? Because count of number of rows per date and sum adds revenue per date. This is basically time series analysis and it is extremely common. Now a quick interview insight for you. Group by reduces number of rows. Join expands number of rows. Remember that contrast. Now we have query number 7, which is about employees with highest salaries. And here we will be using two things. First is a join function and next is a filter function. Now let's take a look on the query. So here we have employees with highest salaries and this is my query. So what we are basically trying to do is we are combining both the tables, which is employee table and departments table. And our concern is to find out any employee whose salary is more than 90,000. So that's the overall observation on this particular question or business question. So what's the execution order? Coming to execution order, one of the most important and commonly asked question in SQL interviews is the execution order of the commands. So far, we have seen through all the basic fundamentals of SQL commands, right? The keywords basically select, join, and all those things. So let's consider this as a homework. Let us know in the comment section below what is the execution order of all these keywords in SQL. Now, for a quick clue, let's see the flow of execution for this particular query. So what happens is, first, join is the one which activates. It joins both the tables. Then, where comes into the picture? It filters the rows. And then comes selects, which formats the output. And this order matters. Let's quickly execute this query and see the output. So there you go. We have Bob, David, Eve, and Heidi, who have salaries greater than 90,000 and their dedicated departments are engineering, finance. So these three employees are from engineering department and we already discussed this, right? Engineering department is the one which is paying highest number of salaries. So we have three from engineering itself and the next one is finance. Now, why where is executing after join? This is your question, right? We are filtering employees, not departments. If we filtered earlier, we might lose the relationship context. Now, let's have a quick practical takeaway. Join defines relationships, where it defines conditions. Never confuse with both of these. Now we have the query number 8, where we will find out departments with no employees at all. Now, let's take a quick look on the query on my screen. So this is my query. I want to select the department name from departments B, and I want to apply left join, and I'm joining this with employees on the category of department ID and where employee ID is null. This is a classic interview query and it tests deep join understanding. What's happening is, in a step-by-step way, left join keeps all the entries from the departments table where employee ID is equals to null, and it keeps only rows where no employee is matched. So the result, let's execute this to find the result. So there you go. Departments with 0 employees. Why inner join can't solve this? Inner join removes non-matching entries. Left join plus null, check, reveals them. This is powerful logic. Now we move into the 9th query, customers with multiple orders. So let's take a quick look on the query. Now this is a multi-layer query and it combines a lot of things. For example, join, group by, and having. This is real-world SQL. Why having is used instead of where could be one question in your mind, because where filters rows and having filters groups. This you need to understand. This is one golden rule which you always need to keep in your mind. Now let's discuss the execution logic. Join users and orders. Join is used to combine users and orders. Group by to group or categorize email. Count is used to count the number of orders per user. And lastly, having keeps only the users with order numbers greater than 2. Now let's execute this query. So we have the output here. We have Alice and Bob with total orders 4 each. That's the output. Now what's the business meaning? This query finds out the loyal customers, high engagement users, retention targets. Exactly what analytics teams do on a daily basis. Now this is a final wrap up for joins. If you understand this module deeply, joins are no longer scary. Nulls make sense, aggregations feel logical, interview questions become more predictable. You didn't just learn the syntax, you learned how databases combine data, how SQL thinks, how real systems are queried. That's professional level SQL. And with that, we make a transition to the next module. Now, repeat. Now we have reached to the module number 6, which is about grouping and aggregating data in SQL. So here we will be dealing with group by, having, aggregation functions, and filtering group results. Now let's have a quick introduction to this. Why this chapter or this module matters the most. Up until now, everything we have done in SQL has focused on individual rows. We used to select rows, filter rows, sorted rows, and we used to join some rows. But here's the reality of how SQL is used in the real world. Businesses almost never ask that, show me every row in the table. Instead, they ask, how many employees do we have per department? What is the average salary? Which days generate the highest revenue? Who are most active customers or the most loyal customers? These are summary questions. And the moment SQL moves from showing rows to answering summary questions, you made a huge transition. We enter the world of group by and aggregation. So far, you had a basic introduction to these functions. This chapter is where SQL stops being data relevant and starts becoming data analysis. If joins helped us connect data, group by helps us understand patterns inside the data. Now let's go with the part 1. What group by actually does. Let's build the intuition first. SQL looks at each row independently, but when you use group by, SQL changes how it thinks. Instead of processing row by row, SQL tries to process in a different way. It tries to group rows that share the same value, applies calculations to each group, returns one row per group. So you are no longer working at row level. You're working at a group level. Think of group by as a machine that takes many rows, bundles them into logical buckets, and produces summarized information. This is the foundation of reports, dashboards, KPIs, analytics, and business intelligence. Now let's go to the part 2. First, group by, simple and clear. This could be our first query here. Now let's go through the sample query on my screen. So here we have a department ID and we're trying to count the number of employees per department, and we will be aliasing it as total employees, and we are selecting this data from employees and we are trying to group it by department ID. Now, what we want to know is the question. So it is basic and simple. We want to know how many employees are there for each department. Instead of listing employees one by one, we try to group them. And once we group them, we will try to count them and then execute the query. So let's execute this query and see the output. So basically we have 5 departments here. One department is not assigned. So that particular one is based on Frank that we earlier executed. So let's take a pause and understand what SQL is doing here. It is scanning the employees table, grouping rows by department ID, counts the total number of employees inside each group. Every department becomes one row in the result. Now, one important observation that you need to have here is employees with null department form a separate group altogether. This is real world behavior. Missing data doesn't disappear. Now, let's make a transition to part 3, where we try to group by with join, making output business friendly. IDs are useful for databases, but people don't think in IDs. They think in names. So let's improve this query by using a join function. So let's quickly go to Workbench and see the code on my screen. So previously we had no names to the department, right? Now to make it more sensible, we are trying to combine employees table with the departments table, because departments table has the name of the department, right? The null 1, 2, 3, 4 doesn't make sense. So it could make a lot sense when we had an actual department name. So for this, let's execute this particular query, and you already know how the left join works and on what basis did this particular employee table establish a join with employees table, right? So here we have department ID from employees table, and here we have department ID from departments table. Based on the match and the type of join that we are using is left join, what it does is it keeps all the entries from the left table, which is the department or employees table, and the matching elements from the right table, which is the departments table, right? So employees is the left and departments is the right. Now we will be grouping by department name. So let's execute this query, and there you go. We have HR, engineering, finance, and the null department, and the total number of employees working in each department. Now we join employees with departments. We grouped by department name. We made the output more readable for leadership. This is how SQL is used in HR reports, management dashboards, workforce planning, and a lot more. Now, one very important learning from this part is joins usually happen before group by. Now, let's make a transition to part 4, which is slightly tricky group by, and we will be using multiple columns here. Now, let's raise the difficulty slightly. Suppose the business asks you this: how many employees were hired per department per day? This means we group on more than one column. So let's execute the code right on my screen. So if I scroll down, here we have another slightly tricky query. So here we are trying to select the department ID, hire date, and we are counting the number of employees based on the column employee ID, and we are aliasing it as hire count, and we are extracting this data from employees table. And here we are grouping by multiple elements. One is department ID and another is hire date. You might be wondering, will this work? Group by was designed to take multiple entries here, so this totally works. Now let's execute this query and see the output. So we have a department ID and hire date. So based on these dates, we have the total number of recruits that we had on that particular date. Now what's happening here? SQL creates groups using both columns together. Each unique combination becomes one group. This increases the number of results per row. The key rule to emphasize clearly is any column in select that is not aggregated must appear in group by. This rule appears frequently in interviews. Now, let's move to the next part of this module, which is about aggregation functions. So it's a quick deep dive. Now that group by makes sense, let's talk about aggregation functions. These are functions that operate on groups, not individual rows. Now we have a few of them. So let's get started with count function. It is basically used for measuring volume. Let's start with count. You can see a sample query on my screen. So let's go to the workbench once. So here what are we trying to do is we're trying to count the total number of employees from the employees table, right? And we will be aliasing it as the total employees. What this basically does is it counts all the rows. Now with grouping, back to my screen. So let's execute this, and we have about total employees. Now about grouping, we have the query right on my screen here. So what we're basically trying to do is we are basically trying to group the total number of employees per each department. So we are adding the department ID and counting the number of employees in there. So let's execute this query. There you go. So count of column ignores all the nulls. Count of star counts total number of rows regardless of how many entries we have. Count answers questions like how many, how frequent, how active. Now with that, we have the next aggregate function, which is a sum function measuring total value. Sum is used for totals. Let's see a code. So here we have select sum of salary as total salary from employees table. Let's execute this. And we have about 8,70,000. Now, let's make it a little more meaningful. Explain the business context, budget allocation, cost control, department-wise spending, right? These will be the business level questions. If you categorize by departments, then you will have a clear answer on the budget allocated for each department. Next aggregate function is based on average, typically measuring some values such as average salary per department. So let's execute the code. So we also have another query on sum. So let's execute this as well. So once executed, you will have, this is the amount of salary or budget allocated to each department. Now let's go with the average function again as discussed. So here we want to find out the average salary allocated per employee in each department, which is similar to the previous query. So let's execute this and we will have the answer. So the average salary allocated for each department is, for HR we have 60,000, for engineering we have 1,08,750, for finance we have 95,000, and for marketing 80,000. So this is the average salary which we have allocated for each and every department. Now the next aggregate functions are minimum and maximum, and it is finding the extremes. So let's go for an example, and the business use cases are salary bands, compensation gaps, identifying anomalies, and a lot more. So here we have the department name. So minimum salary as lowest salary per department, maximum salary is the highest salary per department, and we're extracting this from employees table. And since we need the department name, we are joining this with departments table D, and based on the column department ID, and we are grouping by department name. So let's quickly execute this query, and there we have the lowest and highest salaries of each department: HR, engineering, finance, and marketing. So the lowest salary in HR is 50, highest is 70, engineering is 90, and 12 or 1,20,000, and 95,000 for finance, and 95 is the highest as well. Marketing, we have 75 as the low and 85 as the highest. Now let's make a transition to the part 6 of this module, aggregations with dates, transaction data. Now let's switch tables and think like analysts, like orders per day. Now let's go through the query here. So this is one query that highlights the number of orders per day. Let's execute this. So we have about so many orders, and a few dates are where we had multiple orders, and we also have few dates where we have about a single order per day. And let's go through the next query that we had, which is revenue per day. So this particular query is based on revenue per day. Let's execute this, and we have 25,12,6 as the highest revenue which we earned, which is December 6th, 2025. So this is how daily KPIs are built. These queries sit behind dashboards. Time-based aggregation is extremely common. Now with that, let's make a transition to part 7 of this module, which is about having clause, filtering groups, and it is really critical. Now we address one of the most misunderstood concepts of SQL, where filters rows, having filters groups. You cannot use aggregation functions inside where. I guess this is the second time I'm repeating this because this is really important, and most of the times we confuse with this. This is why having exists, and basic having examples are the following: departments with more than 2 employees. And for executing this command, let's take a quick look on the screen. So here we have the query. Select department ID, count the total number of employees as department's employee count from employees table, and group by department ID, having count of employees greater than 2. So let's execute this. And we have that one particular department where we have about 4 employees. I think it is engineering department. Now let's also discuss the execution order once again, so that you have a quick understanding of how the execution order really works in SQL, and it could be helpful for your homework that we had in our previous model. Group by runs first, aggregation happens next, having filters the result, and having with join. And for this, let's go with an example. Right here, we will be combining both having with join. So here we are trying to have this particular business question: which departments are highest paying? So here we have department name, average salary, and employees. And we are trying to find out the employees with paycheck more than the average paycheck of every employee. So engineering and finance are those two teams which are paying more than the average salary. So we have our final answer. So those two departments which are having the highest salary, right? Tricky having multiple conditions. So is our next repeat. Now moving next is another tricky question, and this particular one is based on having multiple conditions. So let's go back to the MySQL workbench and have a look at the query. So multiple conditions is right here, having count more than 2 and the average salary should be more than 80,000, right? So let's execute this query. The only difference is we are trying to have the average salary should be more than 80. So engineering team is the one which has employee count as 4 and average salary is 1,08,750. So having can use multiple aggregations. This is advanced interview level question from SQL, so you can make a note of it. Now moving further, we have part 8 of this module, filtering grouped results, where we have where along with having together. This is where learners truly level up. Now let's have a small business requirement. Show average salary per department for employees hired after November 2025, but only include departments where the average salary is above 85,000. So let's take a quick look on the code. So this is the code that we will be executing. So we have put the hire date, which is November 1st, 2025. We're trying to group by department and the same query condition, which is salary should be more than 85,000. So let's quickly execute this query. So we have two departments in that way, engineering and finance, where we recruited employees after November 2025 and the salary is above 85,000. Now let's look at the execution order. From executes first, then join, followed by that we have where, then group by will be executed, followed by that we have having clause, then we will select, and lastly we will order by. This is core analytical SQL thinking. Now let's move to the part 9 of this module, which is a capstone query, and this could be real dashboard logic. Let's end this with a realistic analysis query. Back to the workbench. So here we have the query. So here what we are trying to do is we are trying to group by order date, and we should be having some amount greater than 800 and total revenue should be in descending order. We are trying to find out those particular columns, which is order date, count total sales, sum of total revenue, and average order. So let's execute this query and we have the output over here. Now let's understand this. Multiple aggregations are done together. Filtering is done using having clause. We have sorted the results and this query could power a business dashboard. Now let's also discuss some of the common mistakes that learners should be warned about. Now let's discuss some of the common mistakes that learners make and we should be alert about. So the first one is about forgetting group by columns using where instead of having, mixing row level and group level logic, ignoring null behavior, aggregating without the business context. Now, why this chapter was a turning point? At this stage, learners cross an important milestone. If you have understood group by, aggregation functions, having clause, where clause, filtering group data, then you're no longer just querying data, you're analyzing data. This is the skill that powers dashboards, drives decisions, gets tested in interviews, separates beginners from professionals. In the next chapter, we will build on this foundation with advanced analytics concepts, including window functions and ranking. Now we enter the module 7, which is about subqueries and nested queries in SQL. So it could be single row, multi-row, correlated subqueries, plus usage in select, from, and where. Now let's have a quick introduction to why subqueries matter so much. So far in SQL, we've been answering direct questions. Some questions like, show me the roll number of employees, show me departments, show me total revenue per day. But real business questions are rarely simple. Businesses ask questions like employees who can earn more than the company's average, departments with higher than average salaries, customers who place more orders than most of the other users, sales days that outperform the overall trend. Notice something important. These questions depend on the result of another query. And that's exactly why subqueries exist. A subquery allows one SQL query to depend upon the result of another SQL query. This chapter is where SQL becomes logical and layered, not just procedural. Now, part 1 of this particular module, what exactly is a subquery? So let's define it. Subquery is a query inside another query. It runs first, produces a result, and that result is used by another outer query. Think of subqueries as asking a question, using the answer to ask a better question. In interviews, this is often described as SQL inside SQL. Simple visual example can be understood in this way. Inner query calculates something and outer query uses that calculation to provide some better answer. SQL reads subqueries inside out, not top to bottom. This mental shift is really critical. Now, let's go through some examples. So this brings us to part 2, single row subqueries. What is a single row subquery, you ask? A single row subquery returns exactly one value used with operations like equals to, greater than, less than, greater than or equals to, less than or equals to. Let's take an example on my screen. So employees earning more than the average salary. So let's find the average salary first. Let's look at the code on my screen. So here we are trying to find out the average salary of the overall employees table. So the average salary is 87,000. Now instead of hard coding this value, we will nest it, right? So here we want to find out the employee ID, name of the employee, and salary from employees table, where salary is more than the average salary. So here we are ingesting this particular subquery that we recently executed, right? So this happens to be the single line subquery that we are discussing as of now. So this particular single line subquery will be ingested inside the outer query. So this happens to be the inner query and this happens to be the outer query. Now let's run this. There you go. So we have about 1, 2, 3, 4, 5 employees who earn more than the average salary of other employees. So let's take a pause and understand what's happening here. Inner query calculates company's average salary. Outer query performs and filters employees above the average salary range. Important business interpretation to understand here. Who are our top earners compared to the organization? This is a classic interview question. Now, let's take another example. Employees earning more than the maximum salary in a specific department. Let's say HR. Now, let's take an example on my screen. So here, we have a subquery which is select maximum salary from employees where department ID is equals to 1. So the department ID 1 is none other than the HR department. So we are encapsulating this particular inner subquery onto the outer subquery, which is trying to select the name, salary from the employees table, right? And where salary is greater than a number which is the result of this particular subquery, which is the maximum salary of employees. Now, let's execute this query. Control enter, and there you go. Now, let's take a pause and understand how is this working. The inner query returns the maximum value of salary from HR department, and the outer query compares every employee against it. This shows targeted comparison logic. Now, let's make a transition to part 3, where we will have multi-row subqueries. So what is a multi-row subquery? A multi-row subquery returns more than one row. It is most commonly used with operators like in, any, all. So for this, to understand in a better way, let's take an example. And the example question is employees in departments with average salary greater than 90,000. So first, let's identify all the departments. For that, let's take a look on my screen. So let me quickly write a small query. Star from departments. So we have 1, 2, 3, 4 departments: engineering, HR, finance, and marketing. Now we need to execute this particular subquery where we are trying to find out department ID and employees and department having salary more than 90,000. Now let's execute this. So we have department IDs 2 and 3 where they have greater higher salary or the average salary. Now we need to use this particular query inside another external query. So this is the outer query, this particular section, and this was the subquery that we just executed. Now we need to encapsulate this particular subquery inside the outer query, and now let's execute this. So we have the name of the employee, their salary, and their department ID. So as discussed in the first subquery, these are the employee or department IDs and their relevant employees. Now let's understand this clearly. Inner query returns multiple department IDs and outer query filters employees belonging to those departments. Now the business question answered here is, which employees work in higher paying departments? So that's what the answer we gave. Now let's take another example. So the example 2 is, we want to find out customers who placed more orders than the average. Now let's execute this particular query. So there you go. These are the customer and their IDs 1 and 2, and they have placed orders 3 and 4. These are the most loyal customers. Now let's understand the working of this particular code segment. Customers who placed more orders than average. Now let's understand this carefully. Inner subquery calculates order counts per customer. Next level calculates average order count. Outer query filters high activity customers. This is advanced analytical SQL, not beginner stuff. Now let's make a transition to part 4, which is about correlated subqueries and most important concept. Now, what is a correlated subquery? A correlated subquery depends on the outer query and it executes once per row and cannot run independently. Think of it as, for each row, run a subquery that depends on that particular row. This is where SQL starts to feel like programming. For that, let's take an example. So this is the particular example we are going to execute. The question here was, employees earning more than their department's average. Now let's understand this particular example. Outer query processes each employee. Inner query recalculates average salary for that particular employee's department. Now the comparison happens row by row. Now the business interpretation. Who are the top performers inside each department? This is one of the most frequently asked SQL interview questions. Now, let's consider another example. Orders that occurred after customer's first order. For that, let's take a quick look on the code on my screen. So here it is. We are using two different queries, the outer query and the inner query. So the inner query is where we selected minimum orders and customer ID is equals to customer ID from orders table. And we are joining, or we are applying self join here, basically combining the orders table with itself. Now let's execute this query. There you go. Now let's understand this. For each order, we find the customer's first order. We keep only the later orders. This helps to analyze repeated behavior. Now what is used here? We use this in retention analysis, funnel tracking, behavioral analytics. Now with that, let's make a transition to part 5. Part 5 is about subqueries in where clause. So it is a basic recap plus best use. This is the most common place where subqueries are used. Let's take an example. So here the business query is sales on high revenue days. Let's understand this. Inner query identifies high revenue days. Outer query fetches detailed sale rows. This pattern is used constantly in analytics. Now let's execute this query. So there you go. We have the answer. So we have two different entries, sale ID 8 and 9, and the amount was 400, 50 and 600. Now let's make a transition to part 6 of this module. So part 6 is about subqueries in SQL clause and will have calculated columns. Subqueries can act like dynamic columns. So let's take an example. So this is our example here. Let's execute this. So we have the output. We have a name of the employee, salary, company's average salary and difference from average. Now let's understand what did we execute here. Salary compared to company's average. The inner query runs once, adds context to every row, makes reports more meaningful. Now it's great for dashboards and exports. So here what we did is we find out the salary of the employee and company's average and what's the difference, right? The difference amount that they are earning more than the average salary. Now this drives us to part number 7 of this module, which is about subqueries in from clause, or also known as the derived tables. Subqueries from act like temporary tables. For example, department-wise salary summary. Let's take a look at the example on my screen. So this is the code that we will be executing, and here we have the output. Now let's understand what is the logic that we implemented here. The inner query creates a derived table, outer query filters it, and this improves readability for complex logic. This is a stepping stone to CTEs and window functions. Now let's move to part 8. So part 8 is about when to use subqueries versus joins. Now one important discussion. Now with that, we make a transition to module 8, which is about the difference, right? When to use subqueries and when to use joins. Use subqueries when logic is layered. Aggregation is needed first. Readability improves. And when to use joins? Joins are used when data relationships are direct, performance matters most, data volume is really large, and professionals choose clarity and performance. Now let's also go through some of the common mistakes to warn learners about. So using equals to instead of in, expecting multi-row subqueries to return one value, forgetting correlation logic, overusing subqueries where joins are better, and the last one, ignoring performance implications. Now why this chapter was a milestone? If joins taught SQL how tables relate, subqueries teach SQL how logics relate. Once you understand single row subqueries, multi-row subqueries, correlated subqueries, subqueries in SQL, from and where clauses, you can answer almost any analytical question in SQL. This chapter is a bridge from intermediate SQL to advanced SQL to interviews to real production analytics. In the next chapter, we will take this logic and supercharge it using window functions and ranking, which solve many problems more efficiently. Now we transition into module 8, which is about data modeling and relationships. So primary keys, foreign keys, relationships, ER diagrams, and normalization are the topics discussed in this particular module. Now let's have a quick introduction. Why this module defines your SQL maturity. Before we begin this chapter, I want you to pause for a moment. Up to this point in the course, you've been learning how to talk to a database, how to select data, how to filter it, how to join tables, how to aggregate results. That's important. Okay, this chapter answers a deeper question. Why does a database look the way it does in the first place? This chapter is not about writing queries. This chapter is about thinking like a database designer. And here's a reality check that most tutorials won't tell you. In real world, SQL queries are easy to learn. Poor data modeling destroys companies. Most production bugs are data design bugs. Most analytical errors come from bad relationships. If data modeling is weak, joins become confusing, data becomes inconsistent, reports contradict each other, performance drops, and most importantly, trust in data disappears. This is why senior designers, architects, and analytical leaders care deeply about data modeling. This chapter will help you understand how professional systems are designed, read any database schema with confidence, answer system design interview questions, avoid beginner level modeling mistakes, build databases that scale logically, not just technically. Think of this chapter as the architecture class of SQL. Now, let's start with part 1. What is data modeling? Now, thinking before coding is nothing but data modeling. Let's start with the foundation. So, what do you mean by data modeling? Data modeling is the process of identifying entities, defining their attributes, establishing relationships, enforcing rules and constraints. In plain language, data modeling is deciding how information is structured, stored, and connected before data even exists. A good data model answers what are core subjects of this system, what information belongs to each object, how do objects relate to each other, what rules should never be broken. Now let's go through a real world analogy to understand this better. Imagine you're designing a hospital data system. You don't start by randomly creating tables. First, you think about patient's data table, doctor's data table, appointments table, departments table, prescriptions table, bills table. Then you start asking questions. Can a patient have multiple doctors? Can a doctor treat multiple patients? Does an appointment exist without a patient? This type of thinking is nothing but data modeling. SQL syntax comes later in the picture. Why data modeling comes first is because of some reasons. First, many beginners jump directly into creating tables. Start inserting data, worry about queries later. Now, let's discuss this in terms of professionals. Professionals design the data model first, validate relationships next, anticipate growth in the future, and prevent any type of inconsistency. Data modeling is about future-proofing your dataset. Now, this makes our transition to the part 2 of this module, primary keys, the primary identity of any data. Let's talk about the most fundamental concept in relational databases. What is a primary key, you ask? A primary key is a combination or a column of columns that uniquely identifies each row in a table. Every record must have one identity, one unambiguous reference. In simple terms, a primary key answers one question. how do I uniquely point to this exact row? Now, why primary keys exist? This is one particular and critical insight. Imagine a table without a primary key. You have two customers with the same name, same city, and same phone number as well. Now you ask yourself, which row do I update? Which one do I delete? Which one does a specific order belong to? Now your answer. Without a primary key, data becomes unreliable. That's the answer. That's why we do have a primary key. It's like an identity for your data entry. Let's understand through a real world analogy. For example, government identity. Your name can change, your address can change, your phone number can change. But the passport number, the Aadhaar number, social security number, which will not change. This uniquely identifies you. That's exactly what a primary key does for a row. Now, let's discuss the characteristics of a strong primary key. A good primary key should be unique, no duplicates ever, it should not be null, its identity cannot be missing. Third one is it should be stable, should not change over time. And next one is it should be minimal, prefer single column keys. Now, let's understand one difference between natural keys and surrogate keys is very important. Natural key comes from business data. Example, email, username, PAN number, etc. Now, what are the problems here? So the problems are this can change, this can be duplicated, it can be tied to business rules. Now, let's understand the surrogate key. Surrogate keys are artificially generated ones. For example, auto increment ID. What are the benefits of using surrogate? They are simple, stable, and efficient for joins. Most modern systems use surrogate keys to enforce uniqueness separately. Now, a quick interview tip. Should email be a primary key? A most mature answer is email can be unique, but emails can change. Better as a unique constraint, not as a primary key. Now, we make transition to the part 3 of this module. Foreign keys, which are connecting the data world. Now comes the concept that makes SQL relational. So what is a foreign key? Foreign key is a column in one table that references the primary key of another table. In simple terms, a foreign key relates a relationship between tables. Why foreign keys exist? Now the next question is, why foreign keys exist? Instead of duplicating data, department name, customer details, product information, we store it once, reference it everywhere. This ensures consistency, reduced storage, cleaner updates. Now, let's understand through a real world analogy. Booking a flight. A ticket references to passenger ID, flight ID. The ticket does not store passenger name repeatedly, aircraft details repeatedly. Foreign keys keep systems normalized and scalable. Now, let's go through referential integrity, a non-negotiable rule. Foreign keys enforce you cannot reference a record that doesn't exist. You cannot delete a parent if children depend on it. This protects the database from orphan records, broken relationships, logical corruption. The next one is on delete and on update. These are business decisions. When a parent row changes, should child rows get deleted? Should they get updated? Should the action be blocked? Now to understand this, consider these examples. Deleting a customer with orders, usually it is restricted. Deleting a draft record, cascade is allowed. These are domain decisions, not just SQL syntax. Now let's make a transition to part 4 of this module, relationship types, how data connects. Understanding relationships is the heart of modeling. We have a wide variety of relationship types. Let's start with one-to-one relationship. One record in table A maps to another record in table B. For example, user data table to profile data table, employee data table to ID card data table, person data table to passport data table. Now the next question is, when should you use one-to-one relationship? It is rarely but intentionally used when sensitive data needs separation, optional data exists, performance optimization is required. Now let's consider an example. Authentication data separated from user profile. Now the next type of relationship is one to many or one to n. This kind of relationship is most common. One record in table A maps to many records in table B. Examples, customer table to orders table, department table to employees table, user table to post table. This is the default relationship in relational databases. What's the implementation rule? The foreign key always sits on the many side. This rule alone clears 70% of beginner confusion. The next one is many-to-many relationship or M is to N relationship. Many records in table A relate to many records in table B. Some of the examples are students table to courses table, products table to orders table, movies table to actors table. Now, junction table concept. Relational databases resolve M to N using a third-party table, two foreign keys, optional extra attributes. This table often stores timestamps, quantities, status, grades, etc. With that, we make a transition to part 5, which is about ER diagrams. It is basically about thinking visually. An ER diagram is a visual blueprint of a database. It shows tables, columns, primary keys, foreign keys, and relationships. Now, why ER diagrams matter in the real world? Before code, architects use or draw ER diagrams. Teams review them. Business rules are validated. ER diagrams prevent rework, confusion, costly redesigns. How interviewers use ER diagrams could be a question. So they want to see logical thinking, relationship clarity, normalization awareness. You don't need fancy symbols. Clarity matters more. With that, we make a transition to part 6 of this module. Normalization, which is about keeping the data clean. Now with that, we make a transition to part 6 of this module, which is about normalization and keeping the data clean. Now, let's talk about one of the most misunderstood topics. What is normalization? Normalization is organizing data to minimize redundancy and dependency. In simple words, avoid duplicate data, avoid inconsistent updates, protect data integrity. Now, why normalization exists? Without normalization, same data stored in multiple places, updates miss same rows, reports contradict each other, and the data trust collapses. Now we have a few different types of normalizations. So the first one is 1F or the first normal. It is about atomic values and no repeating groups. Now a bad format will be phone 1, phone 2, and phone 3, and a good separate phone table is the best example for this. Now we have this second normal form, which is 2NF, and the rules are in 1NF, no partial dependency, and it applies mainly to composite primary keys. Now we have the third normal form, which is also known as the 3NF, and the rules are in 2NF, no transitive dependency, meaning non-key attributes depend only on the primary key. Now let's understand the difference between normalization versus denormalization, which is a real-world trade-off. OLTP systems, highly normalized, write consistency matters. Analytics systems, often denormalized, read performance matters, and professionals choose intentionally, not blindly. And with that, we make a transition to part 7 of this module, which is about real-world case study on e-commerce modeling. Let's design a simple e-commerce system verbally. So we have the following entities. We will be having users, products, orders, order items, and payments. Now let's discuss the relationships. Users are connected to orders in 1 to n, and orders are connected to order items, which is also 1 to n. And the last one is product to order items, which is also 1 to n. No direct order to product, which is m to n resolved via order items. This is real world modeling in action. Now let's make a transition to part 8, which is about common beginner mistakes. Let's quickly cover some mistakes professionals avoid. So some of the mistakes are using names as primary keys, storing repeated values, missing foreign keys, over-normalizing early, ignoring future growth. Avoid these mistakes and you already think like a pro. Now we enter the part 9 of this module, which is about interview mindset and how to answer design questions. Interviewers want thought process, trade-off awareness, business understanding. Always explain why you choose a structure, why you rejected alternatives, how it scales. Now, a simple summary. Why this chapter changes everything. This chapter transforms how you see databases. You no longer memorize syntax, fear joins, or guess relationships. You now understand structure, design confidently, think long term. This is the difference between a SQL user and a data professional. So now we have entered module 9, which is about indexing and performance tuning. This module will help us understand why indexes matter, creating and using indexes, and query optimization tips. Now, let's have a quick introduction. Why performance is a career skill. Before we talk about indexes, let me tell you something very important. Most SQL learners stop at select, where, join, group by commands. But professionals are judged on performance. In real companies, no one praises a query that works. They praise a query that works fast. They praise a query that works at a scale. And here's the truth. Performance problems don't show up in small datasets. They show up in production. This chapter is all about why some queries are fast, why others slow down as data grows, and how databases search data internally, how indexes change the game completely. If you understand this module, you'll write scalable queries, you'll pass performance-based interviews, you'll avoid production outages, you'll sound like someone with real experience. This is not about memorization. This is about how databases link. Now, the part one of this module. Why indexes matter, how databases find data. So, let's start with a simple question. How does a database find data? Imagine a table with 10 rows. It could be fast. And if you have 10,000 rows, maybe your query is manageable. 10 million rows, already you might be thinking your query could be slower. And in case if you had a billion rows, it's a complete disaster. So without indexes, this could become a reality. Now, without an index, the database performs a full table scan, meaning it checks every row one by one until it finds what you asked for. That's like searching for a name in a phone book without an index, reading every page from start to the end. Now, a real-world analogy. Book index versus page-by-page reading. Think of a textbook. If you want to find out a normalization topic, you don't have to read every page. You go through the index, find the page number, jump directly, and that's exactly what a database index does. Now, what is an index? An index is a separate data structure that stores column values in sorted order without pointers to the actual rows. In simple terms, an index is a shortcut for finding data quickly. Why indexes improve performance is your question, right? Indexes reduce disk input-output operations, CPU usage, query execution time. It is especially for where conditions, join conditions, order by conditions, or clauses and group by clauses. Now, important reality check indexes. They speed up reads, slow down writes. Every insert, update, delete commands must also update indexes. So indexes are not free. This is why indexing is a design decision, not a default action. Now, with that, we make a transition to the part 2 of this module, which is about how indexes work internally. Now, you don't need to be a database engineer, but you must understand the intuition. Most databases use B tree or B plus tree structures. Conceptually, data is stored in sorted blocks. Each block points to a child block. Searches are logarithmic, not linear. This means searching 1 million rows is almost equal to a few steps. Searching 1 billion rows is also still manageable. Without indexes, search time grows linearly, performance collapses at a scale. Now, let's understand the difference between clustered and non-clustered index. First, clustered index. It defines physical order of data. Table can have only one and it is often a primary key. Now, non-clustered index. It's separate structure. Multiple clustered indexes are allowed, points back to table rows. You don't need to memorize this just now, you just understand. Some indexes control how data is stored, others act as lookup maps. And with that, we make a transition to part 3 of this module, which is about creating and using indexes. Now, let's talk about practical usage. Basic index creation. Indexes are created on columns that are frequently searched, frequently joined, frequently filtered. Now, some of the examples are like user ID, order ID, email address, and other foreign keys. When should you create an index could be your next question. You should create indexes when table size is large, queries use where on that column, and joins happen frequently, and sorting is very common. And the next topic is about selectivity, which is a key performance concept. High selectivity. Column has many unique values. For example, email, user ID, and low selectivity are few unique values. For example, gender, status, active or inactive. Now, indexes work best on high selectivity columns. Composite indexes sometimes queries filter on multiple columns as well. For example, a department ID is equals to 2 and salary is greater than 90,000. A composite index on department ID and salary can significantly improve performance, but order matters. Department ID, salary is not equals to salary, department ID. Indexes follow left to right rules. Indexes and joins, very important part. Indexes on primary keys, foreign keys make join operations faster, more predictable. This is why foreign keys are often indexed. Now, we make a transition to part 4. Query optimization is not magic. It's about reducing work, reducing data scanned, helping the optimizer. Now, the rule 1, avoid select stuff. Select stuff fetches unnecessary columns, increases input-output operations, slows network transfer. Always select only required columns. Rule number 2, filter early. Use where conditions as early as possible. Filtering early reduces rows, improves joins, and improves aggregations. Now comes rule number 3, index where and join columns. If a column appears often in where, join, order by, it's a candidate for indexing. Rule 4, avoid functions on indexed columns. Now let's go through an example which is bad, where year of order date function is equals to 2025. Now let's also go through a good example, where order date is between 2025 1st of January and 2025 December 31st. Functions can prevent index usage. Now the rule number 5, use explain. Most databases provide explain and explain analyze. These show query plan, index usage, and scan type. Professionals always check execution plan before optimizing blindly. Now comes the part 5 of this module, which is about common performance anti-patterns. Let's talk about mistakes that kill performance. First anti-pattern, over-indexing. Too many indexes, slow inserts, slow updates, and increases storage. Indexes should be intentional, justified, and reviewed. Second anti-pattern is indexing everything. Not every column needs an index. Indexing low selectivity columns rarely helps and often hurts. Now, third anti-pattern, ignoring data growth. A query that works today may fail at a scale or may time out later. Always ask, what happens when this table has 1,000,000 rows or 100,000,000 rows, right? Now, the fourth anti-pattern is blind optimization. Never optimize without measuring, without understanding the plan. Premature optimization is often dangerous. Now comes the part 6 of this module, which is about real world scenarios. Now the first scenario, slow dashboard query. Millions of orders filtered by date range, grouped by customer. Now the solution for this problem, index on order date, composite index if needed, and avoid select star. Now the second scenario, slow join query. Orders joined with customers, foreign key is not. Now the quick fix for this problem is index foreign key, reduce join columns, and check execution plan. Now comes the scenario number 3, which is about reporting versus transaction systems. OLTP, normalized index for writes plus reads. Analytics, denormalized index for reads, sometimes materialized views. Now comes the part 7, which is about interview perspective, how to talk about performance. Interviewers don't expect perfect tuning, deep engine internals. They expect awareness, trade-off thinking, real-world mindset. Good answers mention indexes, execution plans, data volume, and query patterns. Now, some of the bad answers that you should avoid are add indexes everywhere, use faster hardware. A little summary of this module. Why this module makes you professional. Anyone can write SQL that works, but a very few can write SQL that scales, performs, survives growth. This module moves you from beginner level SQL thinking to production ready SQL thinking. From here on, you won't fear slow queries. You will reason about performance, you will design smarter schemas, and you will earn trust in real teams. And with that, we make a transition to the next module.
The types of joins in SQL. So before that, let's understand what exactly is a join in SQL. In SQL, joins are used to combine rows from two or more tables based on a related column, or you can also call it as a primary key. They allow querying data across tables by specifying conditions that define the relationship. Joins are essential for accessing normalized data effectively in relational databases. Now proceeding ahead, we will understand the different types of joins available in SQL. So there are multiple joins available in SQL, but the primary ones that you need to focus on are these 5. So they are inner join, left join, right join, full join, cross join, right? And each of these joins will have a specific purpose in combining the data. Now, let's have an in detail understanding of each of these joins, starting with the inner join. So an inner join retrieves rows that have matching values in both the tables on specified condition. It only includes records where the join condition is true, excluding unmatched rows. So here you can understand this first circle to be as table A and the second circle to be as table B. Now where it finds a match, that means the common data entries in both the tables are the only ones to be extracted. So that's how an inner join works. Now the next one is the left join. A left join retrieves all rows from the left side table and the matching rows from the right side table. If no match is found, the results include null from columns from the right table. So you have so far understood the inner join, right? So it only presents the data entries which are common in table A as well as table B, right? Now the left join is a little escalated or a little enhanced than the inner join. So it gives all the entries of table A, but along with that, it also tries to pull the matching entries from table B. Let's say you have got 10 entries in table B, which are in match with table A. So those entries are also pulled. That part of the table is also pulled in the left join. Now let's proceed with the third type of join, which happens to be the right join, which is completely similar to the left join, but the only difference is this time you're pulling the data from table B and the common values or common entries from table A, right? So a right join retrieves all rows from the right table and the matching rows from the left table. If no match is found, the result includes nulls for columns from the left table. Now, let's proceed with the full join or full outer join. Now, this acts like a bit differently, right? Whenever you wanted to club two different tables with all the entries, let's say the master data table has 10 columns, right? But for some reasons, you choose to split those 10 columns amongst two different tables. The first 5 to 6 columns will be in table A, and the next 4 to 5 columns are in table B, based on your requirements, right? Now, there comes a situation where you need all the 10 columns in one particular situation. So this is where you come across the full outer join or full join. So this particular full outer or full join does one thing. It combines all the columns from the A column or A table and all the columns from the B table and also the ones which are in common between both, right? So this is how a full outer join works. Now, the last type of join is the cross join. Cross join produces a Cartesian product of two tables, pairing every single entry of the first table with every single entry of the second table. So this particular image here will explain you how a cross join works. So the first entry in table A is matched with all the entries in table B. Similarly, the second entry of table A is combined with all the entries in table B. So this is how a cross join works. So far, we have covered the theoretical explanation of all the 5 joins present in SQL, starting from the inner join, left join, right join, full join, and lastly, the cross join. Now it's time for us to go a little practical. Now we will start the SQL workbench and try to execute some of the queries. Now we're on the SQL workbench, so our data is saved in this particular database, which is named as car dealership. And let's run the query. There you go. And let's also check our tables. So here you can have access to the tables, and these are the columns: order ID, state, region, customer ID, customer name. And if you close this, here you have your second table and expand the columns. And you have your columns here: order ID, delivery date, delivery days, and days to be delivered. Right? So you have two different dates: the order date and delivery date, and days to deliver. If I only, oh yeah, you have another section here where you can read, and category, product, fuel type, etc. These are the columns you have in both your data tables, right? So you have a clean visual of your data table. Now let's start with our use cases. So we have mentioned our use cases here. So one for each type of join. So the first join is inner join as mentioned here. And now the inner join is identify customers and the products they purchased. We want to find the names of the customers and the products they purchased, ensuring the data exists in both customer data and dealership data. Now let's write a query for that. So the query will start with the select statement, and we wanted 3 columns here: the customer name, product name, and dealership name, right? So let's push them out, right? Customer name is the first column that we are trying to pull, and followed by that we have the product name that they purchased, and dealership name from the table, which happens to be the customer data. And remember, I'm using smaller case letters for the variables or the table names or the column names, and capital letters for the keywords, so that the reader can automatically understand what is what, correct? Now we want to perform an inner join with the dealership data. So you can just copy this and paste it here so that you can eliminate this and just write it down as dealership data on. I want to join on two primary keys, which is order ID. So to make sure that there is difference between the order ID from customer data and order ID from dealership data, I'm using this particular approach. So now customer data dot order ID and dealership data dot order ID. The query is done. Now let's quickly run this. Select this particular query and run. There you go. Now we have the data that we were looking for. There you go. So we were looking for the customer name, product they purchased, and the dealership. And here we have. Now let's proceed with the second use case. So now we will be performing the left join, and you are similar with the left join. Here we will be pulling out the data from table A, which is the first table, and also the matching entries from B table, right? Now list out all the customers, including those who have not purchased anything. We want to display all customers and any purchases they made. If no purchases exist, it should show as null for product and dealership information. Now let's write the query for this particular request. Start with select, and next we want to specifically mention the column is from customers table. So customer name as customer, comma. The second one is dealership data dot product as product purchased. Third column is dealership data, dealership name. Make sure you remember the names of the columns. If there is a small error in your column name, the query might fail. So make sure you keep the column names simple and rememberable. The table customer data, C, and I want to join now with dealership data. So use the join or left join, since we are performing specifically the left join. And the left join is upon dealership data. So what you can do is mention the dealership data name here. It's D. On what condition? This is a different database, don't worry. On the condition order ID, customer.order ID is equals to the dealership.order ID. So we can simply place order C.order ID equals to D.order ID. There you go, semicolon, and the query is ready for execution. So select the entire query and run that one single query, and there you go. So we have the customer name, product purchased, and the dealership name as well. So the third use case is identify all dealership orders, including ones without an associated customer. We want to see all the orders processed by dealerships, even if there is no customer information associated with them. Now, for this, we will write the query as follows. Begin with select, as usual. Don't even if the MySQL Workbench gives you recommendations, don't choose that. Go with the use case thing so that you identify which is a keyword and which is not, right? Now, d.dealership name as dealership, comma, d.product as product purchased, comma, c.customer name as customer, From which table? So it will be from the table customer and customer data, and mention it as C, so that it is easier for us while writing the join query. Customer data C, and now we will be performing the join. So since we are specifically focusing on right join, use right join, and we are joining it with another table, which is dealership data, and mention it as D, and the condition is on which columns? C dot order ID equals to D dot order ID, and semicolon. Now let's quickly select the entire code and execute this. Now I have selected the entire code, execute, and here we have. So we have all the dealership orders, including the ones without an associated customer, and we have all the orders processed by those dealership, even if there are no customer information associated with them. Now moving ahead, we have our last but one, the fourth use case for today's session, which happens to be the full join. Okay, I didn't mention it here, so let me add it here as well. Full join or full outer join. Let's mention it as full outer join. And here goes the use case. So the use case is generate a comprehensive report of all customer orders and dealership orders. We need to complete dataset of all customers and dealership orders, even if they don't match. Now let's proceed with the code. So in this particular aspect, we might want to proceed with an union. But anyways, let's start writing the code. Select, tab, and what we can do is we can borrow the data from this code as well. So we want customer name as customer, and we want order ID as customer order ID. I think we missed a comma here. That's the error. Okay, not a problem. Now the next one is we want D dot order ID, dealership order ID, comma, D dot product as product purchased, comma, the last one, D dot dealership name as dealership, from which table? I want it from the table customer data, and I will short term it as C. Customer data C, enter. I want to join this, so I'll proceed with left join with dealership data E on the terms, on the condition C dot order ID equals to D dot order ID. Now we will unite them by using the union command, and we will copy paste the same keywords or column names here. Copy and paste. Make sure everything is fine. We have customer name, order ID from customer data, order ID from dealership data, product and dealership date. Now, from customer ID, sorry, customer data is the table as C, and I will be performing the right join. So both including left and right will complete as a full auto join. Right join on dealership data. Copy and paste it right here. And the condition is the same as before. Order ID should be equal in both tables, and semicolon. There you go. Now let's quickly select the entire code and run it. And we should be having our data here. So we have the customer name, customer order ID, dealership order ID, product purchase, and dealership. Now moving on to the last part of today's session, which is the cross join. And here's the use case. So the use case is create all possible combinations of customers and dealership products. We want to understand potential matches between customers and all available products in dealerships. Now let's proceed with the query for this particular request. So we will begin as usual with select statement. We are wanting to select customer name, product and dealership name. So why don't we just take it from here, customer name, and we wanted the product name as well. So we will take product name and dealership name as well. And we want this from customer data C, automata C for join. So we will be doing a cross join here for all the permutations and combinations, right? So basically the use of cross join is matching each and every entry of table A, the first table, with the second table, and the second table is dealership data D. Just paste it here, and that's our query ending. Now let's quickly run this query. Select the entire query and run. So there you go, we have the required data. So we have created all possible combinations of all the customers and dealership products, and we have understood the potential matches between customers and all available products in dealership. So SQL subqueries. So subqueries in SQL are majorly of three types, which are scalar subqueries, multi-row subqueries, and nested subqueries in SQL. So when it comes to scalar subqueries, it'll return one row and one column. And when it comes to multi-row subqueries, there are two types. It can either give you one column and multiple rows, or multiple columns and multiple rows. And the last one is almost kind of self-explanatory, which says it is just a subquery inside an already existing subquery, right? So without further delay, let's get started with the MySQL Workbench, load our dataset to the MySQL Workbench, and try to query some subqueries based on the use cases that we are able to build on the dataset that we are using, right? And this might be an interview question, so where exactly can you use a subquery? So you can use a subquery along with the where, along with having, along with between, along with a select query, maybe insert, right? There are multiple possibilities. Just try to name a couple of them, maybe a 4 or 5, which makes you stand on the safer point during your interview. Now let's get started with the MySQL Workbench. Now here we are. The first thing that we will be doing is load the dataset. So just click on this new schema. So new schema is nothing different from your new dataset. So let's name it as Superstore and apply. It requires lowercase, so let's proceed with the lowercase as well. Not a problem. There you go. You have the new dataset or database. Now you need the dataset. So that dataset needs to be applied to the table. So currently we don't have any data in the table. Go to the import data wizard, browse, and downloads, and here somewhere I have SQL data. And remember to save your Excel data in the form of the comma separated file as CSV, and ensure that all your data table name and the column headers are compatible with MySQL or SQL. So basically what's the problem is, let's say you have some maybe the difference in naming convention, row space ID, right? So that could cause a problem when you are kind of trying to write a statement, right? So here I've already done that, row ID, order date. So I've replaced with an underscore wherever I found a space so that it becomes automatically SQL compatible, right? Now the first row might be having a small error due to the import function, but that's something that we can fix. So let's also check other column names or column headers over here. So every other column header looks absolutely fine, but the first one, which happens to be a small import error, but that's something we can fix. So go to the next and press on next. So this is about 9,000 to 10,000 rows of data, which might take a little while, but that's not a problem. Let's wait gently. There you go. The data got successfully imported. Now the next step is just click on the next here, and yeah, therefore we have our 9,987 records imported successfully. Finish that, and we can close this schema, and now refresh the data set here, just right click and refresh all. And there you go. You can see the arrow mark here. Just click on that. You can see the Excel data set. So here we have all the columns and remaining things what we require. So here are the columns. Now let's quickly use the data set. The data set name is Superstore. So this is the Superstore data set. So we have also named the database as Superstore. Just run it. Now we have the full access of Superstore. Now you can just run the select star from the table name is Excel data, and we have query ready, and just run it, and we have the entire table right here. Yeah, so remember we were supposed to change the row name, right? So you just hover over this and I think you'll get an option of copying the field name. Copy the field name. Now use the alt table Excel data, the name column 2 row. Go. So we have done it. You can just run this query once again and make sure that everything is fine. There you go, row ID. So far so good. Now let's get started with the subqueries. So as we discussed before, there are 3 different types of subqueries. Basically, scalar subquery, multi-row subquery, and nested subquery. So let's start with the scalar subquery. So there you go. Now we know scalar subquery will give us 1 row and 1 column. So according to that, let's try to devise a use case. So let's find out the list of customer names that made a purchase above an actual average, right? Let's say we have the customer names and customer IDs. Let us say that, okay, let's find out the average sale, the overall sale, right? So there might be a few customers who might have basically some deep pockets, basically they're rich, and they might have, purchased some goods from the store, billing more than the average of overall sales, right? We need to find out such customers so that we can basically offer them some discounts and maybe a few more coupons, something like that, so that encourage them to shop a bit more. That sounds like a use case, right? So let's get ahead with that. Let's write the use case. So that's our use case right there. So first we need to find out the average of all the sales. So let's write the query. You write the query by select and an aggregate function which is average avg sales. So we have sales data here from table. Let's copy the table name Excel data semicolon. So this is our first query, or you can also call it as an inner query. So the average sales is about $294, right? So this is our average sale. Now we need to use this inner query. We need to devise this as an inner query and write an external query where we will find out the customer names, right? So let's write that. Select customer name, customer underscore name from Excel data. So you can see that I'm using the naming conventions in a different way. The keywords are all caps, and the table names and the column names are in small, right? So this makes things easier for anyone who's reading your code. So they'll understand that this is, a variable name or maybe a keyword. So they'll easily identify that. So this happens to be our outer query. So select customer name from Excel data where sales are greater than average of sales. This is our inner query. So you can name it as outer query, and we have already named it. No, we didn't, but we can name it as inner query. So this increases the readability of your code, right? So now if we execute this, we can get the output. So we have so many names here, but we happen to require, as we can see, we have duplicate entries of data, right? So we can make minor changes over here. What we can basically do is use a group by function, and let's group them by customer names. And as a fact, we know the sale number, right? So let's include sales as well, so that we have customer name right in front of the sales what they made, and we can have a clarification if they cross this 294 number, correct? And since we're using group by, and in that situation, let's replace where with having. Now this is a correct query. So that's the explanation, right? So you can use subqueries along with have, along with where, along with having, and select, right? So let's try to execute this code, and we should be having the output ready, right? So we have our customers, and they have made multiple sales here, right? So they might have come to the store multiple times, and they might have made multiple sales, right? So here they have made multiple sales which are above the given sales number. Now let's proceed with the next query, which is the type of query is multiple row subquery, the second type of subquery, right? So let's rename this as multiple row subquery. So why am I doing this? So this document will be an open source document, so that you can have access to this document while you are learning. This will be linked in the description box below. You can just download the dataset. You can just download the query document and try to follow us for a better learning experience. Now let's go with the problem statement for this. So it is something which gives you multiple rows and multiple columns in return. So now let's try to build a use case for this. So the use case is, let's try to find out, okay, let's execute our first query over here. So we have city, right? We have city, state. So now let's try to find out that particular state which has highest sales, right? So let's try to identify any state which has more than 100 sales. Let's say your manager just gave you a use case to find out that single state where we have maximum sales happening. So the sales number should be nothing less to 100, so that we can target the product more, right? So for that particular situation, we can go with this particular solution. So again, there are two parts of this, and firstly we will try to find out distinct states names, right? Select state from Excel data where sales is greater than $100 close. So this is the inner query. Let's execute this. So these are the states. Now we wanted a distinct allocation, right? So let's try to roll this state under distinct function, so that we have those distinct states. So one state might have faced multiple sales which are above $100, right? So we just wanted to know which are those states which are giving sales at least above $100. So that's the inner query. Now let's try to wrap it under an outer query, where we will try to find out the same thing. And we can do one better. So what we can do is, since we already had multiple states in the list, let's try to find out a city or state that has less than $100, right? So why don't we do that? Let's select distinct states or state from Excel data where state is not in, where state is not in, where state not in is not required over here. And you can open the bracket, and you can wrap this inside an inner query. Close this. There you go. And if in case you wanted to provide some indentation, you can also do that, and your query is done. Now if we execute, we can find out those states which are not yielding at least 100 sales. There you go. So we have a list of 4 states which are not even giving us 100 sales, right? So in these sales, you can do two things: either stop your store, or you can give some exciting discounts on your products, so that you can drive some motivation in the customers to buy some things. Now the next use case is, let's try to find out some product names from subcategories that get higher sales than all the products in their subcategory, right? So this is another example in multiple row subquery. So let's try to execute that. Let's write down the use case first. So we have the use case ready. Now let's try to write the query. Select product name. Let's also try to extract the subquery, right? That should be helpful. Subcategory, not a subquery. Maybe we can also extract sales numbers from Excel data, and let's try to alias them as E1, where sales is greater than, so this is the outer query. Now let's try to build the inner query. Select average of sales. We wanted to find out that product which is selling more than the average of all the sales, right? Sales, wrap it under the average function. From Excel data, we can alias it as E2. So why am I doing this aliases over here? Because there is a funny thing, not actually funny. So this is an important thing which you might have to consider, because these aliases will help us to write a query in such a way that the query will run only when it has some value from the outer query. So far here, if you run this query, the inner query, it will actually run without any error. And when you execute it along with the outer query, it will run, right? But in the current situation, the current query which we are writing here, it will not run unless it is clubbed with the outer query. How? Let's check it. So I'm going to write a where query right next to this, where E1 dot subcategory is equals to E2 dot subcategory. You can just copy paste this to save time in the interest of time and close the bracket, right? Now, if you try to execute this inner query, it will never execute. It will throw an error, right? Now, if you club this along with the external query, it will run. So if the query is heavy, sometimes we might lose the connection to the data set or the server. It's okay. At times, we can just optimize the query and try to get an alternate result. So you can see it's running over here, fetching. We should be receiving the output shortly. There you go, we have the data. So based on that particular subcategory, we have accessories, we have labels, appliances, right? So it's like you are grouping all the categories available in your data set, and you're calculating the average of sales happened in that particular subcategory. Now you have that average number, right? And if any product in that subcategory is selling above the average of that particular subcategory, we are extracting that product name, right? So SanDisk, numeric keypad, Bluetooth. So these are some products which are outselling in those respective categories. So we're basically trying to find out the best performing products of all the individual categories, right? Now let's proceed with the next query. Let's proceed with our third type of subquery, which happens to be the nested subquery, right? Now let's devise a use case for this. So the use case is find the customers who have placed orders for products from specific category and whose total sales exceeded the average sales of all the customers, and who have placed orders for products from the same category, right? So this is the use case. Now we can devise a solution in 5 steps, as I have mentioned already here. Identify the customers who have placed orders for products from specific category. That's the first step. Then, for each of these customers, calculate total sales for products from the specified category. And then, calculate the average sales of all customers who have placed orders for products from the same category. Fourth step is compare the total sales of each customer from step 2 with the average total sales from steps 3. And lastly, return the list of customers whose total sales exceeded average of all sales. Now, this is a little complex to understand, but again, not to worry about. We will devise the solution one step at a time, right? So we will write the query inside a query inside a query, right? So we will be also using some join clauses in between. So that's how it's going to work. So let's quickly write the query. So the first query that I'm going to write is find the customers, identify the customers who have placed the orders for products in specified category. So select customer ID. Let's also try to calculate the sum of sales that they provided. Sum of sales. And let's call it as an alias as total sales, right? So far so good. From Okay, let's try to add an underscore. I've missed that. Excel data. So the thing is, for a specified category, right? For a specific category. So the query is a little interesting here. So okay, let's quickly run our query here where we will identify what categories we have, right? So select category from Excel data, right? So we will identify which categories we have. So we have office supplies, technology. Okay, let's try to identify it as distinct so that we have the unique names of our categories. So now we have the unique names of our categories. We overall have 3 categories. Now the use case is they want to find out the sales from a specific category. Right, now let's provide the category as, I don't know, I like technology. So let's try to add the specific category as technology from Excel data where category is equals to, remember the double quotes or single quotes because we are using dealing with character type data type. So technology, or you can just copy field, right? So we don't want to take any risks here. That's the first query. Close and try to execute. Yeah, we missed group by, so what you can do is just add a group by. Let's group by customer ID. There you go. So based on the customer ID we have grouped it. Now this would be our inner query, and before we close it, we will alias it as customer sales. Okay, that should be the good name for it. So close this using a bracket and also begin this using a bracket and name it as customer sales. There you go. So the first part of it is done. Now we are going to implement the join function. Now based on what are you going to join this, we will be using the same query. We will be making a mild modification onto it. E1 dot customer ID. Let's copy paste. And this E1 dot customer ID should be equals to customer sales dot customer ID. So far so good. Join. We will copy paste the same query over here. This should be our inner query, and the outer query, try to select average of total sales, average sales from, and try to make some indentations so that it's easily readable and understandable. So I don't think we will be needing the customer ID here. All we need is sum of sales. We will name it as total sales from Excel data where we have the category. Okay, we have grouped it, and now let's close it and alias it as average sales. Okay, on customer sales, okay, we will join this on customer sales dot total sales, and this should be greater than the average sales of that particular category. Sales dot average sales. So far so good. Now we have devised the inner query and outer query. Now we need to take care of what are we going to extract from this, right? Now we want to extract distinct names. Okay, this might give us a lot of names, so we want distinct names, distinct of E1 dot customer ID, comma E1 dot customer name as well. So let's go with customer ID and remove ID and type down name, and we are extracting this from Excel data. Let's alias this as E1. This is our E1 table. Okay, and now we are going to join this. There you go. Now let's try to execute our query. So we have taken care of all the indentations and subqueries and nested queries, and if we run it, we should be getting the data. There you go. So we have extracted, basically we have extracted the required Find the customers who have placed orders for products from a specific category, so technology category, and whose total sales exceeded than the average total of all the other customers. So in the technology segment, the average sales of all the other customers should not be, so there are specific customers who bought a lot of technology stuff, and their sales is actually more than the overall average of all the other customers who placed technology orders in the same segment. So that's what we have found here based on their customer ID and customer name. So we basically executed all three types of subqueries, which is scalar subqueries, multi-row subqueries, and nested subqueries.
Imagine walking into a giant library. This isn't just any library, it's huge. There are rows and rows of shelves, each packed with thousands of books. But wait, you don't need to read every book here. You're just looking for specific ones like books about space or stories about superheroes. But finding what you need is such a huge library. That's going to be tricky. This massive library is like a database. A database is a huge collection of information stored neatly, ready to be used. It holds everything: name, address, grades, prices, whatever data you can think of. But sometimes all that information can be overwhelming. You don't want to shift through everything every time. You need something specific, right? That's where views comes in. In this video, we will explore views in SQL, explaining what they are and how they simplify working with databases. We'll also cover how to create views, manage them by updating, deleting, and listing them, and also introduce different types of views like simple, complex, read-only, and those with check option. We'll also dive into materialized views which store data for faster queries. And by the end, you will understand how views can manage data easier and more efficient. We will also look into a quiz question to clarify your understanding. So, what exactly is a view? Let's go back to our library example. Imagine if you had a magic window, a special one that only shows you the books about space or superheroes that you are interested in. You don't have to wander through the entire library anymore. You just look through your magic window and it gives you exactly what you need. That magic window is what a view is in the world of databases. A view is a special virtual window into a data that shows you only what you need to see. And the best part is, it's not actually storing any new data, it's giving you a filtered look into a huge database. Think of view as a shortcut, making your life a whole lot easier. So let us get into the demo part about how to creating a view and the types of views in SQL.
So let's start with the demo part, that is how do we create a table in MySQL. So here, as you can see, I've just logged into an online compiler, and now we will just learn how do we create a table, and then we'll move on to creating views and the types of views. So first, to create a table, just enter this command, just write over here, create table, and this, just enter the table name. It could be something like student details, and here you can give the student ID name. We want a student ID name in the first row, so we'll just keep SID, and the type of the variable is integer, so we'll just mention int over here, and since it's a primary key, we'll just mention it over here, primary key. Next variable can be something like name, and for this the type is varchar. You can just enter any number here. Suppose I've entered 255. Comma. Next, mention the address. Again, it's varchar address. So as you can see, we have created this table with student ID name. So we have to give your underscore. Student ID name with primary key integer type, and the name and the address over here. So after we have created this table, we want to insert data into the table. This is our next step. So to insert data, what could be the basic command which you can write? Can be something like insert into student, the table name, student details over here, and just mention what all columns which we have, attributes we have created, which is S underscore ID. Next is name, and then we have address over here, and then we mention the values. So now that we have created table, and then we can enter our details over here. So these are the values which I've inserted, which is Harsh, Ashish, Pratik, Dhanraj, Ram. Okay. So like this, you can enter the values over here. And now if I want my records to be displayed here, the command which I'm using is select star from student details. So all these, the table will be shown here. So we'll just click on this run button over here. Okay, so now you can see this is the SID name, number, and the names which we have mentioned over here. So as you can see, this is the output generated. This is the SID, the name, and here is the address. So as you can see, the table is created now, and the output is also shown. Now we will move on to the main step, which is creating a view. So what exactly is a view? A view is like a window that lets you see specific data, as I've already told you in the intro part. So now let's say we only care about students with SID less than 5. Okay. And instead of running the same query every time, we want to create a view. So here's how you can do it. You can just simply enter a command. So here's how you can create a view. So just mention this command, which is create view detail view as select name, comma, address from student details. So student details is the table here which we have already created before. And I want the student ID less than 5. Okay. So I want this to be shown here. So we'll just simply click on run over here. So as you can see, this is the error it's showing. Why is it showing? Because line number 20, create view, must be the first statement in a query batch. So to resolve this, we have to ensure that the SQL batch is properly separated by go command and the view creation is syntactically correct. Alright, so we haven't used the go command here to do that. We just simply, after we have inserted our records in the table, here you just type go, okay, and so this is the end of the first batch. And now since we have created a view in a new batch, we'll just mention this whatever command we have already given, and at the end of the second batch we'll again write go. Okay, and now next I want my query to be shown here, so I'll just write this command for generating my output, which is select star from and the table name. Okay, not that student details table name. I want the view table name to be shown, which is detail view, right? This is the table name. So here, just copy it from here. Just paste it. Give this semicolon. So now you can see our view is created. So why have we used go? Because go ensures that the create view command is executed in a new batch, and this will help the SQL server properly separate commands and avoid conflict. Alright, and we have also used the select star from details view, which will fetch the data from the view and includes only student with student ID less than 5, which is Dhanraj, Pratik, Ashish and Harsh. Okay, name and the address is displayed over here. So this is our output generated. Now let's talk about managing views and updating the view. Let's say later on you want to update the view to also include the student's age. Instead of deleting or recreating the view, you can use create or replace view to update it. So let's add the age column to the table now. So we have to just insert the data for the students here. So to add a new column age to the students detail table, we need to use this command, which is alter table, and then provide the name of the table, which is student details, add age, and the type is integer, and give the semicolon over here. Alright, and now we have to insert the age data for the student. So to do this, we will use the update command, and here we will just write this update, okay, name of the table, which is student, and here we use set age is equal to 19, where SID is equal to 2. No, sorry, with SID is equal to 1. So in a similar way, you have to just update all the table over here. So after updating it, you can just simply search run here. So like this, you will just update the student details and set the age accordingly. And now the next step is, after updating it, we have, as you can see, we have just entered all the age number which we want to be displayed here. And we have used the insert to command to insert records into the table with the age values. And now in order to select it, we will give the command which is select star from and the name of the table which is student details. And now if we want to end this batch, we have to use this go command, enter. So now as you can see, we have updated and inserted all the age data for the student, and we have selected all the data from student details to display the final result by giving this command which is select star from student details, and this is the name shown over here, and here is the address, and this is the age. So we have inserted all the age data, and we have also corrected the update statement. Set age is equals to 19, where SID is equals to 1. And do not forget to add this go. Okay. Now, the next thing which we will be talking about is deleting a view. In order to delete a view, you just simply have to give this command, which is drop view if exists, and then give the name and the table name, which is detail view, right? And just simply you can go to this, just run, and you can see that our table has been dropped. Okay, so now we have deleted our table just by giving this command now. So, and do not forget that this command will delete the view, but don't worry, the data in the original student details table will not be affected. Only the view table which we have created is deleted. And now next we will be talking about listing all the views. Okay, so now in order to list all the views, just you have to simply write this command, which is show full tables where table type is equals to VIEW, view. So by doing this thing, this output will give you all the views which we have created in this table, the name, student ID, okay, and the addresses, and also the age. Okay. So it will give you all the view table which we have created. Now let's move on to the main part, which is the types of views in SQL. Now let us first understand what is a simple view. So a simple view is created from a single table. It's straightforward and it doesn't involve complex logics like joins or subqueries. For example, to create a simple table, you just simply have to write this command, which is create view student names as, and then select name from student details. Okay, so if you query this view and then write select star from student names. Okay, so after doing this thing, you just simply click on run. So after we have written this view, simple view, which is create view student name as, select name from student details, and do not forget again to mention this go, and then select query the simple view to display student names and select star from student names. Alright, and at last again add this go, and here this is the output generated, the names. Alright, so by using simple query you can do this thing. Now let's move on to the second part, which is creating a complex view. A complex view involves multiple tables or complex logic. let's say we have another table known as student marks that stores student marks. So let's say we have created this table student marks, and we have given the details here. And again, we have inserted the data values, student ID, marks, 193. These are the values which we have inserted. This is the student ID and these are the marks which we have given. Alright. So now let's create a view that pulls data from both student details and student marks. So now as you can see, we have created a complex view by providing all these details, and this is the student ID and the marks shown over here. Alright. So now let's move on to the third part, which is read-only view. So a read-only view ensures that no one can modify the data through the view. This is useful when you want users to able to see the data but not change it. To make the view read-only, you can use permissions in your SQL databases, and this feature depends on your database engine. To create a read-only view in SQL Server, we cannot directly enforce read-only behavior with the create view statement. However, you can control access to the view using permissions. So here's how you can do it. So first you can create the view normally. You can use revoke, insert, update, and also delete permissions from users for that particular view, ensuring that they can only read the data. So now this was all for the read-only view. Let's move on to the fourth type of the view which we are discussing today, which is the check option. So with the check option is SQL, which is with the check option. I'll just type here with check option. Okay, this is the fourth type of view which we are talking about with check option in SQL. It ensures that any insert or update operation performed through a view complies with the conditions specified in the where clause of the view. This means that you cannot insert or update records through the view that violate the condition of the view itself. So let's go through the creation of a view with the with check option and provide an example with an explanation and expected output. So now as you can see, we have the expected output for the valid insertion using this command, which is with check option. And with view creation with check option, we created a view named sample view, as you can see here, that selects student ID and name from the student details table, but only where the name is not null. Alright. So as you can see, we have clearly mentioned here not null. And the with check option ensures that any insert or update through the view must comply with the condition where name is not null. And the first insert into sample view inserts a student where student ID 6 name, which also has a valid name. And here is the output generated here. Alright, this is the student ID, the name over here, and that's it. So now we have learned about this with check option as well. Now I'll be talking about a materialized view. So what exactly is a materialized view? Well, a materialized view is different from a regular view because it stores the actual data in a database, meaning the data is pre-computed and doesn't need to be fetched from tables every time you query it. This makes accessing data from a materialized view much faster, especially for complex queries. Alright, so as you can see, we have created the table and we create three tables: the order details table and the product details and also the customer details table over here. And then we have provided the necessary data also. The second step was the sample data is inserted into all the three tables. The materialized view fast order summary is created to summarize orders, joining data from the three tables and computing the total cost. And the next step is the materialized view is queried, and because the data is pre-computed, it returns results very quickly. With new data, when added to the order details table, the materialized view is refreshed using refreshed materialized view to include the new data. Alright, I hope you get it. Why are we using the refreshed option? And the next step is the materialized view is deleted using the drop materialized table over here. We have used this drop materialized view, fast order summary, and in this way you can, create a materialized view. So now you might be wondering that what is the difference between the materialized view and the complex view and the simple view. I'll be seeing you that later. So first, let us now discuss why are views so useful. Okay. So, why are views so useful? By now, you might be wondering what's the big deal with the views, and here's why it's so useful. They make our life easy. You don't have to keep writing complex queries over and over. You create a view once, and it saves you tons of time. They also help you in simplifying data. Instead of pulling everything from your database, views can help you narrow down exactly what you need. They also help in improving security. Want to show only certain parts of the data to certain people? Use views to control what others can see without letting them touch the raw data. You can also rename columns for clarity. You can rename confusing columns in the view without changing the original table. So let us now discuss the differences between the simple, complex and the materialized view. So here's a quick summary of the differences. So simple view pulls data from a single table, no complex logic or joins involved, and it doesn't store data. It also, the performance is it executes every query every time, whereas the complex view, it combines data from multiple tables using joins, aggregates, or other complex logic, and it doesn't store data, executes query every time. And talking about the materialized view, it stores the result of a query, making it faster to retrieve data without running the query again. It also stores data and it is much faster as it uses pre-computed data.
By looking at the job posting, we can see enormous demand for SQL developers across the globe. From finance to tech companies, all of them deal with massive amounts of data. Therefore, these industries need to process and extract meaningful information from the data. SQL is basically used for accessing and managing data in relational databases. One of the advanced features of SQL that makes the data analysis more powerful is the use of window function. So guys, in this video, we are going to uncover the fundamentals of window functions that are going to help you understand various aspects of how they work. We will cover everything from what is a window function to different types of window functions, providing clear examples and practical use cases. So guys, let's start with what is a window function. So guys, a window function performs a calculation across a set of table rows that are somehow related to the current row. This is comparable to the type of calculation that can be done with an aggregate function. However, window functions do not cause rows to become grouped into a single output row. The rows retain their separate identities. So you'll be wondering, what exactly is an aggregate function? So guys, an aggregate function performs a calculation on a set of values and returns a single value. Common aggregate functions include, like we can have a sum, we can have an average, we can have max, we can have count. Okay, so these are some of the aggregate functions. These functions typically used in conjunction with group by clause to help the rows to have the same values in the specified columns into the summary rows. For example, the sum function can be used to calculate the total salary of each employee in a department. So how? Let me show you a command. So suppose we can write select. So suppose there is in employees table, we have a department. Okay. So from the department column, say we can take salary as argument. Okay. Salary field, and we can use alias as, and we are going to return the total salary from employees, and then we use the group by clause. So guys, in this case, the result set is grouped by department and each department's total salary is calculated, resulting in a one row per department. So guys, you'll be wondering what's the difference between aggregate function and a window function. While both aggregate and window functions perform calculations across set of rows, but they differ in how they present the results. Aggregate functions reduce the number of rows in the result set by grouping them, while window functions maintain the individual rows and add the calculated values as additional columns. For instance, guys, using a window function to calculate the cumulative sum of the salaries. So suppose we have this command, okay, and we have this employee table same. So suppose select emp id, okay, and here we have the department column, then we have the salary column, then we are using the aggregate function all over here, and that's salary. This is over, and in this we can take order by. So this is our clause, and we can take emp id all over here, and we can use the alias as, and in this we are trying to find the cumulative salary from the table employees. So guys, in this example, each row retains its individual identity, and the cumulative sum of the salaries is calculated and displayed for each row. This allows for more detailed and flexible data analysis without losing the context of individual records. So guys, I hope so you would have got a brief idea regarding this. Now let's move on and understand about what exactly is a window in SQL. In SQL, a window is defined as a set of rows that are related to the current row. The window is defined by the OR clause, which can include partition by, order by, and rows or range. Okay, so these are the certain things. So we have all over here partition by, okay. So let us discuss each one of them one by one. So guys, in a SQL, basically a window is defined as a set of rows that are related to the current row. And the window is defined by the OR clause, which can include partition by, which basically divides the result set into partitions to which the window function is applied. Next is order by. So guys, order by defines the order of rows in each partition. Next we have rows or range, which basically defines a subset of rows within the window frame. Now, let us discuss what exactly is a function. In SQL, a function is a predefined operation that can perform calculations, data manipulation, and formatting. Functions can be scalar, returning a single value, or an aggregate, returning a summarized value for a group of rows. Now, let us discuss the different types of window function. So guys, our first function is aggregate function. We have already discussed about aggregate function, which includes sum, average, max, min, count, and basically it returns the summaries. Next, we have the ranking function. So guys, ranking functions are a type of window function that assigns a rank to each row within the partition of a result set. These functions are useful for the scenarios where you need to rank rows based on a specific criteria. So our common ranking functions include the row number, which assigns a unique number to each row, starting from 1 for each partition. Next, we have the rank, which assigns a rank to each row within partition, with gaps in the ranking if there are ties. The third one is dense rank, similar to the rank, but without gaps in the ranking sequence when there are ties. Next, we have entile n. It basically divides the rows into the partition into n groups and assigns a group number to each row. For example, guys, using rank function to rank employees based on their salaries within each department. So you can type the same command like select employee ID, department, salary, okay? And then you can use the rank over partition by department, order by salary in the descending order, and you can use the alias as rank from the employees table. So guys, this was a pretty simple example. So you can try with the rank function. Now let us move on to our next function, that is the value function. Value functions are the window functions that provide access to the value of a column from another row in the result set. These functions are basically useful for comparing values from different rows. Common value functions include lag. Basically, lag provides access to a value in a previous row within the same result set. Then we have the lead, which provides access to a value in a subsequent row within the same result set. Next, we have the first value, which basically returns the first value in an ordered partition. Next, we have the last value, which basically returns the last value in an ordered partition. So guys, let me show you by using a lag function, we can get the previous employee's salary within each department. So guys, as you can see all over here, we have taken select statement and then with employee ID, department, salary, so these are the column names, and here we are using the lag function, which is a kind of a window function, okay? And we have taken this salary and 1, we have used a clause over, then we have used partition by department, order by employee ID as previous salary, and here from the employees table. So this is how the window function is generally used. So below here, what we are doing basically, so with the help of lag function, we are getting the previous employee's salary within each department. Now guys, consider this following table, okay? So we have the column name employee ID, department and salary from the employee table all over here. Now we are going to understand what is the syntax of window function. So basically, first you apply the window function, then you take an over clause and here use the partition by, then you have to use the partition expression, then you can order by and you can do the sort expression, and finally you conclude it with a frame clause. Let us go through an example to understand the same. So suppose in order to calculate the cumulative sum of the salaries, how we are going to write the syntax. So guys, all over here you can see that we are using the select keyword, then we are selecting the employee ID, department and the salary, okay? And then we are using an aggregate function, which is a type of a window function, and then what we are doing, we are taking this column as our argument and then we are using over all over here, okay? So if we see the syntax guys, then here partition by, okay? Then here is a partition expression. So after over, what we are basically doing, we are using the partition by. So here partition by is your order by in the same place and we are taking employee ID. Then you are writing the alias as basically calculating it as the cumulative salary from the employees table. So this is a sample example of how we are achieving the window function using these syntax. Now let us try to understand how you can use a window function with the partition by. So guys, as you can see all over here, in this scenario, we are selecting the employee ID, the department and the salary. And we are using the aggregate function sum and then we are using the partition by keyword, okay? And with the department, this is our expression. And then we are doing the order by clause with the employee ID from the employees table. So this is how the overall syntax for this is. I hope so. You have got a brief idea that how we can apply the window function with the partition by keyword. So basically, we are calculating the cumulative sum of salaries for each department with the help of window function. Now let us try to understand the next part. So guys, with the help of select statement, we are typing the employee's ID, department and salary. We will be using row number as our window function over partition by and department order by salary description. And then we are taking alias as from the row number and from the employees table. So basically, if you see this code, so it's similar, but here we are using row number as our window function. Let us take one more example. Now guys, in the next example, we are going to learn how to use a dense rank function. Basically what we can do all over here, we can select the required columns, that is employee ID, department and salary. And then we can apply our dense rank function over clause, and you can use the partition by department, and you can use order by through the salary description from the employees. So this is how you can apply the dense rank function. So guys, basically dense rank function is a ranking window function which is used to assign rank to each of the row within the partition of the result set. And you can also see all over here that there should be no gaps within the ranking values. So this function is basically useful when you need to find a dense ranking of the rows without skipping any rank numbers when there are any ties. Okay. So guys, this is a sample description which I have given for dense rank function. So a similar example we have used all over here.
So let's start with what is normalization. Normalization in DBMS is a method used to organize data within database to reduce repetition. By breaking down large data sets into smaller, more manageable tables and ensuring these tables are properly related, normalization helps prevent issues like data redundancy. Data redundancy means the unnecessary repetition or duplication of data within a database. For example, when a same piece of data is stored in multiple places, it can lead to inconsistencies and take up more storage space than needed. For example, data redundancy before normalization. You can see the table mentioned above where we have order ID, customer name, customer address, product and quantity. You might see some of the data which is being repeated again and again. In the above table, the customer address for John Doe is repeated 3 times. Let's suppose if John Doe moves to a new address, every occurrence of his address in the table must be updated. If any instance is missed during the update, it leads to inconsistencies and errors can occur in the database. The solution is reducing the redundancy through normalization. Let's check it out how. So you can see this is the normalized table we have created. First is the normalized customer table and then we have the order table. So what are the benefits of normalization? The address for John Doe is stored only once in the customer table. If John Doe's address changes, it needs to be updated in one place, ensuring consistency through the database. This reduces the risk of errors and maintains data integrity. The process involves multiple steps that transform data into a tabular format, removing duplicates and establishing clear connections between different tables, making the database more efficient and reducing problems like errors during data insertion, updates, or deletion. Let's now discuss the types of DBMS normal forms. Normalization rules are categorized into different normal forms. The first one is 1NF. For a table to be in first normal form, it must satisfy the 4 rules. Single-valued atomic attributes. Each column should contain only one value per row. This means that there should be no repeating groups or arrays within a single column. Same domain values. All values stored in a specific column should be of the same data type or domain. For example, if a column is meant to store dates, all values in that column should be dates. Then we have unique column names. Each column in the table should have a unique name. This ensures clarity and avoids confusion when referring to a specific column. Then we have order of data, which doesn't matter. The order in which rows are stored in the table should not affect the data or its integrity. Let's check the example of the first normal form. Consider the following unnormalized table: customer ID, customer name, and the phone numbers. As you can see, the phone numbers are repeated twice. The problems with the original table is the non-atomic values. The phone numbers column contains multiple phone numbers separated by commas, which violates the atomicity rule of 1NF. Converting to first normal form, to bring this table into 1NF, we must ensure that each column contains only atomic value. This involves splitting the rows where there are multiple phone numbers. As you can see, we have splitted the data. Each row now has a single phone number, ensuring that the phone number column contains atomic value. Same domain names, all the values in the phone number column are consistent in format and type. All are phone numbers. then we can see that the unique column names, the columns customer ID, customer name, phone number, which has unique name satisfying the requirement. Order of data, the order in which the rows appear does not matter as the data's meaning and integrity are preserved. By applying these rules, the table now conforms to the first normal form, eliminating any redundancy related to the phone numbers and ensuring data is stored in a more organized and efficient manner. Let's go through each of these database normal forms step by step with simple examples to help you grasp the concepts more easily. Let's talk about the second normal form. For a table to be in second normal form, it must satisfy the following condition. Number 1, it must be in 1NF. Number 2, no partial dependency. Every non-key attribute should be fully dependent on the entire primary key, not just part of it. This rule applies primarily to tables with composite primary keys. Example of second normal form is, consider the following table that is in 1NF. The order ID, product name, quantity, and the supplier name. The problems with this table is that the partial dependency. The product name and the supplier name depend only on product ID, not the entire primary key, which is order ID and product ID. This violates 2NF. Converting to second normal form, to bring the table into 2NF, we separate the data into two tables to remove partial dependencies. Order table and the product table. No partial dependency in the order table. Quantity is fully dependent on both order ID and product ID. In the product table, product name and supplier name are dependent only on the product ID. This ensures that each non-key attribute is fully dependent on the primary key, bringing the tables into 2NF. Let's now talk about the third normal form, 3NF. For a table to be in third normal form, it must satisfy the following condition. Number 1, it must be in 2NF. Number 2, there should be no transitive dependency where non-key attributes depend on other non-key attributes rather than the primary key. Let's check out the example of a third normal form. Consider the following table that is in 2NF. The problems with the 2NF table is that the transitive dependency. The instructor name is dependent on the course name, which is not directly on student ID or course ID, and this violates 3NF. So how do we convert this into 3NF? To achieve 3NF, we split the table to remove the transitive dependency. Student course table and course table. No transitive dependency. Now, the student course table, there are no non-key attributes depending on other non-key attributes. The course table stores the course and instructor information separately. This structure eliminates transitive dependency, ensuring the tables conform to 3NF. Let's now talk about the Boyce Codd normal form, which is BCNF. BCNF is an extension of the third normal form, 3NF. A table is in BCNF if it is in 3NF, and for every functional dependency, A implies to B, A should be a super key. Let's check out the example of a Boyce Codd normal form BCNF. So you can see this table here consisting of employee ID, department, and the manager. The problem with this table is that the BCNF violation. In this table, department determines manager, but department is not a super key, since employee ID is the primary key. This violates BCNF. So how do we convert this to BCNF? To achieve BCNF, we split the table to ensure that every determinant is a super key. As you can see, the employee table and the department table. The super key requirement in the employee table, employee ID is the primary key, and in the department table, department is now the primary key. The decomposition ensures that every functional dependency is satisfied by a super key, meeting the requirements of BCNF. Let's now talk about the fourth normal form, which is 4NF. A table is said to be in 4NF if it is in BCNF and has no multi-value dependencies. So let's consider an example of a fourth normal form. Consider a table where an employee can have multiple skills and work on multiple projects. As you can see, the employee ID, skill, and the project. The problem with this table is that it is multi-value dependency. An employee skill is independent of the project, but both are stored in the same table. This leads to multi-value dependency, violating 4NF. So, in order to achieve 4NF, we separate the skills and the projects into different tables. The employee skill table and the employee projects table. And now you can see that no multi-value dependency. By separating the skills and the projects, we eliminate multi-value dependencies, ensuring the table conform to 4NF. Let's now talk about the fifth normal form. the employee skill table, and the employee projects table. So as you can see that no multi-value dependencies there. By separating the skills and the projects, we eliminate multi-value dependencies, ensuring the tables conform to 4NF. Now let's talk about the fifth normal form, which is 5NF. A table is said to be in fifth normal form if it is in 4NF and cannot be decomposed into any smaller tables, losing information, also known as joint dependency. Let's consider an example of a fifth normal form. This is a table here that records the relationship between suppliers, parts, and a project. The problem with this table is that the joint dependency. The table has a complex relationship between suppliers, parts, and projects that can be decomposed further. So how do we convert this into fifth normal form? In order to achieve 5NF, we break the table into smaller related tables, the suppliers part table and the suppliers project table, also parts project table. Eliminating joint dependency by decomposing the table into 3 smaller tables, we remove the complex relationship and eliminate the joint dependency, ensuring the tables conform to 5NF.
So how to install SSMB or SQL Server Management System in Windows 11. Now we already have that SSMB in my system, so why don't we just quickly uninstall it and try to reinstall that, right? So why don't we just search for all the Microsoft SQL Server files in our system and uninstall all those, and then try to download the files we require and install them. This might take a little while. So the uninstallation has been started. Slowly we will remove all the files related to Microsoft SQL Server and SSMS. So that's our SQL Management Studio. So let me remind you, we will be needing 2 different files for this. The first one will be the Microsoft SQL Server, then the Microsoft SQL Server Management Studio, which will act as an IDE for us, where we can write our queries. We'll uninstall this quickly. There you go. All these specified components have been uninstalled successfully. Now let's check for a few more other files if there are any and try to remove them as well. So we have SQL Server. Let's quickly uninstall that as well. So we need to choose the remove option here. There you go. Just go with the next here and select all, or you can just select everything what you have there. Go to next again. So just select remove. So we are removing all those files related to SQL Server 2022. This might take a while, so it's okay. There you go. We have successfully removed all the relevant files to SSMS. Now let's close this and try to check if there are any other files. So let's recheck. I think it's already gone, so no, not to worry anything. Now let's quickly open a new tab on Google. Before that, let's quickly cross-verify if we have any relevant files related to that, so that we don't have any problems after installing and setting up the file. So I think there are no more files related to SSMS. Now let's quickly open a new tab on Google and try to fetch the required files. Your window. Now you can quickly write down SQL Server Management System or SQL Server download. Yep, just click on that and select the first link, SQL Server Downloads. There you go. So you have SQL Server Azure, Edge, and on-premises. And there you go. You have the 2 options, developer option and express option. Since we are learning and we want some extra features, we'll go with the express version, which is for free. And it has some more features more than the developer. So there you go. That's our file. Now let's quickly go to the downloads and install it. So before we go to the downloads, let's check the PPT back once again. So as I said, we will be needing 2 different files. The first one, Microsoft SQL Server, And the next one, SQL Server Management System. So we have downloaded the Microsoft SQL Server. So as we begin with the installation, at the end of the process, the last step will be downloading SQL Server Management System, right? So let's proceed with the first installation, that is the Microsoft SQL Server. So we have reached the downloads. So let's open the file, which is SQL, right? So I think we have downloaded it twice, so you can choose any one. So we'll go with SQL 2022 Express 1. Yeah. So the Express edition is getting installed. So we have three versions: basic, custom, and download media. Let's go with basic. Let's just read all the agreements. You can just accept those. So this is the location of your SQL server. If you want something else, just browse and select. So make sure you have a minimum free space and download size. It's 278 MB. Just go to install. So this might take again a little more time. Let's wait. So the download is successful and the file is getting installed now. Anyway, this might take a while. It's okay. So there you go. The installation process has been successfully finished. That's the connection string. That's the SQL install log folder where you'll find all the log files, and the installation media file, installation resource folder. So you can now just click on install SSMS, which will be our next step. Choose the third option, and it should redirect to Microsoft Edge, where we will have the location of the file. Just scroll down a little bit, and we must have the file link. Yes, just click on that, and slowly the file will be downloaded. It's about 473 MB, so it might take a while. You can minimize the 2002 SQL Server installation, page. You can just go to Microsoft Edge. Yeah, that's the one. And once the download is finished, I think all we need is just to run the exe file, and our SSMS will be set up. There you go. The file has been successfully downloaded. All you have to do is just run it. You can click on open file, or just go to the location. I think that should start the installation process. Yeah, there you go. Just click on the run button. So that's the default file location, and in case if you want to change, you can change. So I want to continue with the same location, just install, and this might take a while. There you go, the setup is completed. So just close it, and we can go to Windows and type SSMB to find the application, and then start a new file. SSMB, no SSMS. So that's our application. Just run it. That's the Studio IDE that we require to write the SQL queries. There you go. So we have started the Microsoft SQL Server Management System. So you can have some setups. So I'll go with the database engine as default, and server name will be my official name here. And we will be going with the Windows authentication. You can go with your choice, and you can just start by selecting the connect option. I am expecting some errors here because we had some files. So maybe we should be getting, yeah, that was the error. So maybe we have to change some port numbers here and readdress a few port numbers. So for now, we can just use the Microsoft SQL Server Management Studio in the offline mode. We can quickly start a new file and write some queries if required, and you can just take a trial. So this is the actual procedure of installing your Microsoft SQL Server Management Studio successfully. Since we already had the old version, and we try to uninstall a few files, so one or two might be missed. So that might be the reason why we couldn't establish a successful connection. Not to worry. So let's now cancel the connection. Let's try to open a new file, new project. And that's how, okay, so it's showing that it's still not connected, but we can use it in offline mode, not to worry. So in this session for today, which is SQL Server tutorial, we will cover the SQL basics. That is how to create a table, how to insert data, how to retrieve the data from the tables, etc. And apart from that, we will also go through some of the other fundamentals of SQL basics, which include sorting in SQL Server. And followed by that, we will also go through the group by and order by sequences in SQL Server. Next ahead, we will also learn another important part, which is conditional statements, which includes case statements in SQL. Proceeding ahead, we will get into another segment of today's session, which is about joins in SQL, where we will be combining two or more tables in SQL Server. Followed by that, we have the next part of today's session, which is all about the having clause in SQL Server. Next, we will proceed with learning the next part, which is about the between operator in SQL Server, and followed by that, we will get ahead with pattern matching in SQL Server. Next, we will cover the time and date functions available in SQL Server, and after that, we will proceed with temp, which is temporary tables in SQL Server. And proceeding ahead, we have the most important part, which is about the common table expressions in SQL Server, and followed by that, we have the last part in SQL Server tutorial, which is about creating views and executing a query to extract the data present in a view in SQL. So far, so good. So these are the foundational skills in SQL Server that you need to get before becoming a pro in SQL Server. So this particular tutorial will discuss the major foundation skills, the fundamental skills, the basics of SQL Server and its operations. Now, without further delay, let's get started with one of the compilers which can help us execute the SQL Server queries. So we are on one of the SQL Server compilers available online. In case if you are facing any difficulties setting up the SQL Server Management Studio in your PC, then you can come up with this one. And we have also set a particular tutorial where you can learn how to download and install SQL Server Management Studio and how to configure your SQL Server Management Studio. And the link to that particular tutorial will be dropped in the description box below. Make sure to refer that in case if you wanted to execute these same codes in SQL Server Management Studio, right? So first, we will be dealing with two different data tables. We will be dealing with customer data and dealership data. So the first table will be about the customer data, where we will be having about the order ID, order date, delivery date, dealership pin code, product category, and car fuel type, etc. Followed by that, we will insert some rows into that particular customer table, about 15 to 20 tables. And after that, we have a dealership database, where we will be having order date, state, region, customer ID, customer name, primary key, foreign key, etc. And we will be inserting about 20 entries into that particular table. Don't worry if you have more than 20 entries. In case if you have more than 20 entries, let's say about 2,000 entries or 20,000 entries, it's not at all a big deal if you're working on SQL Server Studio, right? There you can use the wizard to just ingest the data from your source into the SQL Server, right? You can use SSIS tool to import all that data and you're good to go. You don't have to manually create the data and you don't have to manually insert the data. Just for the sake of learning the basic process of how to create a data table and how to insert the data table, you're going through this particular procedure. So far, so good. So we have also inserted the data in the next data table, which is our dealership data. And now let's query the data from our tables. And now let's select the execute data. There you go. We have the data table right over here. And let's copy this query and paste it to query the data from the customer table as well. So instead of dealership, we will be writing down customer. So if you observe closely, I'm using uppercase for keywords like select and from, and sentence case or lowercase for the variables, the table names, etc. So that there's a difference between the keyword as well as the regular variables. There you go. We have executed the customer data, and here we have it. The order ID, order date, delivery date, days to deliver, category, and etc. Now, let's mention the use cases, correct? So, let's use double quotes, or maybe we can also use hashtag along with the pipe symbol here or the slash symbol here, and write the use cases, and then proceed with executing the codes or queries. So the first use case is, let's try to filter customers from specific regions. And now let's close this particular comment, proceed with writing the query. So we will be using select keyword, and we want customers from a specific region, right? So let's write down the customer name. So I think the customer name is not mentioned in the customer data, but instead of customer name we have a order ID. So let's extract the order ID, not a problem. Select order ID and dealership name, comma state, and the important part, which is about the region and what product did they, and what's the revenue that the dealership has extracted out of that particular customer from the table customer. Next line is about join dealership. So we will be using join table dealership, the keyword. So we have one common keyword in between both the tables, which is about the order ID, which is equals to order ID. So this is not done here. Since we are clubbing both the tables, we need to specify the tables here. So dealership dot order ID and customer dot order ID, so that the SQL server will identify we are trying to map two different tables, and we are trying to combine and extract the data. Now we are trying to filter out customers from a specific region, correct? Now we will be using where clause to specify that particular region. So let's go with West region, correct? Since we are using the text format here, so it's better we choose double quotes, correct? Now let's run this query. Let's give it a next try. Ambiguous order ID. So let's do one thing. We will pull customer table name here so that it's no more ambiguous. There you go. So the thing is, we have order ID in both the tables, customer table and dealership table. So SQL Server got confused here, which particular table you want me to extract order ID from. So if you mention customer table or dealership table, it will choose a specific table and extract that particular column. Now we have the order ID, dealership, and all the members that we selected are from the West region, if you check here. Now let's proceed with the second use case of today's session. Okay, let's continue with the same here so that it is clearly visible for us. Now, let's sort, we're using the sort command here, products based on the revenue. So it's like maybe highest revenue should be in the top or lowest revenue should be in the top. Let's go with the highest revenue, okay? Sort products based on or based by revenue. We will write the command here itself. We will go with some columns. I would like to have product here, so I'll eliminate everything else, and the product will be here, and I want the revenue as well. Now I don't want the revenue, I want the total revenue. So if you're looking for total, then you will be going with the function or aggregate function, which is sum, right? I want the sum of all the revenues that particular product has earned throughout the years or that particular financial year. From which table? So I have both product and revenue in the customer table itself. So I'll go with customer table itself. I don't want to join anything here. I'll eliminate the join command. And instead of region or instead of where command, I would use the group by command here. Group by product. And it is not done so far. We want to order it. So we want to keep it in descending order so that the highest grossing product is on the top and the lowest grossing product is on the bottom, right? So that we can also make sure that our inventory is filled with those products which are giving us high revenue. So we will be using order by total revenue, right? So we can give it an alias as total revenue. Right now we can use this particular term here, order by total revenue, descending. DESC is good enough. Now this is how you will sort the products. Now let's execute this particular query. There you go. So the car model T, okay, yeah. So the car model J is giving us the highest revenue. Next is followed by T, M, and S and G. So we are not mentioning specific, if you go back to the table, here we are not mentioning the actual car brands and actual car names, so that we don't want any copyrights to be faced. So we are just mentioning some random names, not to be too specific there. Now, let's proceed with our next query for the session, where we want to group by state and calculate total revenue. Let's edit the same comment here. Don't worry, if you want this demo document, we will also link that demo document with all edit and view rights, so that all the viewers can have a quick glance and try to execute these queries in their own local systems. Okay. Now let me type down group by state and calculate total revenue. There you go. Now let's try to edit the same query. Now we want state-wise revenue and we want from customer table, right? We want to join a dealership for this particular one because dealership is the one which has some details for it. So the state data, right here you can see we have inserted state data California, Texas. So we want the state data, so it is present in dealership table. So we also want to perform a join there. No worries, let's edit the same query here. So we want, instead of product, we want state, and instead of sum of revenue, we want revenue. So we will keep it as it is, total revenue as total revenue, sum of revenue as total revenue from customer table, and we want to perform a join operation. So let's create some space, join dealership. Okay, let's copy the name so that we don't make any confusions here. Dealership, sorry, here. Don't worry, we'll make some edits down the line. Dealership on order ID. So let's go with the order ID, which is available here. Order ID equals to order ID. Remember the first step we did. Eliminate the confusions by mentioning the table names, dot column name, and customer name. The customer table name, dot column name on. Yeah, we did it on dealership dot order ID equals to customer dot order ID. Now we will be performing the group by operation. We don't want the order by here. Group by state. Of course, in case if you wanted to, order by the highest grossing state, you could have used order by there. But so far, according to the use case, we don't want that. So let's continue with the same execution here. Click execute and you will be having the answer here. So based on the states, you have their respective revenues. There you go. Now let's proceed with the next use case for today's discussion, which is about using a conditional statement like case. Using case, query, or clause for custom calculations. We'll perform some customized calculations. Now let's say we wanted to find out a product which is giving revenue greater than 10,000 as high revenue. Let's say we have revenues in terms of thousands of dollars, and let's have a benchmark like $10,000. And $10,000 is the minimum revenue you wanted to extract out of that product. And if it is not yielding at least 10,000 for your dealership, then that product is not selling much. So that you can at least make some space in your dealership so that you can import some products which are giving you highest revenue, right? So we want to find out those products which are giving us revenue between 5,000 to 10,000 as medium revenue, and less than 5,000 as low revenue, and greater than 10,000 as high revenue. You understood the game, right? So we have three segments: high revenue, medium, okay type of revenue, and least revenue products, so that you can eliminate the least revenue products out of your inventory. Now we want order ID. So copy the order ID from here and paste it here. So we are looking for order ID, and we are also looking for product. So we don't want sum of revenue here. Let's eliminate this one, and instead of that, let's add product. From we'll extract this from, okay, before from, this from statement will be at the last. Here we will begin with a use case, right? Let's type case. Now, when a specific product or revenue, okay, let's revenue is greater than $10,000, then let's not use sentence case, let's use keywords in caps. Then mention it as high or high revenue. Let's copy paste the same code here. When revenue is between 5,000, and we will be using an AND operator here, then term it as, okay, we don't want alter, average revenue or medium revenue, and copy paste the same here. We'll remove the alter. And revenue is less than, okay, I think we don't want to use this. Instead of this, we can just place else, right? So we will place else. It should be termed as low revenue or least revenue. Let's go with low revenue. There you go. And now, from which table you want to extract that? I want to extract all this data from customer table. So everything will go off apart from that. Now let's execute this particular code. Let's see if we get any errors. Incorrect syntax for case. I think we made some mistake here. Okay, we forgot the comma here. Should have mentioned the comma. And yeah, so the thing is, we by mistake chose the alter from suggestions, alter keyword from suggestions. So far we missed a comma and alter from suggestions. I think it's everything good to go. Let's try to execute, and if it faces some issues, no problem, we'll try to resolve it in a different way. So incorrect, we missed to write the end. Okay, we did not end the case. Okay, fine, not a problem. End as, okay, let's term it as the entire table as revenue category. Since we are splitting into three categories, revenue categories. There you go. So this is the way to learn. Make some mistakes so that you can learn in a better way. For the next time, you'll never make a mistake. So far, so good. So we have all the car models have categorized into the revenue categories: high revenue, low revenue. So far, we have all the cars in high revenue. Not a bad deal. I think all the cars are performing really well. Maybe if we change the numbers a little bit, maybe if we take up 1 lakh in place of 10,000, then maybe we can get a couple of cars. But so far, so good. This is how the query works. Now, let's switch to our next query, next use case, where we will be combining data from multiple tables using a join. We already did that, but still, for the sake of learning experience, we will also perform that particular operation. So we will be naming this particular use case as combine data from multiple tables using a join. So far you have already have a good experience on how joins work, but still we will try to do that. Now we will use customer table here, customer table dot order ID, and we want customer table dot product and customer dot revenue. And, let's also say take some data from dealership. So we already know that some data of states is in dealership, so we'll also take the dealership data. So dealership dot state We'll also take the region, dealership.region from customer table. Let's eliminate the case statement from customer, and we want to join. Let's push this to the first line so that we don't have confusion how and where the query is going on. So here I want to join. So the second line is all about join dealership. So let's copy this. We are combining dealership with customer on order ID. In the same way, we will take order ID equals to order ID. Now, which order ID is equals to which order ID? The first table, customer.order ID, is equals to the second table, dealership order ID, so that SQL Server understands which columns from which tables are being joined here for what reason. Right? So far, so good. We have given the columns that we want to have in our output, which are these columns, and we are joining two tables based on certain criteria. But now, maybe we can specifically mention some more data. Let's say we already mentioned some query where we wanted the data for a specific region. Let's try to continue that, where region is equals to West. There you go. Let's close the single quote or double quote. Now what happens is it is trying to give us the details of customer order ID, product, revenue, state, region from customer table, and we are going to also execute or extract the details of state and region from the dealership table, and we are trying to join to extract those data with dealership data, and we are specifically extracting the data where the region is West. Let's execute the data. Don't worry if we find any errors in this particular code. There you go, we have the result. So we have all the details from the West region. There you go. Let me expand this so that we have a better view. Anyways, it's okay. Now let's go with the sixth query for today's session, where we will be executing a query based on having clause in SQL Server, and we will try to filter out some states. Only show the states where total revenue is greater than 50,000, just like we discussed before. We initially used a case statement with $10,000 at least revenue, but now let's increase the number to 50,000, and we want those states which are giving us minimum 50,000 revenue. So let's rename the use case here. We will try to name it as filter data or groups with having clause. Okay, so we want state. We have state here, and let's also count as total orders. So order ID. So customer.order ID will be now count of total orders. So the count will be the aggregation function here, count total order IDs, and we can name it as total orders. And do we have revenue? Yes, we have revenue. And let's also remove the product. I don't think we might need a product here. And the aggregation will be some aggregation here, sum of revenue. And I don't think we need to specifically mention it here. But anyways, we'll keep state first. Copy state and drop it here. We want state, count of orders as orders, and sum revenue as total revenue. What this does is it will give a clarity, right? So instead of if I don't alias it, what it shows is sum of revenue. And for a generic person, it might not be as helpful as a data engineer can, right? For a data engineer or data analyst, he can totally understand by just reading the aggregation function. So we are counting the orders here, we are getting the sum of revenue here. But for a mere person who just wants to see the report, the business guy who just wants to see the report, for him, total orders or total revenue is a simplest language that he can understand, correct? Now we are extracting this data from customer, and we will join dealership again, okay, because we also want to extract the state, right? So we did not mention the state here. We can mention the state anyway. Okay, we did mention the state. So since we have the state column, for extracting state details, we'll anyway go for the dealership. So we are already joined with dealership data with customer data. And let's do a group by function here. Group by region, group by state actually. And now the condition, having sum of revenue at least or greater than 50,000. So we will go with the having clause here, and the sum of revenue, or you can also use the alias name, total revenue greater than $50,000. So let's execute this query and see if the alias works or not. Okay, I think alias will not work here. In case of alias, let's go with the actual term and place it over here. And now let's try to execute this if it works or not. Okay, we mentioned two things here, region and the state. So we just wanted state there, not region. I think this should solve the issue. 20 rows affected, ambiguous column, order ID. Now we will, let's say, take customer name and place it here. Or I think a dealership would be the best because we have the details of orders here. No. Customer table has the order details. So let's keep it that way. There you go. So we have so many number of states which have revenue greater than 50,000. So these are the outputs. There you go. Now let's proceed with the next query where we will be using the range function, which is also known as the between function in SQL Server. So let's name the comment as using the range function. Let's not capitalize it. Using the range function named between. So between is the keyword, right? Now let's build a use case. Let's identify couple of states. We will use the same query, will not make some major differences here. So we want to identify a couple of states whose revenue is greater than 50,000 but less than 1 lakh, right? This makes a good use case for that implementation of between function. We will keep all the columns as they are, and maybe we can also include a couple of columns, maybe product as well, and we will join two tables. Now I think we don't need a group by here, but in place of group by and in place of having, we will specify where sum. So to use where clause, to use between clause, having is not the right keyword, where is the right keyword. So sum of revenue should be, in place of the symbol between, you take the suggestions, and 1 lakh. Yeah, this is 1, 2, 3, 4, 5 zeros. So this is the right way. Now let's try to execute if it works or not. If there is some error, yeah, there is some error. An aggregate may not appear where clause unless it is subsidiary. Okay, contain having clauses select. I think this is the place where we can go with the alias name. Let's try that. Or if alias does not work, then we will go with the revenue. Okay, let's simplify this. Let's not go with the join statement here. Let's eliminate the join. We shall just simplify. We don't want state. We want, okay, let's not count this. There was no need for counting. I think that was one error. We will go with order ID as total order. We don't want this. And anyways, we want to take a look at the product and dealership name as well. And we also want revenue from customer table, where revenue is between these numbers. Let's try to simplify and run this query. I think it should work. Yeah, it worked. So these are the dealerships and products which yield in revenue between 50,000 to 1 lakh, right? So this is the best way to use it. So we had some extra aggregate functions which complicated the query. No problem. Now let's go with some pattern matching. Sometimes, let's say we are looking for sales from California or something like that, or we are looking for some car model, correct? And we don't know the full name, or we might have a spelling mistake, right? We have California here, but let's say we don't know the spelling of California, but we know the first 3 or 4 letters of California, right? So in those instances, what you can do is try to match the pattern that we have in our hand with the pattern which is available in the data table, and wherever it finds a match, it extracts those rows. So this is how the pattern matching works. Now let's execute a query for a better understanding. Let's keep the same query. Let's change the use case here using the pattern matching in SQL Server. So we will have order ID as it is, dealership name as it is, and product as it is from customer table, where product, so let's copy this and paste it here, like, or I like is the opposite, so let's go with like. Car model, let's check with the car models first. So all car models are the same. So maybe if we go with the fuel type, I think fuel type will help, because all the car models have the keyword car model, and the only thing is an alphabet M, etc. So it doesn't make sense for us to execute the like operator here. So instead of product, let's keep fuel type like hybrid, correct? Let's go with the hybrid one. So we will take only the first 4 letters. Let's imagine we don't know the full spelling of hybrid. So if the pattern is like, and since it's a text, we will use single quotes or double quotes. If the pattern HYBR matches with the elements or the column present in the customer data, it will pull all those columns or rows. Now let's execute this. So there you go. Okay, we missed one important thing. We missed to include the percentage. This percentage symbol will make SQL Server understand that the text should have HYBR, and after that anything is accepted. So anything which has a beginning with HYBR should be pulled out, right? Now let's execute once again and see the data. There you go. You have it. Correct? So remember the symbol percentage, right? And in case if you didn't knew the hybrid, let's say, it has some YBR in its format, right? It has some YBR in the format. Anything before YBR is okay. Anything after YBR is okay. Again, it will yield in the same result, hybrid. There you go. But in case if you wanted to change, let's write the name of petrol. I don't know the spelling of petrol, so let's say PEET. So let's imagine I don't know the name of petrol, so instead of petrol, I'm eliminating P and I'm writing PETR and anything after that. Now let's run this query and see the output. There you go. So we have all the vehicles which are of fuel type petrol. So this is how you can use pattern matching in SQL Server. Now let's perform some calculations with dates, right? So we'll perform some date and time calculations. Let's rename the comment as date and time functions. Date and time in some mathematical math calcs. Now let's say you are the owner of dealership, and let's say for a specific car you are losing customers. Initially it used to perform very good, like many customers used to come for that specific car, and right now that specific car is receiving less orders, and you wanted to find out what is the reason behind it. And after a general survey, you come to know that the number of days you took to deliver that car is growing. Let's say earlier you used to deliver that car in 2 days, but right now you're taking like 2 months to deliver that car, right? So that might be the reason. But you wanted to make sure that you have a solid proof that you have the number of days that you're looking at to show your sales team why is so many number of days is being taken to deliver a car. Now for that, let's go with select order ID, order date. You want order date for it. Now you can simply copy the order date here and paste it there. And you also want the delivery date. And Copy that and paste it there. Remember, these date and order date and delivery date are of date data type. And now you want to calculate the difference. So for that, you use a function called dateDiff or datedDiff. So there's two ways of calling it. So if you prefer calling it as date, right, diff, or a few call it as dated diff. Okay, so there's two ways of calling that function. So I prefer to call date diff because date difference. So date diff, comma, open bracket. So I want to provide some details here. So I want to provide a day. I want to count the days, right? So I want the count of days. I'm mentioning day and order date. Difference between the order date and the delivery date. You can specify that using a comma. So I want the difference between these two. In case if you want to alias it, you can also do that. Days to deliver from customer, and we don't want this. Simply place a semicolon there. And now just copy this and execute. There you go. Now you have the number of days that you or your sales team is taking to deliver the vehicles. So, and on an average, you're taking about 10 days to deliver. Now you can prove this to your sales team and let them know this is not good. You want to have at least a minimum 4 to 5 days or 2 to 3 days to deliver a vehicle. If this goes on, the sales might drop and it might be a little problematic, right? Now let's proceed with the next use case of today's session about the temporary tables. Now, why temporary tables? So there comes a situation where you have to just run some numbers, run something very not too critical, but you just wanted to do that. So in such scenarios, what you can do is you don't want to harm the original table. So what you can do is you can create a temporary table or a copy of that table, which is somewhere in the intermediate memory storage. And as soon as you close the studio, it fades away and nothing happens to your original data table. So that is where the temporary tables come into picture. Now let's create a simple use case for that particular temporary tables, right? So we will be selecting order ID, and let's also take product, and let's also take revenue into temp order. Yeah, it's enough. Temp order tables. I don't want that. Temp order, and I don't want to alias it. And from which table are you taking that? I'm taking that from customers. You can either choose to keep it in a new line, or you can keep it in a same line, but I want to keep it in a new line. From customers, and where revenue is, I said you right, you wanted to just explore a few things which is not too mandatory, but you just want to take a look at it. That's why you take the option of creating temporary tables. And I want to find out which are those products which are giving us revenue greater than 1, 2, 3, 4, 5, $1 lakh, right? Now let's run this. It's done, but we don't know where it is. So what you can do is you just write up simple select query, select star from your temporary table. Close the query and run it. There you go. So far, there are no such products which are giving us greater than 1 lakh sales about that single product. Invalid object name, temp order. Okay, there might be some error about this particular query. Let's try to reduce the number. Did we miss anything? Where revenue is greater than, okay, this is a number, we don't want semicolon there. Okay, we missed a semicolon here. Let's run this, execute. Let's keep it as 10,000. Okay, so there was no certain product which was above 1 lakh. That was a problem. Okay, so these are the products which are giving us 10,000 sales at least. Not a problem. Now let's proceed with the next important part of today's session, which is about the common table expressions. So remember, common table expressions are also known as CTEs, play a very major role in real-time data analytics. right? So let's have a sample of that. Let's create a common table expression, which is rather simple, and just learn how technically it works, right? So the only difference is the CTE start with a keyword named as with, and after that you can term your common table as some data. So or some name. I'll give it as sales data as, and open a bracket, and inside this bracket is where you write your actual query. Now let's organize a few things. I don't want the temp order table here. I don't want temp order here. Okay, I want to extract a few columns. I want maybe state, and I maybe want I don't want order ID. I want revenue. Maybe revenue is good. So let's sum the revenue and term it as total revenue from customer. And now let's proceed with a join command where we will be joining dealership data. Let's copy the dealership data table name. We will be joining based on the order ID that is common. So maybe order ID. Copy the order ID is equals to order ID. And which order ID are you talking about? I'm talking about customer's order ID and dealership data order ID. So we need to mention that on dealership.order ID and customer.order ID. Group by state. So since we took state as well, we can use a group by function here. And this is not the end of everything. So semicolon may have to wait. So this is the first part. Now, using this particular CTE, this entire term is CTE. So the output of this particular query will be stored in sales data. Now, we will make use of this CTE or sales data term to extract a few more queries. So we will be writing another select statement. Select state from, okay, let's also take the total revenue which we created here. Let's take that same term here so that we don't make a mistake. From the CTE which we created very recently, which happens to be the sales data, where total revenue is crossing something about $50,000. And now is the semicolon. Let's try to execute this. There you go. So a few regions or a few states and total revenue which are exceeding $50,000 are, there you go. So what exactly is a CTE, you ask? Now, if you are a beginner in SQL, let's say you wanted to club two different tables or more different tables, maybe 3 or 4, right? So you will be using one keyword, which is join, right? And let's say you may have to create a query in such a way that you have to club different tables and you have to extract the results from one table into another and finally create a output table, right? So this might be sounding a little too complex. So basically what CTE does is it acts as a temporary table, right? Now you can write a query and save it as a CTE, right? And that particular resultant table from CTE will not be created, but will be in the memory as a temporary data or an intermediate resultant data, right? Now, whenever you want to use a join or whenever you want to use the same query inside a bracket or inside something in your query, you can just simply use the name of the CTE and then the data you require, the columns you require, and done. You will get the data. Now, this might be a little too complicated to understand in just mere words. Now let's just go through the formal definition of what exactly is a CTE and what it does, and then let's quickly. So it's a little too complicated to understand it just with mere words. So let's get started with the practical examples. But before that, let's understand a formal definition of what exactly is a CTE in SQL. So CTE, also known as or also called as the common table expression, or some people also are used to call it as a with expression. So the keyword is with. So a common table expression in SQL is a temporary result set that you can define within a query. As I said, it helps to break down the complex queries, make the code more readable, and allows you to reuse the result set multiple times within the same query. Just you need to use the name of the CTE in the places where you want in your query, and it reduces the code length as well as the execution time. Now, CTEs are defined using the with keyword as we discussed before, followed by the CTE name, right? So for every column name or anything in your dataset, you give a name, right? Similarly, when you are using CTEs in SQL, you also need to give a name to the CTE, and that particular name will be used in your subquery positions that will reduce the query length and execution time. So you should be giving a name and the query that generates the result set. The CTE is available only during the execution of that particular query or specific query, right? So as I said, the CTE table, the resultant table which is created while you are using the CTE, will not be created as a permanent table in the database, right? It will be a temporary or intermediate result which will be active as long as your current query, which is using the CTE, is active. Now, let's go to the demonstration mode where we will try to create some simple queries, right? And we will understand how exactly a CTE can be beneficial in those situations. Now, let's go to the MySQL workbench. This is my MySQL workbench. So I have a lot of tables here. We have the credit card dataset, we have the Sakila dataset, SLP dataset, SIS, Superstore, World, etc. Right? So we will be using the Superstore dataset. The database. So firstly, we need to write in the query, which means that I am going to use the Superstore database, right? Sorry, Superstore. So I prefer using smaller case or lower case for database names and column names, and uppercase for the keywords. For example, here use is uppercase and Superstore is the name of the keyword, right? So that is for identifying or easy readability, which is a keyword and which is a name, right? So let's execute this query and have access to the Superstore dataset. And in Superstore dataset, I have one table called as Excel data. Now let's quickly check what we have in Excel data. Select star from Excel data. Here we have row ID, order ID, order date, ship mode, customer care, everything, right? So we have region, we have sales, quantity, discount, profit rate. So we have a number of possibilities, a number of reports that we can generate. But let's try to keep it simple. Let's try to find out unique regions, right? Select unique of regions, right? Or just regions, Excel data. Group by regions. So let's quickly execute this statement and see the output, or maybe we can make some modifications to it, right? Instead of that, you might want to use distinct function so that you don't get all 10,000 plus rows. So basically, this particular dataset has about 10,000 or more rows in it, and it's not real, it's completely made up report using artificial intelligence. So we use ChatGPT to create 10,000 rows of data for 30 years, maybe from 2000 or 2001 to up to 2030 or 31, right? So we don't want all those 10,000 plus columns, rows. So let's use a distinct here and try to execute this statement so that we get 5 of the regions what we have. So there you go. We have 5 regions as expected: northeast, southwest, and central. Now you can also select a kind of maybe average of sales, maximum of sales, and total sales. So this is bringing us somewhere we can try to find out region-wise sales, right? So region-wise sales grouped by years, like 30 years. What was the sale happened in the year 2001, right? We begin from 2000 or 2001 to all the way up to 2030 or 2031, right? So we can see if there is an increase in the year-on-year sales or decrease in the year-on-year sales. We can identify the best performing year, the worst performing year, right? So this sounds like a good use case. Now let's go to the code where I've written it as a CTE and understand the workflow. So here I have named my CTE as sales CTE. So I'm starting it with the keyword with, right? So with sales CTE as. Now this is our query, right? What am I doing? I'm extracting. So according to the dataset, we have the date, right? So the date is year, month, and date of that particular day, right? But we want just the year. So we're using the year function to extract the year from the date as sales year, region, sum of sales, right? We wanted to find out the total sales happened in that particular year as total sales from the dataset, Excel data, and group by year, right? We wanted it in increasing order. So 2000 to all the way up to 230 or 2031, correct? So that's how it is. And I'm saving all this as a CTE named as sales CTE. Now I want to select some parts of that particular CTE. So I want to select sales year, region, total sales from sales CTE, which is right over here, and order it in form of sales and region, right? Now let's try to copy this code and run this in our workbench. Right, now let me close this quickly so that we have a complete view of the code, right? So let's now select all the code. So now we have selected this particular code. Let's try to run this and see the output. There you go. We have the output, but there is something wrong. We did not get the years, right? So all the 30 years of data, here it is grouped by region, which is fine. Okay, we don't want region. We want to group it by year. That's okay. And the thing is, we need to fix this particular year. So maybe there is something wrong with the order date, right? So I think the database has saved this particular. Oh, okay. Since this is generated by ChatGPT, maybe the data type of the date is other than data, right? Other than data type. It may be string. Now we might have to do some typecasting to change the data type of the order date, and let's quickly do that. So now we have updated the year. So what we have done is just cast here, right? So we have changed the string type of date to the normal date, which follows by year, month, and date. So this is simple typecasting that you can do, and rest everything. And we've also added a where condition. So where date is not added or date is equals to null, and you can just ignore that. And now let's try to execute this query, and we have also removed that region thing, right? Group by region or order by region. So we want that to be ordered according to the year, which should start with 2001 or the first ever year to the last ever year according to the dataset. Now let's select the entire CTE query and run that and check our outputs. So there you go. So you have the year-on-year sales from 2001 to all the way up to the year 2030 and 2031, right? So that's how the CTE, or common table expressions in SQL, or the with query in SQL, can be used.
Imagine you're at a grocery store and you need to pick up just a few items. But instead of heading straight to where your items are, you wander through every section, checking out every shelf before making your selection. Sounds inefficient, right? That's exactly how poorly optimized SQL queries work. SQL is the backbone of database management. It helps retrieve, manage, and also organize data efficiently. But if your queries aren't optimized, they can slow down servers, increase load times, and waste valuable resources. This is why SQL query optimization is so important. It's the difference between a query that runs in milliseconds and the one that drags on for minutes. Let's take a simple example. Suppose you are searching for a customer details in a database. You write a query like select star from customers where city, suppose it's Los Angeles. So at first glance, it seems fine. But here's the issue. You will pull all the columns of the data even if you only need the customer's name and the email. This makes the query slower and unnecessarily heavy on the database. So instead, an optimized query like select name, email from customers where city is equals to Los Angeles. This will retrieve what's needed, reducing load time and improving performance significantly. So in this video, we will explore the 12 best practices for SQL query optimization that will help you write faster, more efficient queries, such as using indexes effectively, avoiding select star and retrieving only necessary columns, optimizing join operations, minimizing the use of subqueries, leveraging the stored procedures for performance boost. And by the end, you will have practical strategies to improve your SQL performance and ensure your queries run at lightning speed. So let's start with our first practice for SQL query optimization, which is using indexes effectively for SQL query. First of all, imagine you're looking for a specific word in a 500-page book. Without an index, you would have to flip through every single page until you find it. But with an index at the back of the book, you can jump straight to the right section in seconds. And that's exactly how indexing works in SQL. It acts as a shortcut that helps the database find and retrieve data much faster. But then, why indexing actually matters? When a query runs without an index, the database has to scan every row to find a matching data. But with the help of indexing, it knows exactly where to look, cutting down search time significantly. However, it's important to use indexing wisely. While it speeds up data retrieval, it also adds overhead when data changes frequently because indexes need to be updated. Now let's discuss the types of indexes and when to use them. At first, we have clustered indexes. You can think clustered index as a library where books are arranged in perfect order by title. Clustered indexes physically sort and store data based on actual column values. They work best for sequential, unique data like primary keys. Now let's talk about non-clustered indexes. Now you can imagine a library catalog that lists book titles separately. With the help of reference number pointing to their shelf location, that's how non-clustered indexes work. They create a separate lookup structure that points to the actual data. This is useful for lookup tables, mapping relationship, or glossary style searches. Now let's talk about the third type of index, which is the full text indexes. Full text indexes are basically indexes that search for a keyword in a massive document or email. Full text indexes help by storing word positions, making searches much faster instead of scanning the entire text. Let's look up for an example how indexing speeds up queries. Let's say you're searching for customers by name. So without an index, the query scans every row. So there you have to write a query like select star from customers where name is equals to, let's say the name is John. So this takes longer, especially in large data set, but by creating an index on the name column, the query runs much faster. So you have to write query something like create index IDX customer name on customer name.
So now as you can see, the database can quickly jump to the exact row, saving valuable processing time. So basically, in cloud-based databases like Redshift and Snowflake, indexing doesn't work the same way. Instead, these systems automatically partition data based on query patterns. So sorting data before loading can improve performance. Indexes are one of the best ways to optimize SQL queries. When used correctly, they speed up searches, reduce server load, and improve application performance. But remember, not every column needs an index. Use them strategically for frequently searched data to get the best results. Now let's talk about the second practice is that why you should avoid using select star and only retrieve necessary columns. Let's say you're ordering food at a restaurant, you just want a burger, but instead of ordering it separately, you ask for the entire menu, appetizers, main courses, desserts, and drink, even though you don't need them. It sounds ridiculous, right? That's exactly what happens when you use select in SQL queries. Why is this a problem? Because when you use select in your queries, you're asking the database to retrieve every single column, even if you need only a few. Basically, this puts unnecessary load of the database, which slows down query execution, and then it clutters reports with irrelevant data. So instead of using select star from customer profiles, you could use select customer name, customer email, customer phone from customer profiles, which is the table name. So while using this type of query, this will make your query much more faster, optimized, and efficient. So when should you use to avoid select? So basically when you're preparing reports and dashboards, which includes column that businesses users actually need to be. You can also avoid select in data models to keep queries clean by excluding unnecessary fields. For performance optimization, because less data retrieved will give you faster execution on time. Remember, using select is just like carrying extra baggage. It slows things down and makes everything harder to manage. Be intentional with your queries, select only what you need, and watch your database run smoother. Now let's talk about how can you optimize join operation for faster queries. Joins are basically which can make or break your SQL queries. So if you use the wrong type of join, you might end up with duplicate records, which slows query optimization or unnecessary data bloating your results. And that's why understanding inner join, outer join, left join, and right join is very important for writing efficient queries. First of all, you should use outer joins with caution. Think of outer join like dumping the contents of two spreadsheets into one, keeping everything from both, even the unrelated data. Sure, it might sound useful, but it can create duplicates and bloat your dataset unnecessarily. Unless you have a very specific use case, it's best to avoid outer join and stick to more optimized options. Now let's talk about the inner joins, which would be your best friend. An inner join is like matching puzzle pieces. It only returns records when there's a match between both the tables. This is almost always the best choice for keeping your dataset clean and ensuring that you only get the necessary data. For example, we have a query over here like select, let's say customers orders, customer ID, order details dot order date. We are joining two tables. So first table is customer orders and the second table is customer ID. From customers dot customer order, and here we are using inner join orders dot order details on customer orders. So as you can see, we have used inner join over here. So by joining on multiple columns, you can ensure that only valid matches are retrieved, reducing duplicates and improving the performance. But then let's talk about which is better, left join or right join. Left joins keep all the records from the first table and only the matching records from the second table. Remember, whereas the right joins do the opposite. They keep all the records from the second table and only the matches one at the first table. Remember, always try to use left join instead of right join because it's easier to read, improves data governance, and makes debugging less confusing. If needed, simply swap the order of your tables to make a left join work. So some of the pro tips I would say for faster joins is always use join on a common field. Make sure the columns exist in both tables. Use primary and foreign keys. This helps the database retrieve results faster.
Consider joining on multiple columns. This can reduce duplicates and improve query efficiency. So by optimizing your joins, you'll speed up query execution, reduce unnecessary data processing, and then improve overall database performance. Smart joins is equals to faster results and smoother operations. So now the question is, why should you use exist instead of n? So this is one more practice where you should use exist instead of n. So let's say you're searching for a friend in a huge crowd. If you use in, it's like scanning every single face before confirming whether your friend is there or not. But if you use exist, the moment you spot your friend, you stop searching. Which one is faster? Obviously, exist one. That's exactly how it works in SQL. When checking if a value exists in smaller dataset, exist is usually much faster than in, because exist stops searching as soon as it finds a match, whereas in scans the entire dataset before deciding, which makes it slower, especially with large tables. So instead of using query like select star from orders where order ID in, select ID from customer where active is equals to you, true, you can use something query like select star from orders. Let's say the order table is O, where exist, we're using exist over here. Select one from customer, and in this way, what is happening? Because exist will check if at least one active customer exists for an order and stops it immediately after it finds a match. So if you use exist, it will make it faster and more efficient and then scan the entire data set within. If you're wondering, with large databases, switching from into exist can significantly improve performance and speed up query execution. Less scanning will give you more efficiency. Let's move on to the fifth practice, which is we should minimize our subqueries and use CTEs instead. Let's say imagine you're trying to untangle a giant ball of wires, which is messy, confusing, and frustrating. That's exactly what happens when you rely too much on subqueries in SQL. They might get the job done, but they can make your queries hard to read, debug, and optimize. A much better approach is using CTEs, which is common table expressions. CTEs break your query into smaller readable sections, making it easier to understand, troubleshoot, and maintain. So instead of stacking multiple subqueries inside a single query, CTE lets you organize your logic step by step, just like writing a clear set of instructions. Let's suppose you're converting a subquery into a CTE. So here's a messy subquery like select max as most recent signup from the table name from wherever you want to select, customer name with customer phone, from customer details where the year is this much. So how can you optimize with the help of CTE, which is you can use with 2023 signup as select customer name, customer phone, customer signup from customer details where year is equals to this much, most recent signup as, and then you can give the table name and select whatever sections you are selecting from 2023 signups, and then select most recent signup from most recent signup. Okay, so why is this query much more better and optimized? Because as you can see, it is much more easy to read. So each section is clearly labeled, making it simple to follow. Also, it has got better debugging. You can run individual CTEs separately to test logic. It has improved maintainability so that anyone reviewing your code can quickly understand what's happening without digging through nested subqueries. So if your query looks overwhelming, consider breaking it down with CTE because clean code will give you faster queries and easier troubleshooting. Now let's talk about why should you avoid queries inside a loop. So imagine you are at a checkout counter with 100 items, and instead of scanning them all at once, the cashier scans, processes, and then prints a receipt for each item separately. It sounds painfully slow, right? That's exactly what happens when you run SQL queries inside a loop. It makes execution unnecessarily slow and inefficient. But why is this a problem? Because loops like for while and do while execute queries repeatedly, one at a time. This means every query has to go through the full process of parsing, compiling, and execution for each iteration. As a result, performance takes a huge hit and scalability will suffer.
So the better approach is using the bulk operations. So instead of running queries inside a loop, batch process them all at once. SQL is designed to handle bulk inserts and updates, which is far more efficient than executing a query repeatedly. So here we have a slow method, which is a query inside a loop, which is for each customer in customer list loop update customer set. So inside a loop, we have this update customer set status is equals to active, where ID is this much, and then we will end the loop. So this executes one update at a time, which slows down performance drastically. Now here we have an optimized approach, which is bulk update in one query, where we will be writing update customers set status is equals to active, where ID in select ID from ID name. So here, as you can see, we haven't used the loop. So this updates all the rows at once, making execution very faster and more efficient. So if you catch yourself writing a query inside a loop, pause and rethink. There's almost always a better bulk-friendly solution. Now let's move on to the seventh practice, which is why you should avoid redundant or unnecessary data retrieval. Imagine you're shopping online and instead of just searching for running shoes, you browse every single category, clothes, electronics, furniture, just to find what you need. Not only at this time consuming, but it will also slow down everything. That's exactly what happens when you retrieve more data than necessary in SQL. The larger the data set, the slower the query, and the more resources you waste, which can increase costs, especially in cloud-based databases. So how can you optimize data retrieval? First of all, you have to select only the needed columns. We have already covered why select is inefficient, but it's also important to limit the number of rows returned, not just the columns. Second of all, use limit to control output. Queries that return thousands or millions of rows can drag down performance, so always limit the results when needed. For example, using limit for efficiency. So here, instead of pulling all the customers, retrieve only the latest 100 signups. So here, as you can see, we have a query where you can select customer name from customer details, order by name, and limit is equals to 100. So this ensures that only 100 rows are returned, even if the table has 1000. If you want to skip the first 20 rows and get the next 100, you have to use offset. So if you are using offset, you have to write a query like select customer name from the table, order by customer signup DECD, which is order descending, limit 100, offset 20. So by using this offset, this is useful for pagination when loading data in chunks instead of all at once. Cloud databases like Snowflake and BigQuery help optimize queries by caching results, meaning repeated queries run faster, so you can also use temporary tables to store frequently used query instead of recomputing them every time. Now let's move on to the eighth number of our best practice, which is why you should utilize stored procedure. Imagine if every time you needed to bake a cake, you had to measure ingredients, mix the batter, and follow every step from the scratch. It sounds exhausting. Instead, wouldn't it be easier if you had a pre-made cake mix that just needed a few tweaks? That's exactly what stored procedures does for SQL. They act like a pre-written reusable function that save time, simplify logic, and then also boost performance, especially for frequently executed queries. First of all, it gives you faster execution. Stored procedures compile and cache queries so that they can run much more faster than writing SQL statements. Second of all, it's reusable and automated. So instead of rewriting the same query, you can call a stored procedure whenever you need it. Third of all, it's easier to maintain. Changes to the procedure automatically apply everywhere it's used. So avoid redundant edits. How can you create a stored procedure? First of all, let's say we want to find the most recent customer sign up. So instead of writing the query every time, we can save it as a stored procedure. We can write a query like create procedure, find most recent customer as begin, select max, customer sign up as most recent sign up from 2023 signups. And then we can write end. So now whenever we need this query, we simply execute exec find most recent customer. You don't have to rewrite the SQL, just call the procedure and get the result instantly. So as you can see, just by writing this simple procedure query, we can just retrieve all our data. Second of all, let's talk about adding parameters for flexibility. If you want to filter by store ID, we can modify the procedure to accept a parameter.
For example, we can create a procedure, find most written customers, store ID as begin, select max from sign up, where store ID is equals to name and then end. So now we can pass the store ID dynamically when executing the procedure, which is exec find most recent customer, store ID is equals to, and just name the store ID. Suppose it's 1188. This will make your procedure highly flexible while still being reusable. So basically, stored procedures are a game changer for SQL performance. By compiling, caching, and automating frequently used queries, they speed up execution, reduce redundancy, and make SQL development much more smoother. Now let's talk about the ninth type of best practice, which is why you should normalize your database. So think of your database as a well-organized bookshelf. If books are randomly stacked, finding the right one takes forever. But if they're sorted by genre, author, and title, everything becomes easy to find and retrieve. And that's exactly what normalization does for SQL databases. It will organize data efficiently, making queries faster, reducing redundancy, and improving accuracy. So normalization is important because it keeps data well structured and easy, it reduces redundancy, and it improves performance. So first level of the normalization we are going to talk about is the 1NF, which is no nested data. So have you ever seen JSON objects inside a database column? That's a sign of poorly structured data. 1NF ensures that every value is atomic, meaning it can't be broken down further, that each row has a primary key. For example, instead of storing customer address as JSON, break them into separate columns. As you can see in the table, we have broke this into separate columns. In the branch name, we have CS as well as civil also. So we have atomic data stored like individual data. We cannot use multiple data at the same time. Now let's talk about the second type of normal form, which is this split value field. So if a single column stores multiple values, querying the data gets tricky. 2NF ensures that each value has its own row while still being linked to the primary key. For example, instead of storing multiple phone numbers in one field, separate them into a new table linked to the customer ID. Now let's talk about the third type of normal form, which is the 3NF, which has remove column dependencies. Think back to the high school geometry. Remember the transitive property: if one column depends on another, we will move it to a separate table. In a similar way, in a customer table, storing zip code and state together is redundant. Instead, move zip code to a separate table and then link them to the state. In this way, if a state zip code changes, you only update one table, not every customer record. So while higher normalization level exists, most databases don't require them unless handling very complex relationship. Sticking 3NF is usually enough for efficiency and performance. Now let's talk about the 10th type of practice, which is why monitoring query performance is very important. Imagine you're driving a car but never check the speedometer, fuel gauge, or engine health. You wouldn't know if you are wasting fuel, driving too fast, or if your car is about to break down. That's exactly what happens when you run SQL queries without monitoring their performance. You have no idea which queries are slowing down your database or costing you extra resources. So why is monitoring query performance matters? Because it identifies slow queries. You won't know which queries need optimization if you never check their runtime. Second of all, it saves costs in cloud databases, so reducing execution time can significantly cut cloud resource cost. Third of all, it prevents system slowdown. Poorly optimized queries can drain server performance and it can impact user experience. Now let's talk about the tools for monitoring query performance. First tool is query profiling. This technique helps analyze query runtime, number of rows returned, and execution ordering to identify bottlenecks. The second one is query execution plans. These show how SQL queries are processed, revealing which operations takes the most time and which improvements can be made. Third is database logs and server monitoring. Checking logs can uncover slow queries, high resource consumption, or external applications affecting performance. Now let's talk about the example. Let's say you have a slow query and you want to analyze its performance. You can use MySQL explain statement. Explain select customer name from customer where city is equals to, let's suppose it's New York. This will show you how MySQL processes the query, which indexes are used, and where the potential slowdowns are happening. Regularly check your databases, slow query, and execution plans. So if a query takes too long, don't ignore it. Optimize it. A few small tweaks can make it a huge difference in performance and cost savings.
You can't optimize what you don't measure. So by monitoring SQL query performance, you can fix slow queries, improve efficiency, and then also reduce unnecessary cost, keeping your database running at top speed. Now let's talk about the 11th type of best practice, which is why you should use union all instead of union. Imagine you're merging two guest lists for an event. If you use union, you are double checking every name to remove duplicates before finalizing the list. But if you use union all, you simply combine both lists as they are, faster, simpler, and without extra processing. That's exactly how union all works in SQL. It joins two datasets without checking the duplicates, making it much more efficient than union. So basically, union combines results from two tables and removes duplicates, which takes extra processing time. Union all combines results without checking for duplicates, making it faster and much more efficient. Let's look at an example. Union versus union all in action. So here we have union. It's slower because it removes duplicates. So try avoid using a union. We have a query like select customer name from customers and we are using union. Second of all, while we are using union all, we have a query like select customer name, union all. So why is this best for performance optimization? It's best because it specially removes duplicates which doesn't matter or which can be handled later. If removing duplicates isn't necessary, then always use union all because it's faster, reduces processing time, and improves SQL performance. So if you must remove duplicates, try handling them later using distinct instead of forcing union to do the extra work upfront. Now let's move on to the last part of our best practice, which is why you should leverage cloud database specific features. So imagine you're using a high-end smartphone, but instead of exploring its built-in AI features, fast charging, or cloud sync, you are only using it for basic calls and text. You are missing out on a powerful tool that could make your life easier. And that's exactly what happens when you don't take advantage of cloud database specific features. Cloud providers like Snowflake, BigQuery, and Redshift come along with built-in optimization and custom SQL function designed to improve performance, simplify queries, and handle data more efficiently. So why you should use cloud specific features? Because it's optimized performance, built-in functions, and cost efficiency. Now let's look at an example, Snowflake's JSON function. So Snowflake has special function for passing JSON data directly in SQL, something that would be harder and slower in traditional databases. So let's suppose the query is select JSON column customer name, string as customer name, JSON column, and here from orders. So instead of writing complex parsing logic, Snowflake lets you query JSON fields like normal columns, saving time and improving performance. Every cloud provider, AWS, Redshift, Google, BigQuery, Azure, Snaps, or even Snowflake has unique optimization. Check their documentation for performance tuning tips, built-in functions, and query optimization strategies to get the most of your cloud database.
So grab your laptop, follow along, and let's unlock the potential of SQL for data analysis together. So without any further ado, let's get started. So welcome to the demo part of the SQL project. So in this, we will do digital music store analysis. Okay, so this SQL project is for the beginners. So what you will learn from this project, main thing is like, so what's the objective of this project, this particular project? So this project is for beginners and will teach you how to analyze the music playlist database, and you can examine the dataset with SQL and help the store understand its business growth by answering simple questions. So as you can see, I will show you. So I have three set of questions. First one is easy, okay, and the second one is moderate, and the third one is advanced level. So we have three set of questions: easy, set, moderate, and the advanced. Okay, so every set is of three questions, I guess. Yes, in every set there is three questions. So okay, in easy one there are five. So we have 5 plus 3 8, 8 plus 3 11. We have 11 questions to solve. Okay, from this you will understand how you can analyze data with SQL, how you can extract something from database, how you can store something like this. Okay, so, and one more thing, I will show you the schema of the particular data set which we will soon we will restore. So we have the tables in this: artist, album, track, media type, genre, invoice line, invoice, customer, employee ID, playlist, track, and all. Okay, so this is the music playlist database schema. So without any further ado, let me create one database. So here, just right click, create database. Okay, here I will write music. Okay, and save. So now our database is created. Okay, so if you will go to schema and if you go to tables, there is no tables in it. Means there is database, but nothing is there. The database is empty. So now what I will do, just go to your database, just right click. Here you can see the restore option. Okay, restore. So format as it is, then here file name, go to this music store database. I will put this database link in the description box below, don't worry. Open, then restore. Process started, process complete. Some people will face this that the process is failed or something. Okay, so for that what you have to do, just go to file, then preferences. Here you have to set the path, just binary path. Okay, see I am using the 15th version. Okay, so I have set the path here also and this also, but you have to set this path is important. Okay, if you will not set this edv advanced server path, it's fine, but this path is most important. Okay, but for the future reference I have added on the both. So what you have to do, you have to just see where you will find this path. Just go to this PC, then OS, then program files. Here you will find this PostgreSQL. Then I'm using C15, 15, then bin. So you have to copy this path, right? You have to just copy it and paste it here. And then select this one. After that, just save. You won't find any failed thing. Okay, the process will complete. Right, so now let's move forward and see the tables. Okay, it's still empty. Why? Just refresh it. See, now you can see all the columns in my tables. Okay, so what I will do for the checking, I will run one query here. Okay, let me close it. Okay, I will write here select star from album. Okay, let me run it. So now, as you can see here, my table is working fine. Everything seems good. Okay. So now what we will do, we will solve question one by one. Okay. So the first question, let's see the first question, easy one. Who is the senior most employee based on job title? Okay. Who is the senior most? Okay. So I will write here like the first question is who is the senior most employee based on job title. Okay, so this is our question. So we know we have the table name called employee, so we will select that table first. So I will write here select star from employee. So you should know which table should to select. Okay, so here as you can see in this question, there is word employee. Who is the senior most employee based on the job title? Most employee means employee is an employee table. right? So I will run it. Okay. So what I will do, I will just select this and run it. Okay. So now you can see there in employer, there is employee ID, last name, first name, title, report levels, birth date, hire date, and all the details of the particular. Okay. So we will do, so there is one more thing. You can see the levels. Okay, level 1, level 2. So we have to write who is the senior most employee based on the job title. So what I will do, I will write here order by levels in decreasing order. Okay. So first I will do. So now you can see the levels are in the descending order from senior to this. Okay, L7 to L1. So what we want only one employee name. So what I will write here, limit is 1. Okay, I will copy this and I will done it. Okay, so now you can see the last name is Mohan. Sorry, Mohan Madan. This is last name, this is first name. So Mohan Madan is the senior most employee based on the job title. So question first is done. So the second question is which countries have the most invoices? Okay, first I will write down the question. Which country has the have the most in have the most invoices? Okay, so for this what we have to do, see, just first check. First we have to check from which table we will get the solution. So here you can see the word invoices. Okay, so we have one table, invoice and invoice line. We have to select it from this. Okay, so I will write here select star from invoice. Okay, so we have customer ID, invoice date, billing address, billing city, billing state, and everything. So here you can see we have the billing country as well. Okay, because we need the country name, so we will take this column, right? So I will write here, so I will write select, change it, select count star from name, select star billing country from invoice group by billing country. So why I am doing this group by? Because as you can see, we have USA multiple times, USA, then Canada also, then other countries as well. So from this I will get only the one. Okay, I will group them and I will get the one. Fine. So from this we will get the count. So after this I will write order by. So here I will write C descending. Okay, let me run it. So now you can see the billing. This is the billing order. Okay, so or you can say the invoices. USA got the 131 and Canada 76, Brazil 61. If I will write here again that limit 1, what I will get? See, USA. We got the USA. So USA is the country which have the most invoices. Okay. If you will remove this limit, so you will get the other country as well. Second in Canada, third is Brazil, and like this. Okay. And the third question is, what are the top 3 values of total invoices? Okay, again we need the same table. Okay, first I will write the question. Third question is, what are the top 3 values of total invoices? Top 3 value of total invoices. Okay, I know I can just solve this question by the second one, but I want to do it from the starting. Okay, so first I will select stuff from invoice. Let me run it. So first we will sort the data. Here I will write order by total, because the last, this is a table name. Okay, total in the descending order. So first I will select. So we need just the top 3. So first I will do, everyone know, limit 3. Okay. Okay. So here I have wrote this star. That is why it's giving me all the values. If I want this, only this value, so I can write select total from invoice order by this. Okay, I will write and run it. So I have this total like 23.75999 and 19.8 and 19.8. So these are the top 3 values of total invoices. Okay. So here the fourth question is, which city has the best customer? We would like to throw a promotion music festival in the city. We made the most money. Write a query that returns one city that has the highest sum of invoice total. Return both the city name and sum of the all invoice total. So let me write the question first. Okay, I am writing question for your better understanding. Okay, question fourth. Which city has the best customers? We would like to throw a party or promotional music festival in this city. We made the most money. We made the most money. Write a query that returns one city that has the highest sum of invoices total. Return both the city name and sum of all invoices. Okay. So we have this question. Okay. So which city has the best customer? We would like to throw a promotional music festival in the city. We made the most money. Write a query that returns one city that has the highest sum of invoice total. return both the city name and the sum of all the invoices. Okay, so first what we will do, we will select staff from invoice. Okay, sorry, we'll select this. Okay, so first we will select the billing city. We have to focus on this and the total. In this two table we have to just focus on. Okay, so here I will write sum of total as invoice total, comma billing city from invoice. So this time we will do group by billing city because we need the city names. Or then I will add order by invoice total in the descending order. Seems good. Select sum total as invoice total billing city from invoice billings. Okay, so let me select this. So as you can see, the highest billing city is Prague, and the best customer is from the Prague city. Okay, so which city has the best customer? Obviously Prague, you, or sorry for the mispronunciation. Okay, so this is how we have solved our fourth question as well. Okay, because written both the city name and the sum of all the invoices. This is the city names and the invoice total. Okay, moving forward to our fifth question, which is again the long one. Who is the best customer? The customer who has spent the most money will be declared the best customer. Write a query that returns the person who has spent the most money. Okay, so I will write here who is the best customer. The customer who has spent the most money will be declared the best customer. So write a query that returns the person who has spent the most money. Okay, yeah, so who is the best customer? The customer who has spent the most money will be declared as the best customer. Write a query that returns the person who has spent the most money. Okay, so for this we have to take this customer table data. Okay, so I will write as select staff from customer. Okay, I will select this and I will run it. Okay, so this is our table data of customer. Okay, so we have the country, fax, emails, state, city, address, last name, first name. Okay, so as you can see, there is nothing like no detail of invoice or the money, okay, which have spent by the customer. So what we will do, we will look at our schema. So now what we can do, if we can't solve a particular question from with one table, we have to join the table to the other table. So here we have to join customer table to invoice table. So in this you can see there is customer ID and here also customer ID. So on the basis of customer ID we can join the join both the table, and with the help of this total we will sort out the that guy, okay, that customer, right? So for this I will write here select customer dot customer id comma customer dot first name comma customer dot last name, because we need the full name of that guy, comma sum invoice dot total as total. Okay, let me, can we pause? Okay, I don't need the search pad, right? Then I will write from customer, okay, my bad, then join invoice on customer dot customer id equals to invoice dot customer id, then I need group by, okay, group by customer dot customer id. After this let me order it by the descending order, so the most spend customer will come up. So I will write here order by total, the descending order, then limit equals to 1. Fine, let me run it. Let's see what output should become. Okay, some error is coming. Limit, okay, sorry. Okay, so as you can see, the customer ID is 5. The first name is R, the last name is Madhav. R Madhav spent the highest value 144.540000 and 2. So who is the best customer? Madhav, R Madhav, sorry, my bad, R Madhav, right? R Madhav has spent the most money. Okay, so this is how we are done with our easy set of questions. Now let's jump into the moderate one. Okay, so let me write the question first for the moderate. So I will write here moderate questions. So these analytics skill help you in the data analytics to become a data analyst or to become a data scientist. Okay, so the question first is write query to return, okay, write query to return the email, query to return the email, comma first name, comma last name, and genre of all rock music listener. Okay, then return your list ordered alphabetically by email starting with A. Okay, let me get to this. Yeah. So for this, okay, let me open this first. Yeah, okay, fine. So first, what I will do. So now in this question, as you can see, we have to return the email, first name and the last name and the genre of all rock music listener. So if you will see, select star from customer. Okay, let me run this. And if I will see, there is no column name genre. Okay, if I will show you the schema of this, see the genre is here and the customers is here. Okay, we need the first name, last name and the email id and the genre. Okay, and the genre is will should be rock. Okay, so what I can do, I can connect this genre with track, then because here is also track id and here is also track ids, then track id to invoice line, then invoice line to invoice, then invoice to customer with the customer id. Okay, this pattern I have to follow, right? So for this I will write select, just copy this. Okay, just follow these steps. Select distinct email comma first name comma last name from customer, join invoice on customer dot customer id equals to invoice dot customer underscore id, then join invoice underscore line on invoice dot invoice id. Okay, then invoice underscore id, then where track id should be in. Here I will do select track id, okay, from track, then join genre, yeah, on track dot genre dot id equals to genre dot genre id, where this is important, genre name like rock, because we need, as you can see, write a query to return this is this and genre of all rock music listeners. Okay, rock, right? Then order by email. Okay, before that let me show you this track. Okay, select star from track. Okay, let me show you this table. You can see the name, the track id, album id, media type, genre id. Okay, then the composer, this bytes and the unit price, right? Okay, so you know this, we have then this customer. Okay, invoice ID we took, right? Fine. So now what I will do, I will just select this and okay, invoice ID. Okay, invoice ID is ambiguous. Here I have to write invoice line dot invoice ID. Okay, let me now run. Let me run it. Okay, one more. Join genre on track dot genre ID. There is entry for table genre, but it cannot be referenced from this part of the query. Okay. Okay. As you can see here, the table name is genre underscore ID. That was the mistake. Okay, one more. Genre dot name. Spelling mistake. Sorry, my bad, guys. No issues. It happens. Okay. Now you can see we have all the people who love rock music, and we have the email, then first name, then the last name. See, Aaron Mitchell, Alexandra Roca, Astrid Gruber, like this, Camille, Dan, Edward, like this. Okay. So there are total 59 people who loves rock music from this particular database. Okay. Now question 2. Question 2 is, first let me show you. Let's invite the artists who have written the most rock music in our data set. Write a query that returns the artist name and the total track count on the top 10 rock bands. Okay, so let's invite the artists who have written the most rock music in our dataset. So write a query that returns the artist name and the total track count of top 10 rock bands. So now what we need here, okay, let me do this. So what we need here, so let's invite the artists who have written the most rock music. First we need the artist, okay, and the second is rock music, then we need track, okay, and the total track count means we will get from the track. So here we have track column, track table, and we have the artist. So now let's see the schema part. So we need genre, okay, for the rock music. Then we have to combine this with the track ID because genre ID is there. From track ID to album because we need the artist name. See, artist ID and artist ID. So this is how we have to connect the table. Now, so for this, I will write here. Just follow the steps. Select artist dot artist ID, comma artist dot name, comma count artist dot artist ID as number of songs, because we need the total number, okay, who have written the most rock music. Number of songs, fine, from track. Now we have to join album on album dot album id equals to track dot album id. Okay, then we have to join the artist with artist id. So join artist column on the basis of artist id equals to then album to album dot artist id. Okay, so here I have joined the artist to the album column table. Okay, then I have to join genre to the track table with the track table. Okay, so here I will write join genre on genre dot genre id equals to genre id. Okay, sorry, track id, track dot genre id. Okay, so here I will write where genre dot name like rock. Okay, rock, fine. Then I will group by group by artist dot artist id. I need the id as well. Then order by number of songs in the descending. Then limit, I need only 10 rock bands. Limit will be 10. Let me run it. Okay, let me run it. Okay, album. Okay, now let me run it. Okay, now you can see this guy, Led Zeppelin, artist ID is 22 and wrote the most songs 144. Then U2 122, Deep Purple 92, then this, then this. Okay, so this is how we solved our second question, right? So now the third question. Okay, return all the track names that have a song length longer than the average song length. Return the name and the millisecond of the each track ordered by the song length. Okay, so first I will write this question. Q3. So return all the track names that have a song length longer than the average song length. Okay, first we return all the track names that have the song length longer than the average song length. Okay, then return the name and milliseconds for each track. Fine. After that, order by the songs with the longest song listed first. Okay, fine. So we have to return all the track names that have a song length and the okay. First we will find the total length of this songs, then we will do the where then we will put the where clause to find out the particular longest song. Okay, so this will do in the two step. First we will find the average track length. Okay, so I will write here select name comma milliseconds. Okay, from track where milliseconds here I will write select average from the millisecond. Okay, then I will write here as average track length okay, then here I will write from track. After this I will write here order by milliseconds. I need in the descending order. Okay, so let me run it. So now you can see first I will read it again. So return all the track names that have a song length longer than the average song length. Return the name and the millisecond for each track. Order by the song with the longest song listed first. Okay, so this is the longest song. Okay, so we have all the songs which are the longer than the average song length, right? So now moving forward, we have jump into the advanced set of questions. Okay, so now we will do the advanced questions. Okay, so let's see first. Find how much amount spent by each customer on artist. Write a query to return customer name, artist name, and total spends. Okay, so first we will write down the questions. Okay, then question one. Okay, find how much amount spent by each customer on artist. Write a query to return customer name, comma artist name, comma total spend and total spent. Okay, so how to solve it? So first find which artist has earned the most according to the invoice lines. Okay, first let me show you the schema. Okay, we need the artist name, we need the customer name, and we need the total spent. Okay, with the invoice line, because the quantity should be there. Okay, so first we'll see how to join these three table: artist table, customer, invoice, and invoice line, like this. Okay, this is how we will join the table. Fine. So now I will tell you the steps. So first, find which artist has earned the most according to the invoice line. Okay. The second, now use the artist to find which customer has spent the most on the artist. So for this query, you will we need to use the invoice line, track, customer, album, and the artist table. So just remember, this one is tricky because the total spent in the invoice table, right? Let me show you. So total spent on the invoice table might not be a single product. So that is why I was saying we need the quantity. So we need the invoice line table to find out how many each product was purchased. Then we have to multiply this by the price of each artist. Okay, fine. So now, so this is a lengthy one. I will just write it for you and get back to you. Yeah. So this is how you can see. Okay, group by 5. I have wrote this. You can just write it like this. Okay, we took artist name, then sum of invoice line, unit price into invoice line, the quantity that I showed you. Okay, we have multiplied this total with the quantity. Okay, then we joined the table track with invoice, album with track, artist with album. Okay, so now let's run it. Yeah, so now you can see this Hugh O'Reilly Queen, amount spent 27, the customer ID is this. Okay, then Nicholas Schroeder, then 18. Okay, we have the everything. Okay, customer name, artist name, and the total spent. This is the customer name, the artist name, and the total amount they spent. Fine. So now let's move forward to the next one, which is okay. Okay. Yeah. So the second one is this. We want to find out the most popular music genre for each country. We determine the most popular genre as the genre with the highest amount of purchase. So write a query that returns each country along with the top genre. For countries with the maximum number of purchases shared, return all the genres. Okay. So what I will do first, I will write the question. Okay. So okay. Question 2. So find out the most popular music genre for each country. Okay, determine the most popular genre as the genre with the highest amount of purchase. Okay, then write a query that returns each country along with the top genre for countries where the maximum number of purchase. Okay, so so there are two parts in this question. First, the most popular music genre, and the second is the need of data at the country level. Okay, so we can do it from the two methods. Okay, using CT and using the recursive method. So I will use the using CT. I will do this CT. So for that you have to write with popular genre as select count invoice line dot quantity, okay, as purchases, comma, customer dot country, comma, genre dot name, comma, genre dot genre id, okay. Then here I will write row underscore number, then I will write over partition by customer dot country, order by count invoice line dot quantity, okay, into descending order, as row number, okay. So from invoice line, okay, yeah. So here I will join the tables, join invoice on invoice dot invoice id equals to invoice line dot invoice id, okay. Then again join customer on customer dot customer id dot id underscore id equals to invoice dot customer id. Fine. Then again we have to join track on track dot track id equals to invoice underscore line dot track underscore id. Then join genre on genre dot genre id, okay. Then track dot genre id, okay. Then I will do group by 2, 3, 4. Then I will do order by 2, then ascending order, and then 1 to descending order, okay. Then now I will write select star from popular genre where row number is less than greater than 1, okay. Now let me run it. So now you can see we have Okay, let me read it. So we have to find the most popular music genre for each country. Okay, so now we have the country name Argentina. The most popular is alternative and punk. Genre ID is this. Row number is this. Okay, purchase is this. Then the Australia, this rock. Okay, certain rock, USA rock, and everything is there. Right. So this is how you can find the most popular music genre for each country. Okay. The last question is there here. Now the last question is, write a query that determines the customer that has spent the most on the music for each country. Write a query that returns the country along with the top customer and how much they spent. Okay, for the countries where the top amount of spent is shared, right? And they provide all the customer who spent this amount. Okay, so for this, this is like a similar to this question. Okay, so there are two parts in this question. Find the most spent on music for each country, and the second is to filter the data for the respective customer. It's very easy. Okay, so okay, I will write the solution. Okay, you can check the question from there. Okay, I will write customer with country as I will here select customer dot customer ID comma first name comma last name comma billing country comma sum should be total as total spending, right? Then I will write row number same over. We have also written here, no? Right? The same we have to write here over. Then partition by billing country, order by sum, total, descending order as row number. Okay, so after this I will write here from invoice you have to fetch. Then again the same thing, you have to join the table, join customer on customer dot customer ID equals to invoice dot customer ID. Okay, then here I will write group by I1, 2, 3, 4, okay, that's it. Okay, then I will write here order by 4 ASC ascending order, 5 to descending order. Fine. So now I will write here select star from customer with country where ROW number is 1. Fine. So let me run it. See, we have first name, last name, billing country, total spending, row number, and the customer ID. Let me show you the question. Here, write a query that determines. Okay, let me make it this one. Okay. Yeah. So write a query that determines the customer that has spent the most on the music. So customer, we have the customer name for each country. Write a query that returns the country along with this. So we have the country name with the top customer and how much they spend. We have the total spending. For the countries where the top amount is shared, provide all the customer who spent this amount. Okay, so we have everything here, right? We have this Lewis from Brazil, this, okay, with the customer ID. So this is how you can solve these questions. So till now, I can say you have a good data analytics skills. So for this, I can say this will help you in the interview of data analyst, in data science, or any SQL.
Picture this, you are in an interview and the interviewer asks, can you write a query to find the top 5 sales records? You freeze for a moment, thinking, am I ready for this or not? Don't worry, SQL might sound complicated, but it's actually a super useful tool that lets you interact with databases. Have you ever wondered how all those apps and websites stores and organize their data? Well, that's where SQL comes in. SQL, which stands for Structured Query Language, is a universal language for talking to databases. It's super powerful and lets you do things like pull out specific information, add new data, update existing stuff, or even delete things you don't need. It's basically your magic key to manage huge amounts of information with ease. Exactly. And if you're aiming for a career in tech, whether it's a database administrator, data analyst, or software developer, SQL is a must-have skill. Databases are at the heart of almost every application. So knowing SQL can unlock some really exciting opportunities. Now here's the exciting part. This video is your secret weapon to master SQL interviews. We have packed it with 45 carefully chosen SQL interview questions that cover everything you need to ace those tough questions. So we'll be starting with the basics like how databases work and then diving into advanced query challenges, and by the end you'll be fully prepared to tackle any SQL question thrown at your way. So let's dive in and get you closer to your dream job. So let's get started. So now let's start with a SQL interview question. We'll cover every question starting from basic level to advanced level. So now let's look at our first question, which is very basic. What is SQL? So we all know that SQL stands for Structured Query Language, and it is the language which is used to talk to databases. Think of it like giving instructions to a computer system that stores and organizes data. For example, if you want to find out all the customers who ordered a specific product, then SQL can help you do that with a simple command. You can also use SQL to add new data, like entering a new customer details into a database. If you want to update someone's phone number, SQL has got you covered. Or maybe you want to delete old records that are no longer needed, SQL can handle that too. Here's a quick example. If you want to find all the customers in New York, you could write something like select star from customers where city is equals to New York. So we are using this command to find all the customers in New York. Remember, if you want to find out all the specific data from the table, you have to use the star command. And if you want to add new customer, you can just simply write insert into customers, name, city, and then you can also insert value name, which is John, and you can just enter the specific location. So SQL works the same way across many popular databases like MySQL, PostgreSQL, or SQL Server, which is why it's such an important skill for anyone working with data. So now let's look at our second question, which is what are the different types of SQL commands? So SQL commands are like instructions you give it to a database to tell it what to do. There are different types of commands and each one has a specific purpose. So let me explain these in simple terms. Remember, if an interviewer asks you such questions, simply explain using the proper keywords and use proper definitions and easy language. That's it. So the DDL command we have, which stands for data definition language. It basically defines the structure of the database. For example, if you want to create a table, or if you want to alter a table, or if you want to drop a table. Then we have DML, which stands for data manipulation language. It deals with the actual data in the database. For example, insert, update, delete, all of these things. Then we have DCL, which is data control language. It will manage permissions and access control. So if you want to manage permission or access control, then you have to use this particular type of SQL command, which is DCL, which is grant and revoke. Grant will provide access rights and revoke is used to remove the access rights. We also have TCL, which stands for Transaction Control Language. It will manage transactions in the databases. For example, commit is used to save changes, rollback is used to undo changes, and save point is used to create intermediate points in a transaction. So for instance, in a schema with customers table and an order table, data definition language commands are used to define the table, whereas data manipulation commands, which is select, insert, and delete, it is used to update customer or order data. DCL is used to control access, and TCL, which is transaction control language, is used to manage transactions. That's it. It was very simple. Now let's look at your third question, which is what is a primary key in SQL? A primary key in SQL is like a unique ID for each record in a table. Think of it as a way to ensure that no two rows in a table have the same value. Remember that no two rows must have the same value. It is also a rule that the primary key column can't have empty or null value. So these are the basic criteria for a key to be a primary key. For example, in a table of customers, you have a column called customer ID as the primary key. Then each customer have a unique customer ID like 1, 2, 3 and so on. This makes it easy to identify and retrieve specific customers from database. Here's a simple example. Suppose we have created this table, create table customers, and we have given the customer ID as primary key. We have given name as varchar, the city name as well. So the primary key will ensure that each customer ID is unique, no duplicates are there, no customer ID is left blank, that is there should be no null values, and primary keys are also important when linking tables together. For example, if you have orders table, you can use the customer ID as a reference to connect each order to a specific customer. This helps maintain data integrity across the databases. Now the fourth question is, what is a foreign key? A foreign key in SQL is like a connection or link between two tables. It's just like a field in one table that refers to the primary key in another table. This creates a relationship between the tables and ensures that the data stays consistent. For example, let's suppose you have two tables, a customer table with a primary key called customer ID and a sales table with a field called customer ID, which is a foreign key linking back to the customer ID in the customers table. So here's how it will look like. We have created this table and you can see in this example that suppose we have customers and sales table. So we have used this customer ID in our customer table as well. So here customer ID is the foreign key and in the customer table, the customer ID which we had used is the primary key. So now let's move on to our fifth question, which is delete and truncate command. What is the difference between delete and truncate commands? So delete and truncate commands in SQL both remove the data from a table, but then they work in different ways. Let me break it down for you. The delete command. So what delete command will do is basically, this is used when you want to remove specific rows from a table based on a condition. For example, if you want to delete all the customers from a specific city, then you have to use this delete command. It will allow you to be selective, but it's slower because it logs each row deletion, which also makes it possible to roll back the changes if needed, if you're using transactions. Moving on to truncate command, truncate will remove all the rows from a table at once without allowing any condition. For example, if you just want to remove all the rows just in a one go, you have to use this truncate command. Just simply write this query as truncate table. Suppose the table name is customers. Is much faster because it doesn't log individual row deletions, and it simply clears the entire table in one go. However, you can't roll back a truncate operation in most databases once it's done. So the key differences is delete is for specific rows, truncate is for clearing the entire table. Truncate is much more faster because it uses fewer system resources. Delete can be rolled back if used within a transaction. Truncate usually cannot. Delete logs each row deletion and truncate doesn't. So this was all for this truncate and delete command. So anytime if the interviewer asks you such questions, just simply explain this. Now let's move on to the sixth question, which is what is a join in SQL and what are its types? So this is one of the most important questions you'll be getting to know in the interviews. You'll be asked such questions in the interviews. So basically a join in SQL is used to combine a data from two or more tables based on related column, like a column key that links them together. It's just like connecting pieces of puzzles. Join help you see the bigger picture by merging related data. For example, if you have a customer table and a sales table, you can use the join to see which customer placed which order by linking them through a common column such as the customer ID. So you all know what a join in SQL, and let's discuss its type. So join types are basically there are 4 types of join, which is inner join, left join, right join, and full outer join as well. So what inner join will do is it will combine rows from both tables where there is a match in the common column. Think of it as the overlapping section in the Venn diagram. Only rows that exist in both the tables are included. The left join, or we can call or the left outer join, it will retrieve all the rows from the left table and the matching rows from the right table. Remember, the left join will retrieve all the rows from the left table and only the matching rows from the right table. If there is no match, the result includes null values for the right table's column. Think of it as including the entire left circle in the Venn diagram along with any matches in the right circle. Right join or the right outer join is similar to the left join, but it will retrieve all the rows from the right table and matching rows from the left table. If there is no match, null values are included for the left table column. Think of it as including the entire right circle in the Venn diagram along with any matches on the left circle. Then we have the full join. Full join will combine rows when there's a match in the either table. If no match is found, it includes null or the missing values from the either table. Think of it as combining both circles in the Venn diagram. Everything from both tables are included. Now let's move on to the seventh question, which is, what do you mean by a null value in SQL? It's very easy. Null value in SQL means that a column has no data. It's missing or unknown. It's not the same as an empty string or the number 0. Those represent actual value, while null represent no value at all. For example, if you have a table of customers and one of the row doesn't have a phone number, then the phone number column for that row would be null. See, we have listed this in the table here, you can see. If you do not have any data, just simply write null. So the next question is, define a unique key in SQL. So a unique key in SQL ensures that all values in a column or a combination of columns are unique. That is, no duplicates are allowed. It's like having a rule to make sure that no two rows in a table must have the same value in that column. For example, in a user table, the email column can have a unique key to ensure that no two users can register with the same email address. Remember the key points. Unlike a primary key, a table can have more than one unique key. Unique keys allow null values while primary keys do not. So these are very important to remember. So if you're asked a difference between a primary key and a unique key, just simply say that unlike primary key, a table can have more than one unique key, and unique key allows null values while primary key doesn't. So here is a table we have listed below, that is create table users, and we have given user ID as integer primary key, and then we have email varchar as a unique key. So here the email column is a unique key so that each email must be different. It should not be the same. Now let's look at our next question, which is, what is a database? A database is organized way to store and manage data. Think of it like a digital filing cabinet where information is neatly arranged in tables with rows and columns. Each row represents a record and each column represents a specific detail about that record. For example, a database for a library must have a table for books. Then the rows could represent individual books and the columns could include the book title, author, and the publication year. The main purpose of a database is to make it easy to store, manage, and quickly retrieve data whenever you need it. Databases are used in everything from apps and websites to banking system and e-commerce platform. Now let's look at our question number 10, which is explain the differences between SQL and NoSQL databases. So here's a simple explanation. SQL databases are structured, which means they can store in tables with rows and columns, like a spreadsheet. They follow predefined schema, meaning the structure of a data is fixed and you need to define it before adding any data. These databases are great when you need consistent and reliable data, like for banking system or inventory management. Examples are MySQL, Oracle, MS SQL, PostgreSQL, etc. And SQL databases are also known as RDBMS, which is Relational Database Management System. Let's talk about NoSQL databases. So NoSQL databases are flexible and do not use table. Instead, they can handle unstructured or semi-structured data. So NoSQL database is dynamic, where data is primarily stored in JSON objects, key value pair, graph nodes, etc. They don't have a specific structure. Such databases are mostly not preferred for performing complex query operations, and the examples include MongoDB, CouchDB, Elasticsearch, etc. So now let's move on to question number 11, which is what is a table and a field in SQL? So a table is like a spreadsheet that stores data in an organized way using rows and columns. Each table contains records and the details. For example, a table named employees could store information about employees in a company, whereas a field is a column in a table and it represents a specific attribute or property of the data. For example, in the employees table, fields could be employee ID, name, and department. So here's a simple example of the table. You can see here the fields name, or we can say column, and we also have the records or the rows, we can see that. So in this table, the entire table is called employee. Each row or record stores information about one employee, and each column or field represents specific details like employee ID, name, and the department. Now let's move on to question number 12, which is describe the select statement. Well, the select statement in SQL is used to retrieve data from a table or multiple tables. It's like asking databases, show me this specific information. Here's how it works. You can specify which columns you can see. For example, to retrieve all customer names from a customer table, you can select name from customers. If you want to retrieve all the data, just write this query, select star from customers. Remember, I told you before in the first question, we are using star if you want to retrieve all the data from the table. And if you want to just retrieve from a particular row or a column, just simply write, select name from customers, the field name. You can also apply filters. You can use the where clause to filter the results. For example, you can write select name from customers where the city name is New York. You can also sort the results. Use the order by to sort the data. For instance, to sort customers by the name, you can just write select name from customers and then order by name ASC. ASC means ascending order. So in short, the select statement lets you choose what data you want to see. Now let's talk about what is a constraint in SQL and name a few. So if you ask this question, just simply answer a constraint in SQL is a rule applied to a table that ensures the data stored is accurate and consistent. It also helps in maintaining data integrity by restricting what values can be added or modified in a table. Here are some common constraints: primary key, we have foreign key, then we also have unique key, check, not null, and default. So we have already discussed about primary key. It ensures that each row in a table has a unique identifier and the column can't contain null values. Foreign key links to a column in one table to a primary key in another table to maintain relationship. Unique key ensures all the values in a column are distinct, that is, there are no duplicates. The check ensures that data meets a specific condition before being inserted or updated. Not null ensures that a column cannot have null values. The constraints are essential for maintaining reliable and valid data in your database. Now let's talk about what is normalization in SQL. Normalization in SQL is a process which is used to organize data in a database to make it more efficient and reliable. The goal is to reduce redundancy, which is duplicate data, and ensure data consistency. This is done by splitting a large table into smaller related tables and then linking them using relationship like primary and foreign key. For example, imagine a single table that stores customer details and the orders. If the same customer places multiple orders, then their information like name and address would be repeated for each order. Now, using normalization, you would separate this into two tables. First, we would have customer table, which will store customer details like customer ID, name, and the address. And then we have order table, which will store order details like order ID, customer ID, and the order date. Now, by linking these tables using customer ID, you can also reduce duplication and ensure that any changes to customer details are updated in just one place. Now, let's talk about question number 15, which is how do you use the where clause? It's very easy. So just answer the where clause within SQL queries serves the purpose of selectively filtering rows according to a specified condition, thereby enabling you to fetch exclusive those rows that align with the criteria you define. For example, select star from employees where department is equals to HR. Now let's move on to question number 17, which is difference between union and union all. So union is used to merge the contents of two structurally compatible tables into a single combined table. The difference between union and union all is that union will omit duplicate records, whereas union all will include duplicate records. Very easy. Union will omit duplicate records and union all will include duplicate records. The performance of union all will typically be better than union since union requires the server to do the additional work of removing any duplicates. So in cases where it is certain that there are not any duplicates or where having duplicates is not a problem, then we can use union all. It would be recommended for performance. So now let's move on to the question number 18. So here a table is given below and you will have to say what will be the result of a query. The query is select star from runners where ID not in, select winner ID from races. So the answer is, given the simple data provided, the result of this query will be an empty set. So the reason for this is as follows. If the set is being evaluated by the SQL not in condition contains any value that are null, then the outer query here will return an empty set, even if there are many runner IDs that match winner IDs in the races table. Question number 19 is what are indexes in SQL? Indexes in SQL are just like having a shortcut to quickly find data in a table. Instead of searching through every row one by one, an index creates a sorted structure based on one or more columns, making data retrieval much more easier. For example, you can think of an index in a book. If you're looking for a specific topic, you can go to the index at the back and find the page number instead of flipping through every page. Similarly, in database, an index helps the system quickly locate the rows you need. So here's how it works. If you often search for customers by their name, creating an index will speed up those queries. You can just write create index IDX customer name on customer and then the customer name. The database uses the index to find the row, so you just have to run a query which is select star from customers where name is John, and then you can use the index to find the row with name is equals to John much faster. Let's move on to question number 20, which is explain group by in SQL. The group by clause in SQL group rows with the same values in a column, allowing you to apply functions like sum, count, or average to each group. For example, in a sales table to find total sales by region, you just simply have to write this query which is select region, some amount as total sales from sales group by region. So the group the sales by region and calculates the total for each. It's a quick way to summarize data by categories. So now let's talk about question number 21, which is what is an SQL alias? A SQL alias is a temporary name you can give it to a table or a column in a query to make it easy to read or work with. It's like giving a nickname to something for clarity. For example, if you have a column named first name, you can use an alias to rename it as first name in the query results. You just simply have to write this query as select first name as first name in capital letter, last name as last name from employee. Here the AS keyword assigns the alias and the output will show the columns as first name and last name. Aliases are also useful for tables. So for this, you can just write the code as select E first name from department table. So this shortens table name for easier referencing. Aliases are not permanent, they only exist while the query is running. Now let's talk about the question number 22, which is explain order by in SQL. So you can answer this question like the order by clause in SQL is used to sort the result set of a query based on one or more columns. You can specify each column sorting order, ascending or descending. For ascending, you have to use ASC, and for descending, you have to use DESC. Okay. So just have to simply write this query as select star from product order by price DESC. Now let's talk about question number 23, which is differences between where and having in SQL. The where clause is employed to restrict individual rows before they are grouped, such as when filtering rows prior to a group by operation. Conversely, the having clause is utilized to filter groups of rows after they have been grouped, like filtering groups based on aggregate values. The having clause, it cannot be used without the group clause, whereas the where clause specifies the criteria which individual records must meet the selected query. It can be used with the group by clause. Question number 24 is what is view in SQL? One more important question. So, an SQL view is essentially a virtual table that will derive its data from the outcome of a select query. Views serve multiple purposes, including simplifying intricate queries, enhancing data security through an added layer, and enabling the presentation of targeted data subsets to users, all while keeping the underlying table structure hidden. Now let's move on to question number 25, which is what is a stored procedure? So if you are asked this question, just simply say a SQL stored procedure comprises of pre-compiled SQL statements that can be executed together as a unified entity. These procedures are commonly used to encapsulate business logic, improve performance, and also ensure consistent data manipulation practices. That's it. Now let's move on to question number 26, which is one more important question, which is what is triggers in SQL? A SQL trigger consists of a predefined sequence of actions that are executed automatically when a particular event occurs, such as when an insert or delete operation is performed on a table. Triggers are employed to ensure data consistency, conduct auditing, and streamline various tasks. So you can use insert trigger, update trigger, or delete trigger accordingly. Now let's talk about what are the aggregate functions, and if you know them, name a few. It's very easy to answer. Aggregate function in SQL perform calculations on a set of values and return a single result. At first, we have minimum, which will get the minimum value from the resultant set. Then we have the max function, which will give you the maximum value from the resultant set. The sum will give you the sum of values from the resultant set. Average will give you the simple average of the resultant set. And the count will count of numbers records from the resultant set. Now let's talk about question number 28, which is how do you update a value in SQL? The update statement serves the purpose of altering pre-existing records within a table. It involves specifying the target from the update, the specific columns to be modified, and the desired new values to be applied. For example, if you want to update, you can use query like update employees, set salary is equals to 6,000 where the department is IT. Now we'll be moving on to some intermediate SQL interview question and answers. So one of the question is, what is a self-join and how would you use it? I would like to repeat again, these join types of question is very important. These are often asked in interviews. So talking about what is a self-join in SQL is a type of join where a table is joined with itself. It's useful for comparing rows with the same table or exploring hierarchical relationship, such as finding employees and the managers in an organization. So imagine if you have an employee table, so you have employee ID, name, and the manager ID. So if you want to find each employee and the manager, you can use a self-join. you can just simply write a query as select ename as employee, mname as manager, from employee, left join employees on manager. So I've already discussed with you before what is the meaning of left, right, and self join. So here the table joined with itself using manager ID to link each employee to the manager. A self join is helpful for comparing rows in the same table or working with hierarchical data. So now let's move on to question number 30, which is explain different types of joins with example. At first, we have inner join. The inner join will gather rows that have matching values in both the tables. Then we have the right join. It will gather all the rows from the right table and any matching rows from the left table. Left join will gather all the rows from the left table and any matching rows from the right table. And the full join will gather all rows where there is a match in either table, including unmatched rows from both the tables. Very easy. Now let's move on to question number 31, which is what is subquery, and provide it using an example. So subquery basically refers to a query that is embedded within another query, serving the purpose of fetching information that will subsequently be employed as a condition or value within the encompassing outer query. So you can just use this query, which is select name from employees where salary is greater than select average from salary from employees. Now the next question is how do you optimize SQL queries? So basically, the answer to this question would be something like SQL query optimization involves improving the performance of SQL queries by reducing resource usage and execution time. Strategies include using appropriate indexes, optimizing query structure, and avoiding cost operations like fully table scans. Now let's talk about question number 33, which is what are correlated subqueries? It's a type of subquery that makes reference to columns from the surrounding outer query. This subquery is executed repeatedly, once for each row being processed by the outer query, and its execution depends on the outcomes of the outer query. Now we'll be talking about what is a transaction in SQL, and it's very important. One of the most important questions asked every time in SQL interview questions. So basically, a transaction in SQL is a group of one or more SQL commands that are treated as a single unit. It ensures that all the operations in the group either succeed completely or fail entirely. This guarantees the integrity of the database. Imagine you're transferring money from your bank account to a friend's account. Then the bank first deducts the amount from your account and then it adds the same amount to your friend's account. These two steps together form a transaction. If one of these steps fails, example, the system crashes after deducting money from your account but before adding it to your friend's account, then the entire transaction is rolled back, meaning no money is transferred and the database returns to its original state. So you can also explain this question with the help of example that would be more, clear to the interviewer. Now let's talk about what are ACID properties in SQL. So basically, ACID stands for atomicity, consistency, isolation, and durability. And these are key properties that ensures database transactions are reliable and maintain data integrity. Atomicity, you can think of it as all or nothing. A transaction is a single unit of work. If any part of the transaction fails, then the entire transaction is rolled back and no changes are made to the database. For example, if you're transferring money between two accounts, either both the debit and credit operations happen or neither does. The second we're going to talk about is consistency. The database must always be in valid state. A transaction takes a database from one valid state to another, following all the rules and constraints. For example, if a transaction adds a record that violates a rule, like a duplicate primary key, then the transaction fails, keeping the database consistent. Isolation, transactions don't interfere with each other. Even if multiple transactions are running at the same time, each transaction works as if it's the only one happening. Example, if two people are updating the same record, then one transaction will wait until the other is complete. Talking about durability, once a transaction is committed, it's permanent. Even if there's a power outage or system failure, the data is saved and it won't be lost. After you complete an online purchase, the transaction is stored securely even if the server crashes immediately after. So this was for the asset properties. And now we'll be moving on to our next question, which is how to implement error handling in SQL. Error handling in SQL is a process to manage and respond to errors that occur during query execution. Different database systems have specific ways to handle errors. In SQL Server, the try-catch block is commonly used. The try block contains the main operation, while the catch block handles errors if they occur. For instance, in a transaction, you can use rollback in a catch block to undo changes if something goes wrong. Similarly, in Oracle, the exception block within PL SQL is used to handle errors. If an error arises, the exception block executes, rolling back the transaction and then logging the error message. By implementing error handling, you ensure that operations fail gracefully without corrupting data, making the database operations more reliable and secure. Next question, which is describe the data types in SQL. SQL supports various types of data types which define the kind of data a column can hold. These are broadly categorized into numeric, character, data type, and binary types. So we have numeric data types like integer, float, then we have character string like char, varchar. We also have Unicode character string like encat, enttext. Then we have binary, which includes binary image, date and time, which includes date and date and time. Then we also have some miscellaneous data types, which is XML and JSON. So the next question is explain normalization and denormalization. Often this question is asked in this way also, or it could be asked something like explain the difference between normalization and denormalization. So to answer this, you have to just simply explain what normalization is, which I have already discussed before. Once again, I'm saying you normalization and denormalization are ways to organize data in a database. Normalization is all about breaking big tables into smaller ones to remove duplicate data and improve accuracy. For example, instead of repeating customer details in every order, you create one table for customers and another for orders, linking them with a key. Denormalization, on the other hand, is when you combine or duplicate data to make it faster and retrieve. For instance, you might add customer details directly to the order table so that you don't need to join tables during a query. Normalization helps you space and maintain consistency, while denormalization makes data retrieval quicker depending on what the database needs. Let's move on to the next question, which is what is a clustered index? It's very easy. Just simply answer by saying that a cluster index in SQL determines the physical order of the data rows in a table. Each table can have only one clustered index, which impacts the table's storage structure. Rows in a table are physically stored in the same order as the clustered index key. Now we have next question, which is how do you prevent SQL injection? So talking about this question, SQL injection is a security risk where attackers insert harmful code into SQL queries, potentially accessing or tampering it with your database. To prevent this, you can use parameterized queries or prepare statements to handle user input safely. You can validate inputs to allow only expected values, use stored procedures to separate logic from data, limit database permission, and escape special characters. These steps help you secure that your database is free from SQL injection attacks. The next question on the list is explain the concept of database schema. In SQL, a database schema functions as a conceptual container for housing various database elements such as tables, views, indexes, and procedures. Its primary purpose is facilitate the organization and segregation of these databases elements while specifying their structure and interconnections. The next question is how is data integrity ensured in SQL? Just simply answer by saying that data integrity in SQL is ensured through various means, including constants, example, primary keys, foreign keys, check constants, normalization, transactions, and referential integrity constants as well. These mechanisms prevent invalid or inconsistent data from being stored in the database. Question number 42, which is what is an SQL injection? We have already discussed about how we can protect our data from SQL injections. So now let's discuss what is basically a SQL injection. So SQL injection in cybersecurity attack that involves insertion of malicious SQL code into applications input fields or parameters. This unauthorized action enables attackers to illicitly access a database, extract confidential information, or manipulate the data. The next question is, how do we create a stored procedure? You use the create procedure statement to create a stored procedure in SQL. A stored procedure can contain SQL statements, parameters, and variables. So here's a very simple example. You can just simply create by writing this query as create procedure, get employee by ID, at employee ID integer as begin, select star from employees where employee ID is equals to at employee ID. And then you just have to write end. That's it. So next question is, what is a deadlock in SQL and how it can be prevented? One more important question often asked in interview. So you have to answer something by saying that a deadlock in SQL happens when two or more transactions are stuck because they are waiting for each other to release resources. It's just like two people trying to go through a narrow door at the same time, each refusing to step back and let the other pass. Transaction A locks table 1 and waits to access table 2. Transaction B locks table 2 and waits to access table 1. This is just a simple example. So we can see that both the transactions are waiting for each other, neither can proceed, creating a deadlock. So it's very simple. And how we can prevent this deadlock is by locking hierarchies. Always access resources in the same order so that transactions don't block each other. Timeouts. Set a time limit for transaction to wait out for the resources. You can also use deadlock detection and resolution system to detect deadlocks and cancel one transaction and let the other proceed. Now let's move on to a last question on the list, which is difference between in and exist. In basically works on list result set. It doesn't work on subqueries, creating a virtual table with multiple columns. Compares every value in the result list. Performance is comparatively slower for large result set of subquery. Whereas the exist works on virtual tables, it is used with correlated queries, exist comparison when match is found, and the performance is comparatively fast for larger result set of subquery. So guys, that's it for this video on the top 45 SQL interview question asked in SQL interviews.
And with that, we have reached to the end of this session on the SQL Full Course for beginners. Should you need any assistance or any other resources like code documentation, datasets or data tables, or PowerPoint presentations and others, please do let us know in the comment section below and our team of experts will be happy to help you as soon as possible. Until next time, thank you for watching and keep learning. Stay tuned for more from Simplilearn.